Hello, everyone. That was a really nice intro. Welcome from my side, everyone, for joining the .NET Days here. I'm Martin, one of the dev advocates here at JetBrains. We have Matt as well on screen. Hello, Matt.
Hello there. Yeah, I'm also one of the dev advocates, and hello from my side.
Yeah, we are joining from, I'm in Belgium, Matt is in the UK. So if you're in the chat and you are joining us here today as well, let us know where you are from, because we kind of want to get a feel for where everyone is tuning in from. Our first speaker, but we'll talk about that in a minute, is from Australia, so that's even further. So if you can do better than that, just let us know in the chat. Welcome to .NET Days Online. This is the fourth time we are doing this event. It's 2 days of sessions on .NET, shorter sessions, longer sessions with presenters from all over the place. We have C# as a topic, ASP.NET, Blazor, REST, GraphQL, gRPC, lots of things really. And then on Thursday, we will have Game Dev Day as well. That's a first, where we will talk about Unreal Engine, about Unity and things like that. The cool thing there is I have no idea how to program games, but I'm still interested in joining that one. So definitely make sure that you stick around for that one as well. Let's have a quick look at the agenda for today. So this is the website. If you're watching on YouTube, you will also see in the comments below what the agenda is for today. If you have the website, just search for JetBrains.NET Days Online and you will have a full agenda with more abstracts and all of the things that you might be interested in. So today and tomorrow, .NET Days Online, and Thursday we will have Game Dev Online. We will kick off the day with James Turner, who will be talking about maximizing algorithm performance. And I've been going through the abstract a little bit. And that's quite an interesting one because there's lots of pointers and all kinds of performance magic under the hood there. So I'm really looking forward to that one. Matt, do you have a favorite session for the next days?
For the next couple of days, well, I'm very much looking forward to Games Dev Day, I've got to say. I mean, I do a lot of work with the Unity and Unreal things inside Rider, and this is the first time we're doing Game Dev Day, so I'm very much looking forward to that. And as you say, you don't necessarily have to be working with games to get the most out of it, I think. So I'm looking forward to that day. We've got a lot of good things coming up. I'm looking forward to that. As you're scrolling through there, the Spectre.Console one, Khalid talks a lot about Spectre.Console. I know he's a bit of a fan of that there. So I'm looking forward to that one. But there's tons of great talks, really. So, yeah, all of them. I'm going to be sat here watching them all, so it's going to be great.
Absolutely, yeah. I was also going through the agenda. And it's really all talks I want to see. So it's going to be 3 long days.
Yeah.
Also in the chats, I see a lot of places. There's Japan, there's Netherlands, there's Georgia, Brazil, Poland. Who is going to stick around for the entire 3 days? I'm also interested in that. So just
time
throw it in the
could
chat
hurt
and we'll
there.
see. Yeah. All right. Maybe if you're not sticking around for the entire 3 days, this is also interesting to know. We are recording the sessions. Actually, the place where you are watching from right now on YouTube. If you visit the same URL again, you will see the sessions afterwards. They are being recorded and all of that. But I think that's enough of an introduction. So let's bring in our first speaker. James, I hope you're ready because we are bringing you in. All right, there you go.
No,
hey,
I'm not
James.
ready.
Too late now.
Yeah.
How's it going? Hope that talk's done.
Oh, yeah, I think it is. Wasn't
Great.
polishing at the last minute.
Always. That's the way you got to do these things.
Yeah, exactly. So James, welcome. You are kicking this off, so I hope you're ready. We have lots of viewers right now, so this is probably the biggest audience that you will get this afternoon.
Yep.
With that, I will bring on your slides and let you introduce the talk and yourself as well. So good luck.
Hey everyone, as you might be able to tell from the title of this talk, it's about algorithms, it's about performance, it's about Levenshtein distance. I have a lot of things to cover, so we're going to skip this slide. Performance, it can be kind of a funny subject depending on what you're working on. because improving performance can be limited to just better database queries or throwing some caching at the problem. But for a different set of problems, performance falls more into what algorithms you use to process data and how much memory you're allocating. This talk focuses more on the latter, being smarter with algorithms and taking advantage of the features that are available to us in .NET. The algorithm I'll be going through today is Levenshtein distance, and my journey to push it to its performance to the extreme. Levenshtein distance tells us how similar two strings are by returning a value that represents the number of operations needed to transform one string into the other. The smaller the distance, the more similar the two strings. If you know your big O notation, though, you'll see this algorithm is pretty inefficient. In my case, I wanted to use Levenshtein distance between two web pages at a different point in time. So after stripping all the HTML and anything else out of the way, I could be left with a few thousand characters to tens of thousands of characters. So I had a lot to process. To get an understanding, though, of the performance optimizations that I can even talk about with this, it's important for me to walk through how you'd even typically calculate Levenshtein distance. So let's walk through a simple example with Saturday and Sunday. So imagine a matrix like that's on screen. The blue cell is the cell that we're calculating. The cell to the left is the insertion costs, above the deletion costs, and the top left cell is our substitution costs. And it's the combination of these cells that are core to calculating Levenshtein distance. We track the minimum value of the insertion and deletion costs as a variable, and we add 1 to this result, which in this case is 2. With the substitution costs, we track that and we add 1 to it if the current letters of the cells don't match. So in this case, our cell has both capital letters S, so they match, so we don't add anything here. So our value is 0 for substitution cost. We then take the minimum value of both these that we calculated. So our final result that we save into the cell is 0. This process repeats for the next cell with an insertion cost of 0, deletion cost of 2, and a substitution cost of 1. Using the same formula as before, the result for this cell is 1. We repeat this for the rest of the row, and then for every row in the matrix. The value we want, the Levenshtein distance, is in the bottom right corner. This means, for our example here with Saturday and Sunday, the Levenshtein distance is 3. There are 3 essential elements to our baseline implementation. The data structure, representing our matrix to do calculations in. The data initialization, where we set up our first row and column with incrementing numbers. And finally, the main calculation logic, which does the bulk of our processing. This is our baseline implementation in C#. Nothing too crazy going on here, but it's also not overly optimized either. We use link to create a jagged array for our data structure. We have 2 loops for our data initialization. And then we have a nested loop for our main calculation logic. At 10 characters, it takes a little under 600 nanoseconds to run, but we're allocating a kilobyte of memory. So that doesn't seem that bad. But at 10,000 characters, we're taking over half a second to process and allocating 381 megabytes of memory. Even if I could get away with it taking half a second of time to process, that memory usage is going to be brutal to performance. The thing is, we can significantly improve both the time it takes and the memory usage. To do so, though, we need to work out how we want to approach the problem. Of the information we learned from previous benchmark run, the memory allocations were going to be the biggest initial problem, but why exactly? It's that the time and space complexity of the algorithm hurts us big time on large strings. In its most basic form that we've implemented, we're allocating a whole matrix for our processing. With that in mind, it's probably best to have a poke around the algorithm to see if there are any secrets to avoid needing to allocate the whole matrix. So take a look at the matrix again. Highlighted is 1 row of processing. All of the values used in the calculation. We are only using the current and previous rows. So why do we create a whole matrix? Instead, we could just alternate between 2 rows of data. This has a dramatic decrease in the memory requirements. Previously, we had a space complexity of n+1 squared, and now it's only n+1 times 2. And while that's a significant improvement, we can do even better than this. We can get away with using just 1 row for our previous deletion costs, because the substitution and insertion costs start from a known predictable point. so we can track those as just regular variables. This lowers our space complexity to just n. Here's what that could look like in C#, but let's step through the specific changes. First, we have less allocations from no jagged array or link usage. We have one less initialization loop, which gives us a minor performance gain. And our smart variables from the initial substitution and insertion costs. Using a single row, we're significantly faster, up to 57% faster than our baseline already. And we're only just a few minutes into this presentation. We get that while removing 99.9% of allocations for our 10,000 character example. But this was only possible for having a better understanding of the algorithm. These changes, though, give us an opportunity to now look at what framework features we can use to remove allocations entirely. Using array pool, we can make the algorithm allocation free. Because currently every call to our method, our getDistance method, it allocates a new temporary array that we're just throwing out at the end of the calculation. Instead, we can just rent from the array pool and just return once we're done. When used properly, array pool can be extremely useful for avoiding allocations. With array pool, we can see that not only are our allocations gone, but we also have a small increase in performance. While there are some limitations with array pool, like the max pool size, it works well for us in our use case. With memory allocations eliminated, let's take another look at the algorithm. This is our full matrix again, of Saturday versus Sunday. But there's something interesting about this example. It actually contains a smaller matrix that has the same Levenshtein distance in less cells. What's happening here is that common prefixes and suffixes don't impact the result. We can start calculating from the first different character and finishing on the last. Effectively, this would be like trimming our strings of matching characters. In this example, after trimming matching characters at the start and end, we would only need to process 8 cells, not 48. This is what a basic trimming implementation could look like in C#. This section being the primary part that does the logic, which is checking the strings at the start and the end, identifying the start indexes and adjusting the string lengths. This is the other important part of implementation. This actually is getting us our trimmed string. But using substring method on the original strings is a bit of a problem because we're allocating memory now to create a new string, undoing our previous efforts to make our code allocation free. We don't actually need a string though. We just need something that we can index to access the individual characters. So instead of creating a new string, we can use span slice. So span is just like a span of memory, whether it's pointers, arrays, or strings. Our slice is a span with a specific offset and length. Like I mentioned before, though, we don't need a new string, just something that we can reference for individual characters, and span fits that perfectly. We keep the trimming code from earlier, except slicing instead of creating substring. In our case, span is a drop-in replacement for referencing the source and target strings, with only need to do some variable renaming for clarity. Back to trimming though, it only works if the strings have anything to be trimmed. So this is a special benchmark to test the performance with and without common prefixes and suffixes. The trimming variant performs slightly worse when there's nothing to trim, but this is to be expected. We're doing extra calculation that isn't really of any help now. But when there are characters to trim, it performs much faster. One thing worth drawing our attention to with these results is the performance of our previous best implementation. Even though it has no trimming support, it also performs measurably faster when our strings have common prefixes and suffixes, beyond any error margins that we might have in our data. This relates to branch predictability. Our code has a lot of branches. Longer strings means more branches to process. Using hardware counters, we can see how many mispredictions each path has. So in this benchmark, random data takes about 80% longer to process, with around 9 times the mispredictions in our more predictable test. Here's a reminder of our branching logic in our inner loop. We have 3 branches. 1 branch for comparing the characters, and 2 branches for the minimum value logic. And all 3 of these branches run in every iteration of the loop. The problem is how often our loop runs and the potential of the randomness of the data. So longer strings make this more of a problem due to the algorithmic complexity or Levenshtein distance. So for 10,000 characters, our inner loop would have to run 100 million times. There is an algorithmic trick, though, where we can improve the branch predictability. It all depends on the character comparison. In the substitution costs, only adds 1 if the characters are different. So I've highlighted all the cells with matching characters. The substitution cost is always lower in these cases than the insertion or deletion costs. With that in mind, why do we do the minimum value check when the characters are the same? We can just use the substitution cost directly. Primarily, we're just reordering our code and the logic to do the minimum value checks if the characters are different. This gives us the best case for matching characters and having 2 less branches to process. In the worst case, with no matching characters, this would be the same as it was before, having just 3 branches. Those 2 fewer branches when characters are equal shows us considerably larger performance improvement in this particular example, just shy of 60% faster. What is interesting about this is our path when the characters are predictably not equal also has a performance improvement, though there wouldn't be any less branches to process. When we start optimizing on this level, cascading changes can occur with how the JIT processes our code. We can see this to some extent with the code size column. It represents the combined size of all the CPU instructions required for our code. So the code size now is 38 bytes smaller just from reorganizing our C# code. To understand what is going on, it requires us to see the code the JIT generates. Often I'm typically leaning on something like LinkPad or SharpLab to do this, but there are a number of different tools available. With them, we can see how a small change in our C# impacts the JIT. Here's a short, unrelated example to Levenshtein distance. So on the left, we have an array item at the 4th index is multiplied by an array item in the 5th index. You might think the right then would just access these values and multiply the result, but not quite. We have 2 branches indicated by jump instructions, and both of which jump to a call instruction. This is bounds checking in C# in action. But what if we change the 4 and 5 indexes around? When swapped, we have 1 less branch to check and a smaller assembly. Because 5, surprisingly, is greater than 4, it no longer needs to assert the bounds check twice. This is an example of how small changes can have larger changes to the output. An output like this would perform marginally faster for having 1 less branch. Now we've seen the impact from such small operations, let's have a look at our calculation logic to see if we can help the JIT out. Our source span reference here uses row index, which is set in the outer loop, but we're accessing the item in every iteration of the inner loop. The JIT can struggle to notice something like this, as it can't just recognize every pattern. So being mindful of how we write our code, we can give the JIT a hand. All we do is lift the data access to the outer loop. We have effectively the same business logic, just better positioned. But what will this do for our benchmark? So we can get a minor performance improvement. That small difference, though, scales with larger strings because of how often the inner loop runs. It also allowed the JIT to tweak other related parts of the code, as we also now have a smaller code size. Now, that's what I would say, and was true when I originally prepared these benchmarks onto .NET 5, but in some last-minute benchmark runs I did for this presentation, the story changes a little bit for .NET 6. Our code varies between performing similar to our previous code all the way up to running 14% slower. I haven't had the time to really dive into the specifics, but I would surmise that we're now getting in the way of other JIT optimizations. But really, this is a lesson to show how sensitive the JIT can be to certain changes of our code and the importance of benchmarks when you're pushing your code to the edge. But moving on from here, though, let's take a look at what else we can do to improve performance. Pointers. Let's remove spans and use pointers everywhere because, pointers make everything faster, right? They do. The pointers made the code up to 9% faster, but it isn't exactly that cut and dry. So running this particular benchmark with and without that source character optimization I mentioned before affects our results greatly. So with it, the performance optimization that slowed us down, we actually go much faster getting these results here. But without that optimization, we actually end up being slower by doing this pointer work. But for now, just to keep things simple, we're going to continue with that source character optimization so we can have the best performance here. The main reason that we want to use pointers at all is that we can get performance from the lack of bounds checking that is now required. It does mean we lose some of the built-in safety working with C#, and we can potentially read and write outside of the memory that we should be. But this is kind of one of the cases where I wanted the performance. You really want your extensive testing around code like this because you can somewhat easily corrupt memory. So just to recap where we're at now. So we're 70% faster at 10,000 characters, and we're doing that all without allocating any memory. So you might be thinking, how can we possibly make this go any faster? But that's when we dive into the fun world of hardware intrinsics. Hardware intrinsics allow us accessing specialized instructions on a CPU that can accelerate specific workloads. These instructions from additional capabilities sit on top of the CPU's base architecture. So for example, x86 is a base architecture and AVX2 is the additional capability. Since .NET Core 3, we can call these to accelerate our code. The majority of these instructions relate to the concept of single instruction, multiple data, or SIMD for short. What SIMD allows us to do is perform an action to a set of data at once. Rather than operating on individual values, we perform work on a vector. So here's a basic example showing two 8-value vectors added together. For Levenshtein distance, there are a couple of ways we can use it. Starting with our trimming, we can use SIMD to help us compare multiple characters at once to find out how much we can trim. We need to do 2 passes, one comparing from the start of the strings, and once again comparing from the end. Now we need to do a little processing on our result to get the actual number of characters to trim. There is a hardware intrinsic that we can call that can count the leading and trailing zeros of a value. We compared if the characters are equal earlier, so that will give us 1s instead of 0s when the values are equal. But we actually want to negate this so we can more easily count the zeros of equal characters. So we can see here that we have one vector with 1 trailing 0 and another vector with 1 leading 0, one vector with 3 trailing zeros. In cases where only matching characters are found, though, we simply repeat the process onto the next block of characters in our string. This is what that could look like in C#. Here we load strings into vectors with AVX instructions. We compare vectors and get mask with AVX2 instructions. We check our mask value to see if any characters aren't equal. And then if so, we use some bit operations to identify the number of characters, doing the negation and counting then the zeros. This snippet, though, doesn't include any of the defensive checks for instruction support, because as not all CPUs support all instructions. Ideally, you also want to fall back to older instructions, as well as even a non-vector approach for machines that don't support specific vector implementations. Keep these things in mind if you're planning to use hardware intrinsics, otherwise you'll run into some issues. So how much faster does this perform? In this specialized benchmark for trimming, we can get a sense of how much faster it helps in different extremes. We have a performance regression at 10 characters, as we're simply doing a lot more processing than our basic trimming logic would. But anything longer, though, we're seeing a significant performance increase, over 83% faster. Depending on our workload, SIMD and other hardware intrinsics can help us have huge performance gains. Another such case might be our data initialization. It might not seem obvious, nor be something that would be significantly slow, but it's worth having a look to be sure. An approach we can take is by having a vector pre-filled with incrementing values up to the vector's length. We then write the whole vector at once into the memory location. We increment the value of the vector by its length. So in this case, we're incrementing it by 8. And then we just move on to our next memory location. This benchmark focuses on the performance of just the data initialization outside of the whole Levenshtein distance algorithm. We can see some pretty large performance improvements compared to our previous general for loop that we've been using. Having a minimum of 50% performance increase sounds fantastic. However, there's a bit more to it than meets the eye. I'm very intentionally only showing how this micro performance of this very specific operation, not how it behaves in the whole algorithm. Because if we do that, we get a somewhat unexpected result. Rather than being faster or even equal in performance, it actually is performing measurably slower overall. I'll be honest, I was kind of surprised when I actually saw this, but it goes to show how an isolated benchmark doesn't guarantee overall better performance. Like I mentioned earlier with G-optimizations, even something as simple as a reordered statement can change the processed output. This is always a long shot though, so let's skip any further optimizations here and have a look where we can make some big gains, the main calculation logic. Improving our main calculation logic with SIMD is a bit more complicated. The core problem is vector processing works best when we have a full vector of values. This is difficult to do in the main calculation as we don't have all the values we need for processing, but let's walk through an example with the current way we do processing. The substitution cost highlights, so we got no issue there to fill a vector. Same as deletion cost, we can load those, no problem. But how about the insertion costs? The insertion costs are where we actually have our problem, as we only know the first value. But for argument's sake, let's pretend we've got the next 3 values. So now we have our vectors filled, but wait, we actually have 3 of the 4 values we were planning to calculate anyway. So this means that only the 4th value would be new, which isn't really accelerating much. But not all hope is lost. We can still use vectorization in our algorithm. Rather than try and fill a full vector with unique values, we can use the same value in all positions of our vector. This is computationally wasteful. We're making it do a whole bunch of calculations, just throwing them away. But it actually helps us avoid branches on our minimum calculation logic. With less branches in our inner loop, we get more performance. In every case, we have a significant performance boost over our previous best, and we're crushing the baseline here. We are close to 80% faster than our baseline at 10,000 characters. So far, though, these benchmarks top out at 10,000 characters. But what if we wanted to do it on even longer strings? This is where we can add multi-threading to the mix. So let's walk how we could do multi-threading with this algorithm. For this example, we'll split our matrix into 2 regions with a thread for each. We then start to processing the first row of the left region. Once the left region completes its first row, the right region can start its first row. The left region then can start on its second row. The right region only needs the left region to complete the same row first. The left region can then be any number of rows ahead. To achieve this, the threads need to have a shared buffer at their boundaries. The buffer allows setting the appropriate insertion and substitution costs. After the thread on the left writes the data, the thread on the right can then read it. This approach can scale really well across multiple cores by just adding more and more regions as needed. Using all of our other optimizations like single row data, array pool, branch improvements, vectorization tricks, we get a performance regression of 19% at 1,000 characters, but an 81% improvement at 100,000 characters. To put it in perspective though, our baseline can't even run 100,000 characters. Yet we can scale this further on more cores than just the small 8 cores that I actually ran this benchmark on. With the performance regression though, we can avoid it mostly by having both a path for multi-thread processing and non-multi-thread processing, and we switch depending on the length of the strings, so then we can have the best of both worlds. At this point though, you might be wondering, with everything now that I've mentioned, that how can we possibly improve it further? But I've been saving the most advanced optimization for last, so if your brain isn't already mush, it might be shortly. Let's take a look at the calculation backwards for a moment. If I want to calculate the last cell, I need all the cells around it. And if I want to calculate those cells, I will need all the cells around them. You can see here I've highlighted a cell with 2 colors, as it is both a value we calculate from this outer ring, as well as a cell we use to calculate its neighbors, to the right and below it. We've been spending this whole time talking about calculating column by column, row by row, which is where we can hit these issues of cells depending on other cells. Instead, let's take a look from a different angle. Let's tweak the cells that we've got highlighted here a bit. It isn't that we need these extra cells that I've highlighted, but at this point of the calculation, it might start cluing you in to the pattern here. When we move these green cells further and further away from the corner, we can say that they form a diagonal line 2 cells wide. The secret is they also encompass all of the insertion, deletion, and substitution costs we need to calculate multiple cells without any dependence on each other. With the previous data filled in, we can see what that would look like to calculate from this point. The revelation of calculating diagonally by itself doesn't mean a lot if it wasn't for the fact that we've already talked about vectorization, and that's where we can take advantage of this. The idea here is that we maintain two arrays of previous costs we calculated. We can then load the array data into vectors, do some processing on it, and write the result into several cells of the calculation at once. The full code behind the solution is way too dense to actually cover in a presentation, but this is the core part that matters for the calculation. We start off by grabbing the appropriate part of our two strings in vectors. Because we were working on the diagonal, we need to reverse one of these vectors to compare the values. The trick here is that the loaded strings are signed integers. So when we did the comparison, we get a -1 if the characters match, or a 0 if they don't. This gives us what I call a substitution cost adjustment. We take the substitution cost that we know from one of the diagonal vectors, adding our substitution cost adjustment to it. Remember that our adjustment is containing zeros or -1s. So when we're adding here, we're actually subtracting values. We then load our deletion insertion costs, followed by performing all the minimum value logic comparisons we would typically need to do for the calculation. That final line in the block adds 1 to the result, which would typically only happen if the characters don't match. But because of our substitution cost adjustment earlier, we can safely do this without breaking the algorithm. Finally, we store the calculated result from all these operations into our diagonal vector to do this all over again. With all of our effort put into the algorithm now with our fancy diagonal calculation, we can see it perform extremely well compared to not only our non-multi-threaded code, but even closes the gap a decent amount against our multi-threaded variant. Technically, our multi-threaded variant can even take advantage of the same diagonal logic, though it's more complex to do the boundary logic that I described earlier. To put this, though, in perspective with our baseline, at 1,000 characters, this improved intrinsic version is about 7 times faster. At 10,000 characters, that increases to 9 times faster. The fact that we can squeeze this much performance out of the algorithm is a pretty big deal. With all that said and done, though, all these optimizations, what can we really take away from this? Because as much as I've talked about Levenshtein distance optimization specific for it, I'm pretty sure that you're not actually implementing Levenshtein distance. So I think there are kind of 3 key takeaways here for your own code. Have a performance goal. Know why you're optimizing. If all I cared was about very small strings, I probably could have stopped at the first few optimizations, because let's be honest, otherwise all the SIMD and threading stuff would have been a waste of time. But I needed to calculate for 10,000, 100,000 characters. So all of those are actually helpful for me. Knowing what your goal is one thing, but you can't tell if you hit it without constant measuring. So each benchmark I showed had measurable performance and allocation changes, both positive and negative. Without knowing this information, I wouldn't know if I was wasting my time or not. And then finally, it's how you approach the problem. Throughout this presentation, I switched the approach I took a number of times to get the most out of the code. Initially, I started with some algorithmic tweaks, which opened up opportunities to use certain framework features. Later on, some framework features by themselves gave us significant performance boosts. Maybe in your code, there's a way to use array pooler span to remove allocations. Or if your performance goals require it, perhaps leaning on hardware intrinsics or multi-threading will help. And then finally, just got some related links. So Steyn is my library to calculate Levenshtein distance, which includes all of these performance improvements and a couple of others that I didn't include into a single NuGet package. And additionally, all of the benchmarks and the step-by-step implementations to get those benchmark results in this presentation are up on GitHub if you want to check that out too. Anyway, I hope you've enjoyed that talk and you've learned a lot of interesting things about performance.
Wow.
Yeah. Wow, James, that was an amazing talk. That's absolutely fantastic. I'm gonna have to watch that again. That was really good. There's lots of really cool ideas in there. The thing which really struck me, I think, was if I found a problem with an algorithm, I'd sort of reach for a profiler first. That would be my first instinct there. But understanding the algorithm, having a look at what you could do to change the algorithm, understand it in a way so you can like do string trimming and all that kind of stuff is a very different approach. Did you try and look at, reach for a profiler at all first, or did you just kind of start to figure out what to tweak?
So initially it was what I wanted to do it was just allocating so much memory. So I'm like, that first chunk, having to calculate all of to have all of these arrays, I'm like, well, because it was a jagged array, so like arrays in arrays, I couldn't really use array pool, and I already knew about array pool at that point. So I'm like, so how do I get that down to something else more manageable? And then it was just researching actually the algorithm itself. So like, I can't take credit for working out these algorithmic improvements myself. It's definitely a lot of research and other people far smarter than me have actually done. But then, yeah, it's a combination of benchmarking, a combination of profiling. And yeah, like depending what you're working on, if it's really deep algorithmically, if you can pull parts out and benchmark it, I think you can get the most accurate results because it's running so many iterations of it. But if it's something like a much more like slower operation, or if it's not so much an algorithm per se, but some combination of like other code which doing other kind of processing, profiling can definitely be the way to go.
Yeah, we're big fans of benchmark.net as well. It can be a really good way of figuring out, sort of exactly what a small piece of your code is doing. So as you say, running over it several times to get memory and performance usage and everything. But yeah, I'm really struck by the idea of understanding the algorithm better to be able to not just tweak it in a way to cache a variable here or whatever, but to actually understand that fundamentally you can change things. The string trimming thing just kind of that blew my mind before we'd even got to the vectorization.
The string trimming is like amazing. It again, like I covered, like it only works best when you actually know that you might have shared start and ends, like prefixes and suffixes. Or if you've got like such monster like pieces of text that are bound to have that because you're just trying to find a small difference between things. So yeah, like string trimming can work really well.
Cool. Yeah. Maybe related to that, a question that just came in related to strings and trimming the strings. Yep. Will using all of these intrinsics and all, will cache misses actually affect large strings in comparing large strings?
Yes. So once you start going to this level, you're going to start having to deal with things like how much, like how the registers work for what the JIT's applying, the actual like cache lines of the CPU. And I don't cover that stuff because it's still somewhat beyond me as much as I've dived into like deep technical concepts. But yeah, that would be probably some of the next areas to work out of how can you optimize the algorithm further to make sure that, you don't have cache misses unnecessarily, or that you don't have, like I did partially cover, like branch predictability problems.
But at the same time, it's very interesting to see things like the way the JIT does its bounds checking as well. That was pretty surprising. It's like, I mean, I guess the question is how do you learn about whether that changes any better or anything? Would it be the same on all platforms you're running it on and so on?
Yeah, like it will depend. So like I don't cover it too much in the branch prediction side of things, but once you start getting into, say, the hardware intrinsics, you're really requiring certain processes for certain things. So all of my code, both my actual like library and everything I covered, that all of the optimizations for like SIMD rely on like AVX, which is the additional capability for x86. But there's equivalent thing for ARM. There's then other particular ones probably for RISC-V. But you need to then either know what you're going to be programming and targeting to then optimize for those particular situations, or you're just going to have to implement lots of different variations yourself and just hope for the best.
Okay, so for the hardware intrinsics, I mean, okay, I'll probably just walk straight into that. They're different for each hardware, aren't they? So would you have to do a different implementation for different platforms?
It depends. The methods and stuff that I was calling, I would, because AVX2 exists for, was it like pretty much all modern Intel, all modern AMD processors, but those specific instructions do not exist for ARM. There's equivalent ones that exist for ARM, but they're not exposed via AVX dot whatever. They're exposed via whatever the ARM equivalent is. In .NET 7, I believe, there is a lot of work to actually make it more generic, so you don't need to so much touch the AVX2 version. You can just go vector blah blah blah, and you can actually have it do a lot more of these operations. You're still going to be a bit limited for some of them, because it could be a case of, 90% of the instructions are all the same between all of them, but then some specific instruction you need, like some permutation of like 128 bits or something, only exists on, say, x86. But then, you just don't have it available somewhere else.
That's really cool. The vectorization is something which I haven't really investigated myself, and it looks really cool. But it feels like you have to learn how it works. I mean, do you have any tips for sort of how to figure some of these things out? It almost feels like a bit of a jump to get to that.
Yeah, like some of them I stumbled across. Like there's a slide that I had about using like SIMD improperly. And that was just from the fact of, I really need to eliminate these inner branches. I'm going to try and just stuff it in a vector and see what happens. And then I realized, hey, that just skipped all the branch predicting that the CPU would do, which then increased like the code performance. But then when you get to stuff like the trimming, doing the intrinsic trimming, that's where it's like, okay, I know that my string is just a set of characters, which is just a set of numbers, and I can then put that into a vector. So is there a vector instruction that can just compare all the numbers for me? And then it's just kind of like figuring it out from there, being like, okay, so now I have this. What's the next step from there? But fortunately, other people have actually implemented not so much Levenshtein distance itself, but just various other algorithms, either in C or C# that are already touching various intrinsics, so you can get a good feel for how someone might calculate some of these things.
It's all very cool stuff. Martin, have you got any more questions there?
Yeah, we actually just had one come in. Would AOT actually make this faster? Would there be a difference if you run this pre-compiled essentially to native codes, or just have the JITs arrange everything and run it through the CLR?
I would say you probably would, definitely on the first run. So because the first run would require the JIT to actually do its job, but then for any subsequent runs after that, I wouldn't really know. I'd be curious to try it, but I don't really know the actual answer off the top of my head.
Cool. Yeah, makes sense. There was also a comment about how it would perform on WASM, but I think that's also something to try, right?
Yeah, that definitely. That's going to be another interesting case, because while I do think like hardware intrinsics and stuff are available on WASM, that you're kind of again now having to either program now for another set of like vectors, or use the generic one that .NET's now coming out with. But yeah, it's you could win in some cases, but then lose in others. So as much as I guess the kind of conclusion thing that I had with my presentation, if you're needing to target WASM, benchmark, or however best you can benchmark in WASM. I'm not sure if benchmark.net actually works for it, but if you can, try and actually get your benchmark results there, because you could have huge differences between what can work on your actual computer in just a normal .NET environment to then what can be deployed via WASM.
Good question about benchmarking, though. Do you clearly you're using that all the way through the presentation there? When you were working on the algorithm, did you kind of keep the benchmark results with your code? Did you kind of check in every step of the way, and so you can like, this is no good, I got to roll back to this version, so I can then look at the values again? How do you manage that?
Well, first it was just a text document. So it's pretty much like the crudest way you could possibly have it. In my actual library on GitHub, I've got a couple of like markdown files where after I do a couple of optimizations, I'll paste then the new result that I've got on my computer there. But otherwise, if I just am doing it in a pull request, knowing that, okay, this is the angle that I want to actually approach it on, I then just do a comment after every like couple of like tweaks that I'm doing to the algorithm. Like Steyn, I actually have a pull request open for doing a minimum value comparison, which doesn't need branches or vectorization, but it's in my benchmarks, it runs faster in some cases, but the longer strings, it starts running slower, which is also really counterintuitive. But that might be back to the earlier person's question about cache misses and stuff, that now I might be throwing out something else because now the code is so much longer because I'm loop unrolling or I'm doing something else. Yeah, there's like so many layers of optimization which then can start interfering with each other. So you don't know if this one that you're doing is actually better or this one's now worse.
Cool. Yeah. Related to better or worse, do you have any advice for people doing this in a larger development team? Because I mean, typically when you squeeze out more performance in your codes, things might become more unreadable or at least less understandable at first glance. Like, how do you deal with that? Do you stop at a certain point or just squeeze every drop of performance out?
I mean, like, part of me would love to say it's the latter. You get to squeeze all the performance out, but it really goes back to what your actual goal that you're trying to achieve. Like, I wanted my algorithm to work on very long strings, so I had to keep going and just keep going and adding all of these optimizations of optimizations. Otherwise, I could have stopped at like the third optimization of just doing the single row processing, because that eliminated pretty much all of the allocations and was already so much faster than the baseline. But if your code needs to perform in, like 1 millisecond, but it's taking, like 1 second to process, well, you're going to have to do whatever it needs to do to bring it down to 1 millisecond. Whether that is something that's as simple as caching some value somewhere else, or as complex as diving into hardware intrinsics, you're going to have to do and figure it out for your specific application. There's no broad strokes of, oh, we can just do all our crazy optimizations and make this be like nanosecond fast. Like, we have the library developers of .NET doing all of the actual really complex work for us that we can just take advantage of more sane APIs. But when you actually truly need the performance, you can dive right into it.
Yeah, it's fantastic that the platform gives you the power to do that. Really, it's very cool. Very cool.
Having span available is such a great feature in .NET. It's one of my favorite APIs because you can just build so many things, parsers and other stuff that are now allocation free, because you didn't need to deal with strings. You just need to deal with the idea of characters in a span.
Yeah. Being able to do things allocation free and being able to grab stuff like that is great, because you always need to use a subset of a string or of an array or something. So it's a properly good algorithm. Platform API to have. Yeah,
I've done a parser for like robots text files. I've got like a DNS query parser, and they can all do the same type of thing. They just try and heavily use spans to try and reduce allocations wherever possible, and then use array pool for when it really does actually need temporarily an array.
Yeah, good stuff. How are we doing for questions, Martin? Have we got anything?
I think, so some people are thanking you for the session, thanking you for all of the demos, and I would like to add my thanks there as well. That was a fantastic first session to essentially blow everyone's minds. So I hope things get better for a lot of people after this, including myself. I think we can probably bring in the next speaker and let you go, because it's a little bit later there where you're at.
Yep.
Absolutely. Thank you again for a fantastic session. And we'll see you next time.
Very much. Thanks a lot, James.
Cheers, everyone.
Bye-bye.
Cool. See you, James. Bye.
Bye.
All right. Then let's bring in our next speaker. That is Stefan, or Stefan, whatever you want to pronounce it. Hello, Stefan. You're online now.
Hello.
I don't see your screen yet, so let's work on that in a little bit. How are you?
I am super excited to be back. It's amazing. Woo! Thanks for having me. It's a bit nervous like last time, but I guess I hope this goes away through when I'm in the flow.
It will go away. You got this. For those people just tuning in, or those who are not watching the agenda, I think, Stefan, your talk is about source generators and implementing an incremental one. Is that right?
That's right.
All right. I'm actually looking forward to this one, because there's so much buzz and activity around source generators, people using third-party ones, people building their own. So really curious to see that last part there. Are you good to go?
I'm almost. Give me
all right. We'll give you a couple of more seconds.
Thank you. Just to have everything.
Maybe just to get some buzz going and gauge some interest from the audience here on YouTube and on Twitch. Is anyone building their own source generators right now? Curious to learn about that, because I think a lot of people are using them under the hood without even knowing that they might be using it. For example, for Razor in the latest .NET versions, or with JSON source generators. But is anyone building their own right now?
Yeah, it'd be interesting to know what use cases people are targeting with that. Yeah. And again, as well, which just to remind everybody, if they have any questions, please fire away in the chats there, and we will follow up with Stefan at the end of the session.
Exactly. Someone is already mentioning that they have a big typewriter library. It's maybe not the same, maybe it is the same. And there's also a question about what source generators are. So I think that's a perfect question to get into your talk.
And I believe I'm ready. Yes.
Yes. Okay. Let's bring up your screen. Let's move us off screen, and then you're good to go.
Great.
All right, good luck.
Thank you very much, Martin. Thank you very much, Matt. Hello world. It's great to be here at the JetBrains.net Days 2022. And this session is a bit of a follow-up to last year. It was last year's first session, if I recall correctly, by Andrew, called Source Generators in Action. And he showed the new thing that you can implement, the iSource Generator interface, in order to build this Roslyn component that generates new source code at compile time, unlike other source generation techniques such as reflection emit, which work at runtime. And I'll be basically showing a bit of a diff, so what has changed in the last 1.5 years approximately, quite a bit. And we have a look at, and we will also do a lot of live coding, similar to Andre last time built an iNotify property changed source generator, and we'll be building something with around equality. So let's get started. Title is Never Send a Human to Do a Machine's Job, to quote a famous villain from one of my favorite movies. A little bit about myself. I am Stefan Pölz. I am doing .NET for roughly 10 years. Have started with Roslyn around when the pandemic hit, and doing source generators since they have been released in .NET, in the .NET 5 SDK. Currently, I am a senior software developer at Trayport in the office here in Vienna. Trayport is the primary network and platform for the European wholesale energy market, which means there is a good chance that the devices I'm running here to give this presentation are powered by energy which was traded through our platform. However, this talk is entirely my own, and I am also, since recently, a community contributor, a JetBrains community contributor, and a co-organizer of the .NET Austria meetup here in Vienna. I have a couple of socials here if you would like to connect afterwards. I'll link them. I'll supply you with a link at the end. So to a little bit set the stage, what is Roslyn? It's the .NET compiler platform, which includes the compilers for both the C# and the Visual Basic language. We'll be focusing entirely on C# today. And as a consumer of the Roslyn packages, there is a set of NuGet packages that you can consume. You can build plugins, components that your or other people's projects can consume, and then you can supply them via NuGet. So you can build, for example, analyzers. Now, analyzers give you little warnings or errors, the squigglies in your IDE, and they could then be fixed via a code fix provider, which is in Rider the Alt-Enter, or in Visual Studio the Control Dot experience. What Andre showed last time is the iSource generator, which you can build in order to generate new sources at compile time. So this was added in .NET 5, and .NET 6 added the Incremental generator, because there was a bit of a flaw in the programming model of the source generator, and we will see just at the end of this session what the big benefit of the incremental version is compared to the regular version. Also, since last time, now the BCL team of .NET is also using source generators more and more. So .NET 6 got shipped with 3 source generators actually. A source generator for JSON, a source generator for logging, and a source generator for Blazor. So the Razor files that you write are now actually generating C# code through source generators. And .NET 7 will have 2 additional source generators. One around regular expressions and one about interop, so to replace the DLL import and make that faster. Now, the big advantage of using these source generators over existing versions is that most of the times the source generator can produce very special case code that avoids reflection and then therefore is at runtime significantly faster. In order to utilize source generators, we need a couple of language features. One of the most important language features is partial. So C#2 added partial types, C#3 added partial methods, and in C#9, the rules around partial methods have been relieved a little bit. So previously, with C#3, a partial method must be void, and it is implicitly private. With C#9, partial methods can also return values or have out parameters as well. However, then somebody or something must supply the implementation of this partial method. So it may be a human writing the implementation of the partial method, or it may be a source generator writing this partial method. Today we'll be using a partial type. So the user will be supplying a partial type, and then our generator supplies the rest to that. And C#11, which comes out in about a month, will also include file scoped types, which is a type which is only visible within that file in order to avoid name collisions with already existing types. This doesn't have necessarily only need to be used by generators, but the prime intention of this is to be used by generators. Perhaps a little bit of a refresher since last year's, or it's 1.5 years, I believe, JetBrains.net days. What are the laws of source generation? There are a couple of rules we have to keep in mind. Now, the input to a source generator is basically a set of syntax trees. How this looks like, we'll have a look at in 3 minutes, which include the source code that the user has written. Also, the rest of the compilation, for example, the user's project may include a project reference or a package reference, and these you can all get through the compilation. And via the semantic model, you can ask questions about the syntax of the code, where the syntax tree, basically something is system.string. Now, from a syntactic point of view, we don't know if system.string is the system.string from the BCL, or maybe a system.string that the user may have written, because you can. And with the semantic model, you can then actually understand what is the meaning of this string, what members does it have, is it derived, is it implementing something, and so on. Now, source generators are only additive. You cannot change or remove existing code. You can only add new code. And this is where the partial hook comes in handy, where you basically define, the source generator declares the same partial method and extends it with additional functionality. And the output of a source generator is either 0 or any amount of source files, not necessarily files, but source documents. And the result is a string. And this string gets then back into the compilation and is then combined together with the user code. So user code plus generated code is the final compilation. Since generators are technically analyzers, they can also produce diagnostics, such as warnings and errors, perhaps to give the consumer of the generator a little hint about what to do in order to make the source generation possible. And the source generator could also not only consume the C# files as syntax trees, but also additional files, such as JSON files, for example. One very important thing is source generators are unordered. So one source generator cannot depend on a different source generator. They all get the very same input. With one version of Roslyn, there was a bit of an addition added, so you can circumvent this rule to some degree. We will see this in the example. And the two prevalent use cases for source generators is to avoid tedious implementation. So if you know ahead of time what you are going to implement, such as equality, which will be the example we'll have a look at soon, the source generator can do this automatically, and you don't have to do it by hand and potentially avoid making mistakes. And also, you can avoid reflection. We will also have in the look of an example where reflection is used behind the scene, and therefore reflection allocates and is not the fastest because that's runtime evaluated. And we are going to replace that via a special case implementation, which takes the logic to the compiler and then at runtime is fast and doesn't allocate on the heap. Okay, so before we jump into the action, what we saw last time was version 3.8 of Roslyn generators, the I source generator. There was version 3.9, which adds post-initialization. We will see this in the example. And in Roslyn 4.0, incremental generators have been added. And this is the generator, the programming model that we will build right now. So let's jump into the solution. What I have here is a type. I called it the equality comparer generator. So this generator will be creating equality comparers, and it's deriving from, well, no, it's not deriving from, it's implementing the I incremental generator. We also add the generator attribute on this generator type and give a hint that this is a C# generator, because you could also write the generator which emits Visual Basic code. But now let's have a look at the problem. So I have a set of tests here that I will run. And we will be seeing that something is failing. We get the exception the given key was not present in the dictionary. The example that we have is we have a dictionary, we have a my class. Now I assume, or we assume here, that this my class is outside of our control. This is not a class that we have written. It may be coming from a third-party library, so we have no influence on this type. We cannot extend it. We cannot implement equality on it. And as we see in the type, it doesn't implement equality. So since this is a class, reference equality is used and not value equality. And therefore, if we add an instance of the my class with the integer 1 and the string 1 into this dictionary and then try to get that value again, not by reference, but with the same value, we don't find it because it's a different reference. And we would like to use, what we could now do is, because we cannot change the my class, we cannot implement equality on that, we could build our own equality comparer. And I already ahead of time know exactly what I would build. I would build an equality comparer, which is generic of this class, and then basically compares all the members. So it compares the number and also the text. So I know already ahead of time what I would be building. So we can put this into a source generator and have the source generator automatically generating this for us. And another example that we hear, what if we do this with a struct? Now with a struct, this test is passing. With a struct, this works because every struct is implicitly deriving from value type. If we have a look, my struct, the base type, is actually value type. And value type has some implementations for us. So it implements equality and also get hash code. However, there are caveats to this implementation. Now let's run a set of benchmarks. in release mode and with the Net 6 framework. And while we do that, we have a look at the value type. So we will jump to, I'll go to the site sites of .NET, which links a lot of interesting pages and sites. For example, there is the Roslyn, the source roslyn.io, which is a source browser for Roslyn. And we also have source.net, a source browser for the BCL and the .NET runtime. So let's have a look at the system.valueType. And we see that equality is implemented. There is this one is a rather fast check. However, this is only applied if we can compare bits. Now, what does this mean? Let's go to the repository. Let's go find this can compare bits. There it is. And there is a comment. So can compare bits only works if the struct, if this value type does not contain any pointers. Our struct consists of an integer and a string. The string is a reference type, so we do have a pointer there. Or if it's tightly packed, so this amounts to the layout, the memory layout of a struct, if there is padding or not. Or if we have a floating point number, then we cannot compare the bits. And if we cannot compare the bits, then we will actually fall back to what we actually see here, a reflection-based implementation. We get the fields and do equality reflection-based. Now this will allocate. This allocates here and is also slower than a more naive implementation. And the get hash code, if we have a look at the get hash code, it actually says this is the current version of the BCL. This may change in the future, but since the algorithm of determining a hash code dynamically is rather complicated, so we are only comparing the first non-static field. Now this means in our example, our myStruct, which consists of an integer number and a string text, so we have a reference in here. We cannot compare the bits, so we need to use reflection for equality, but also the get hash code causes issue because only the number is observed. Now, if the struct differs in the text, then we actually have a hash code collision. And if we have a look at some benchmarks, which unfortunately have failed, well, it's not that important, but what we would have seen in this benchmark, where we create both a dictionary with the key of the myClass reference type and one with the key of the myStruct, we would see that this method would actually allocate because we have hash code collisions, because there is no difference between so we have hash code collisions, but also we use equality because of the hash code collisions, and this allocates. So this is slow. So we are going to fix two issues with this generator by auto-implementing equality comparers. Now, what I did ahead of time is create a set of unit tests. I strongly advise, if you build a source generator, to have unit tests around it, because this is also, each and every unit test is also a great entry point for debugging, and this is really, really helpful. So what we see, we are consuming the Microsoft Code Analysis C# source generators.testing.xunit. There is also an MS test and an NUnit variant of these packages, and we can use these to unit test our source generators. There's also other versions, other approaches such as snapshot testing, but here we are going to focus on this more low-level package. And so we first have here our unit test. When we just have a class. So the input to a source generator is basically just text. So we will write here some C# code. And if we pass in just an empty string, then nothing is generated. We basically assert here that we only emit a specific attribute. So this is here an attribute. I called it the equality comparer attribute, which gets a type that we will use in order to determine for which type the equality comparer should be generic on. And if we had C#11 already, we could actually make generic types like so. We could have a generic attribute of t, but since we are still on C#10 here, I have to fall back to, or not fall back, but still use the bit of the soon old-fashioned type of version of an attribute. And this will be not only a marker attribute, but it will also hold the information about which type we should generate equality for. And so if we have nothing where we place this attribute on, nothing additional will be generated. However, if we do, so this is how the generator then could look like. We define our own partial class and we slap this attribute on top where we say, please implement equality for the my class type. Where we declare the my class here, it's the same that we saw from the example and consists of a number and a text. Could be any amount of properties. Our source generator will inspect all the properties. Should also inspect fields, but for now we keep it simple and only properties. And then the expected text should be something like this. We always add auto-generated on top of generated code. This is a good practice so that tooling understands, okay, this is generated code. Emitting diagnostics such as warnings and errors for that is maybe not, well, errors is something else, but warnings is not really super helpful because the user who is consuming the generator doesn't really have direct influence about what the generator is producing and can't necessarily fix the warnings. And then we're gonna extend this comparer that we slapped the attribute on. And we're gonna implement the I equality comparer. What I'm doing here, I'm not writing any using declarations. I'm referring to the I equality comparer name in the full qualified name, including the global alias, in order to avoid potential name clashes, because technically the user's project could implement their own system.collections.generic.I equality comparer interface. And by referring to the global namespace alias, we could avoid potential name clashes. Then we're gonna have a private constructor because we will apply the singleton pattern because an equality comparer doesn't really have observable state. So the singleton pattern is a good fit here. And then we will emit those two methods, so the equal methods from the interface and the get hashcode method, where we do, since this is a class, we do some null checking and then compare each member by using the default equality comparer. So we use the integer comparison for both the number of the left and the right instance and combine this with the string, which is the text property of that class, also equal check. And here we see another good practice to put the CodeDOM compiler generated code attribute on top of generated methods or generated types, so that, for example, reflection-based tooling can't really read this comment because it's not there. But reflection-based tooling can read attributes because they persist in the metadata of the assembly. So reflection-based tools would understand that also this is a generated method, not directly written by the user, but some tool, and we pass in the name and the version of this tool, perhaps also for debugging purposes. And the other method that we need to implement due to the I equality comparer interface is the get hashcode, where we get in the my class, we check for null. And if it is null, we hashcode combine all the members. Then we verify that this has actually been generated. So here is a bit of a hint name. What's this? It's not really necessarily a file that the generator is producing, but we will have a look later on of how this could look like. There is a flag to emit the file to disk to have a physical look at it. Otherwise, it's just in memory or in flight in the compiler steps. And then we have a second type for if we define an equality comparer type of myStruct, so which is a value type. Since a value type can't be null, well, not in the terms of a nullable reference type, we don't need the null checks, and we just, in the equals and the get hashcode implementation, we just combine the members. And now we're going to write a generator to auto implement all of that. So let's jump to in the generator. And if we have a look at the interface, the incremental generator interface, there is only one thing. There is only the initialize method. This is different to iSource generators that we saw in last year's JetBrains.net days, where there is an initialize and also an execute. Here we only have an initialize. And in this initialize, we're gonna build up our pipeline. But first, let's have a look at our first failing unit test. So our first test, which only expects the attribute to be generated, doesn't really generate anything because it says we expected 2 sources but have only 1. So there is only the one source that the user supplied, but no generated version. So in that case, we want to emit this attribute. And since we always need this attribute unconditionally, we can use the thing that I mentioned earlier, the initialization, post-initialization, that was added in Roslyn 3.9. So we can say in this context, we can say register post-initialization output, and we will call the method the post-initialization callback, which gets the incremental generator post-initialization context. And we see from this type, this only has a cancellation token and a method to add a source. We have no compilation, we have no information about any syntax trees or anything. So we can just unconditionally emit some source code. And we will do this with our attribute. So we will say context.add source. And now we give that thing a name. We will be using Roslyn.generated.equalityComparer attribute.g.cs. So this is the full qualified name. It includes the namespace and also the name of the attribute that we are adding. And at the end, we always add .g.cs to, again, it's good practice to indicate tooling that this is a generated file. We could also write the full .generated.cs. It's the other convention to indicate this is a generated file or a generated source. And then we're going to refer to the attribute. We defined the attribute that we had a look at already, this very attribute. We will now put emit. And if we run this test, it should turn green in just a second, and it did. The test has passed. So we now are emitting unconditionally this attribute that now the user can consume and put on their types in order to give an entry point to the source generator. And so actually, let's have a look at how this could look like in action. If we go to an example project, what we can now do is, let's say, we can say our internal class, my comparer. I call it the my struct comparer. Just an empty class. It should be partial so that the source generator can add a source to it. And we're gonna put the equality comparer attribute. And we will say type of my, type of my struct. And we will see if I go to the source of this equality comparer attribute, we will see Rider, and it's very, very similar in Visual Studio, shows this with a yellow background, that this is a generated file. If I would try editing it, Rider gives me a hint, hey, this is a generated file. It doesn't really make sense to change it. And this is what the generator is creating. We have the auto-generated comment. We enable nullability. We put the generated code attribute and emit this attribute that now can be used within this project. But nothing is really generated yet. So the end goal should be that I can say, because a dictionary, if we have a look at the implementation of a dictionary, one overload takes an equality comparer, and we want to utilize that extension point. But the MyStruct comparer currently has no members yet. We still need to emit them. So let's go back to the generator. The next failing test is now that we need the actual thing generated. And now we gonna start the pipeline, which is the core programming model of incremental generators. If we have a look in the, this is the wrong method, sorry, in the initialize method, the one that is from the interface, we can have a look at this initialization context. And this initialization context has a lot of properties. Most of them are either value or values provider. And this is very comparable to, it's not exactly, but it's comparable to link, like an I enumerable. So this is a deferred evaluated pipeline that then the actual source generator driver is executing, where the driver could be our Rider IDE or Visual Studio IDE or the .NET CLI, .NET build, for example. And we have a value provider with singular, so we can get a hold of the compilation. We can also get a hold of the parse options. The parse options, for example, include information such as the language version that this project was compiled with, in our case, C#10. We can also get additional texts, because there could be no additional texts or many additional texts, for example, a JSON file or an XML file. This is a so-called values provider, plural. There could be more or none at all. We also have analyzer config options and metadata reference. This, however, is a bug in the version that I'm using here. I'm mostly using version 4.0. This was fixed in version 4.2, where this is actually a values provider because there could be more than one metadata reference. And we have a syntax value provider. With the syntax value provider, we can have a look at all the syntax nodes. Now, why would we need that? Let's again go back to our example and let's have a look at this code. If we put this into sharplab.io, which can not only decompile our source code, but also give us a way to inspect the tree, we can have a look. If we go to the syntax tree of it, we see how this C# code looks from a syntax tree point of view. So everything is in the compilation unit. Now this compilation unit has one class declaration. This class declaration has an attribute list. And those are all nodes. All the blue ones are nodes in this trees, in this syntax tree. And the attribute list has an attribute. It could have multiple attributes because we could have more than just one attribute on top of a member or on a type. And one of these attributes, it has an identifier and an argument list. And in this argument list, we eventually come to the type of expression. So we need to drill down. What we need to do is now find all the classes, all the partial classes in the compilation that actually do have this attribute applied to, and then inspect this type of expression in order to get to this identifier name. If I highlight it here, we see this is the myStruct identifier name. And this is how we can extract the information out of this attribute in order to generate the right thing. So we are going to build we're going to use the syntax provider. So we will say context.syntaxProvider.create syntax provider. Now this takes two callbacks. One callback receives each and every syntax node in this tree and a cancellation token and returns Boolean. So this is a quick filter to see, is this interesting for us, this node? And as a second part, we have a transform. Now this transform is semantic because this generator context also gives us the semantic model to give meaning to our code. And utilizing both, we can now, I have the two methods prepared already. We can have a look at the syntax, the syntactic predicate and the semantic transform. Store this into our pipeline. Okay. And now it's to implement the syntactic predicate. So we get in each and every node of this compilation. So if we jump back to SharpLab, we get in all the nodes. So we get in the class declaration, the attribute, and if there is more, there could be other classes. So we get in all the nodes, and we need to filter which nodes are potentially interesting to us. And with that, I'm gonna bring in this code. So we will inspect each and every node, and if this node is of type class declaration, this is exactly what we saw in SharpLab. If we jump back, we see it's this class declaration that we search for. And if it is, we also should filter if this class declaration has at least one attribute on it. It may not be the attribute that we actually care about, but it's a candidate because we only can have a look at the syntax here. We don't know the semantics here. So just have a look at this code. We don't really know if this equality comparer attribute is actually the ones that we observe, or it's some other equality comparer attribute that the user or some other third-party library has defined. So from a syntactic point of view, we only know we need at least one attribute in the list. And then this candidate, we also check if the modifiers, again, jumping back to the code, the modifiers are these. So we have a partial modifier and a class modifier. And we see, no, class is not a modifier, but we have a partial modifier, but we could also have a static modifier. But because we want to implement an interface, static wouldn't make sense. Static type can't implement interfaces. So we will have a look at if the modifiers, if we have the partial keyword, and we do not have the static keyword in this modifiers collection. And now this thing is a candidate. It could be one of the methods, one of the types that we want to generate source code for. And now after this syntactic check, every syntactic check which returns true will get fed into the semantic transform. And for that, we will bring in a little bit more code where we now know. So we have here the generator syntax context, and this has two things: the node that we previously filtered, so we know this is a candidate, and the semantic model. So we can ask semantic questions about this. We can get type information about this node. And so we know, okay, this node is a class declaration. We filtered it previously. We will cast it to our candidate. And we then get, via the semantic model of this class declaration, we get the type information. And we also check if this is a named type. It should be like, for example, an anonymous type is not a named type, but every class declaration that we usually write in code, that is a named type. And now we check, via the semantic model, we can also get a hold of the compilation, and we can get types by metadata. So we grab both the equality comparer interface and also this Roslyn generated equality comparer attribute. Now this is the attribute that we have emitted in the post initialization. Now what I said previously, source generators cannot depend on each other. However, in the post initialization step, if we emit source code in the post initialization step, source generators can actually see and inspect that. If it was in the execution phase of another generator, then it wouldn't be available just yet. And then we check if of this type, if we jump back to SharpLab, of this very type, we see if it already has this equality comparer attribute. Let me restructure this a little. If it has already this equality comparer interface implemented, because if it's already implemented, then the source doesn't make sense to implement it yet again. And if it's not implemented, now it's time to get a hold of this information, because we need to drill down into this very attribute and get this my struct information out of that. And for that, I built a try get attribute info method where we pass in our candidate, the attribute that we are scoping for, and the semantic model to ask additional questions about that. And here we're going to bring in more code, where since we need here a double for loop, because attributes in C#, we could have attributes like this, and each of them is one attribute list. But within one attribute list, we could also have something like this, comma separated attributes. So this is multiple attributes in one attribute list. This is why we need this double loop. So we first loop through all the attribute lists, and then we grab all the attributes in this attribute list. And we get, again, via the semantic model, the type information out of that to understand what is that. And we want to get a hold of the argument list. So if we, again, drill down to the original source code, this here is the argument list. We see that here, the attribute argument, because we want to get a hold of this type of expression. So we will have a look if the count is exactly 1, because then it is what we want. We get a hold of this argument. We check if it is indeed the type of expression that we just saw. And with this type of expression, we can once again ask the semantic model about the type information of this. And we get a hold of the symbol. And now we have the type. This now actually returns us the type information about this my struct that we have here. This could also be my class, or it could be string potentially, any type that we want to implement equality for. And if we found that, we return true, otherwise we return false. And at the end, we return a combination of both the static type, not the static type, but this the type that we put the attribute on that we want to the partial type that we want to extend, and also the symbol of the type of expression to know which type to generate equality for. And with that, we're gonna implement a bit more in the pipeline. Since I have now, we basically now did the most important part. We have all the types that we need. Now it's time to basically bring the pieces together and start generating the code. So I will extend the pipeline now. I have an additional filter. So this is each and every method here is another step in this pipeline. First, we filter all the types which do not have any value because we return null in this semantic transform here if we didn't find anything interesting. And then we're going to transform this type. I will implement this code rather quickly. We're not scoping into much detail because it's not really Roslyn specific, but what we basically do is get all the information that we need. We get the namespace. It's important to understand if a type is in the global namespace or is in a named namespace. This could cause potential issues if we do not do this check. We get the name of this partial type. We want to understand, is it a reference type or is it a value type in order to generate the right thing with the null checks and so on. If it is a reference type, we actually want to add a question mark at the end because we have nullable enabled. Equality comparer is annotated such as that it could take null as an argument to the methods. And then we go through all the members that are properties of this type. So in our case, the myStruct, we will get a hold of these attributes. And we get the name and also the type, because this is the information that we need in order to generate the code. And just filling in a couple of more gaps in here. And now we have extracted all of this information into this partial class context. This is just a record struct. We have the namespace, the name, is it a reference type, and all the information that we need to generate the code. And now we can actually get generating. So this is the last piece of code that I will bring in. This is now in the execute phase of the compilation. So if we jump up here, we actually still need to implement it. So we can say via the context, we can now finally call the add the register source output. So this will actually be used in order to generate the source code. We will pass in our provider that we have built and also tell him to run this execute method. And here we have now a bunch of code. I'll briefly skim over it. So we have here the null checks in place if it is a reference type. Some more null checks if it is a reference type. And then we generate the source. Since the result is just a string, we assemble here a string. You could also use a string builder or other means of how to generate this source code. So we have the auto-generated attribute, nullable enable. Now if, this is basically saying if the type is in the global namespace, we shouldn't emit namespace, because if it was, the code would actually look like something like this, namespace global, and this wouldn't compile. So if it's in the global namespace, we do not declare a namespace, but if it is in a named namespace, we emit that namespace. Then we generate this partial class. It implements the equality comparer interface. Here we have the private constructor that we saw. Here is the singleton instance member, and we generate both the equals and the get hash code by going through all the properties and emitting these equality comparers. And then at the end, we give this thing a name via the hint name and put the source into production. And if we build that and jump back to our example here, Now, if I go to the dictionary, previously I entered the type and then say dot. Now we actually have the instance available. This is generated by the generator. We still don't see it here, but if we have a look, we can go in wider to the Source Explorer, go to the Dependencies tab, have a look at the source generators. So we can go down this trail, Dependencies, Target Framework, Source Generators. We see here our source generator that we have built and all the code that it emits. This is not necessarily files, but the hint name that we gave, we actually see here in the tooling. This is why it's called a hint name. So tooling can pick it up and give this a name. And here we have this one file is the attribute that we generate via post initialization. And here is our actual implementation of the comparer. So here's our partial class struct comparer. It implements equality of the myStruct type that we have declared, that we have extracted from the type of expression of the attribute. And we have all the implementation ready, and we see we compare the numbers and also the texts. And for hash code, we hash combine it. And we can also do the same for the class. So we can have my class here, and we are going to call this the my class comparer, and put the instance here. Now I'm afraid Wider needs a brief restart. And all of these should turn colorful in just a second. Here we are. And now we can run this benchmarks again if I fixed the unused field. Yes. And while this runs, let's also have a look at our tests. So the other example that I showed was this test where we couldn't. This should be here. There they are. Where we have an issue of finding this class again because we use reference equality. So again, let me create an internal class my comparer. I put the equality comparer attribute that was emitted in the post initialization phase of the generator, type of my class. That's it. The rest, oh no, we still have to make it partial so that the generator can extend it. And now we can, in this example here, add my comparer.instance, again, generated by the generator. And if we run this test, which previously failed because the given key was not present in the dictionary, now we are using this generated equality comparer, and this test will turn green in just a second. There it is. Now it's green because it's now referring to this equality comparer that no longer loses reference equality, but value equality semantics. And also the benchmarks should be done. And the benchmarks previously failed. I'm sorry for that. But what we would have seen is that we would have allocated a couple of bytes here, because for the value type, reflection under the hood would have been used in order to determine equality. And since this is no longer the case, we now have 0 allocation. And this is basically how you could build your own generator to avoid slower one-time based implementations such as reflection, while not really having to do anything. So for the consumer, it's super, super convenient to just, where's my example? There it is. To just define a couple of types, put an attribute on it, say the target type, and that's it. And the user is free to use any type name that they want, put it in any namespace that they want, and use it wherever they want. Now, since this is the testing that we have, is really, really important also for debugging. So if we have a look at our generator, let's perhaps get, where is an interesting part of it? Let's jump into here. So we can actually debug the unit test. To serve as an entry point for debugging, yeah. And we will hit this breakpoint in just a second. There it is. And oh, I closed it. And since this is basically, the Roslyn is super extendable and it's with this package very nicely testable, we can have a look at all the nodes. So we will have call stacks and we can inspect, we can evaluate all the values and have a look at, okay, what's available, what information can I extract. And since this is if we have this unit test, also another nice side effect is that we can use mutation testing and code coverage. So let me run some mutation tests. I'm using Striker.net for that, which is a mutation testing framework. And while Striker.net is running, just making sure that everything is all right. It found test run successful. Now it should determine some mutants. Yeah, that looks good. While this is running, we can also use Rider to inspect code coverage. So let's cover all of our tests. Did I click it? Cover all tests. Doing something wrong. Cover all tests. Still building. Not sure what's going on, but yeah, we would have seen that we got pretty good code coverage and we get the green gutters at the end. And mutation testing is almost complete. We will get a nice report of our test efficiency, where we can actually see, if we drill down a little bit, where do we have something interesting in place? Some mutant that I hit, yeah. So here, the mutation testing changed this end into an OR, but we do not have any failing test. So my test suite is not super efficient yet. I need more cases around implementing interfaces to make it more reliable. And for the last part of the session, we actually wanted to reap the benefit of the incremental generator, because we have one little issue. Jumping back to our example, if we open both generated files, because we both generated types, we generate two of them. If we open them side by side, and in the generator would add a where is my generator? There it is. Oops, sorry. So, in the output, in the emitted code, if we would add the current date of time, datetime dot now, oops, and build that. Where are my generated files? Here they are. All right. If you have a look at these timestamps here, and if I change, so now I have everything set up. If I change any code, let's say I add a enter just here, the timestamp will change. So we have 1426, and if we do that, it will soon jump to. Oops, I think I gave the conclusion away, haven't I? Yes, because I already implemented the last bit. Sorry. Let me comment this out and run the example again. And if we hit return now, so the current timestamp is 12:15:30, and it will soon jump to 12:15:36, and I will hit enter just again. And it jumps to 22. And although I haven't changed anything interesting in the types that we observe, we still generate everything anew. And this is now where the power of incremental source generation kicks in. So as one step of the pipeline, I here define a comparer. And this is now used to compare the results of the individual steps. And so the pipeline that we built, if in the second run of the generator, if one step of the pipeline creates the same result as in the first run, then subsequent steps of this pipeline, such as emitting the source code, can be skipped and just reused because same input, same output. Source generators should be deterministic. And now with this comparer in place, if I rebuild, we have now fixed this flaw. And this is the real power of the incremental source generator pipeline that we just built. Now, the timestamp is 12:16:44, and I remove a couple of enters, and I wait 3 seconds, and this will not change. It will stay at 12:16:45. The code has not been generated again. However, if I, for example, in this class now change text, I rename text into name. Now something actually has changed, and it should be generated again, but only a part of it. So we will see that the myClass comparer now has a newer timestamp, but the myStruct comparer that hasn't changed was still reused. And this is the power of the incremental generator pipeline. So in IDE scenarios, because actually Microsoft hit this problem in the BCL, they have had in Visual Studio and also in Rider a bad developer experience because everything was generated all over again. And with incremental generators, we can circumvent this potential flaw in huge solutions. In a smaller solution, you will not notice any issues. And with that, coming back to the slides. So here are a couple of best practices. This is all online if you want to have a look at it again. We had a look at to add auto-generated, to use the global alias, use the generated code attribute, the hint name. Be mindful about the language version. So I'm emitting here C#10 code because I'm using file scope namespaces. So if a project that is compiled against C#9 would consume this generator, compilation would fail because the language versions do not match. So we need to think about the target audience. Always do benchmark, always do testing, and keep in mind that generators should be deterministic. I have a link to a template that I actually used in order to kickstart a source generator project. And with that, I list here the link to the presentation and also to the source code. And if you follow this website, you could click some of my socials if you would like to follow up later on. But perhaps you have a question right away.
All right, let's bring us in. Thank you, Stefan. Fantastic talk as always. I love seeing you present, and actually I have a nice compliment there for you. Great presentation style with all of the the arrows and marking on screen. And I do want to start with the most important question first. What's the tool you use for marking on screen?
That's oops, sorry, I hit the wrong key. Why does it? There it is. So it's a tool called Zoom It. It's part of the sysinternals suite, and with that you can type and zoom and also change colors. And yeah, I cannot do anything without this tool anymore, and this is why I'm always bound to Windows now.
You're a genius at that, it has to be said.
Yeah, exactly.
Thank you.
Also, some nice comments in the chats of people building their own source generators and using source generators. So someone was using source generators to simplify durable orchestrations in Azure to remove some boilerplate codes. Someone else was using or building a source generator to generate record types for classes in a project with an older C# version, which apparently was a bit flaky on some developer machines. Others are using it to build test suites. So really lots of source generator usage. So thank you for inspiring many more people on getting that knowledge spread a little bit. Maybe one question that is very interesting as well. What do you see as a big difference between source generators and text templates like T4 and things like that?
Well, for example, T4 templates, this is Visual Studio only, I believe. So this is heavily depending on the tool, such as the IDE that you're using. But source generators and incremental generators, they are part of the .NET SDK. So I'm using Rider here. You could also use Visual Studio. You could also use Visual Studio Code or just edit it in Notepad or anything because it's part of the SDK. Well, of course, Visual Studio and Rider both have additional toolings such as viewing the files in the tree, which makes it easier. But it's in the core, it's tool independent. As long as you have .NET installed and reference the Roslyn package, you can make use of source generators. And also you get as the big advantages you get as an input the syntax tree of the user. So you can react to what the user types as the user types, and then you see on the screen that the generated code changes as well. So this is a very nice experience when exploring source generators and starting to work with them.
Cool. So it was a very interesting description of incremental source generators, and obviously we've got now a new API for doing incremental source generators as opposed to just a source generator. Is there a big difference between the two? I mean, obviously it's a bit more of an involved API, but which one would you prefer to do?
So I would, if you don't know the target audience, so if you're publishing this as a NuGet package, and basically the world could be the consumers, then I would definitely go for an incremental generator, because if the consumer has a huge solution and huge projects, then with the non-incremental version, where basically on every key press, everything is generated again, this would deteriorate the developer experience. So for these, definitely use incremental generators because of this, of the pipeline effect that I showed at the end, where the incremental generator can short circuit for subsequent generation phases to not emit the same thing again and then be faster about it. However, I guess starting with the regular, if you want to get your hands dirty with generators, then perhaps start with the regular .NET 5 iSource generator, because the programming model is a little bit easier. You don't have to think about the value providers and this pipeline to build up. So this is a great way to get familiar with source generators in general and the Roslyn API, with source generators in particular and the Roslyn API in general. But for production-ready generators, I would use incrementals.
Yeah, makes sense. Maybe also an interesting question from someone in the audience. Is there any tool for emitting C# sources? So far, most people are string building. There's also syntax trees, but they are a nightmare to format and work with and maintain. So what could be a good middle ground there?
There is, I haven't checked it out myself yet, but there is I think a templating, a C# string templating library called Scribian or Scriben, where you basically define a template and then later on fill the holes. I haven't used it myself, but this could be an alternative. But what you definitely should keep in mind that the mean how to generate the C# string should be fast in order to not be a bottleneck in the editor experience.
Cool. I may actually add something myself there as well. And I took the liberty of cloning one of your repos that you have. If you're using the newer version of Rider, the latest EAP actually, we are reworking some of the language engine. And actually, if you add a language injection saying that this code is C#, you will get syntax highlighting inside of the C# strings we have. So that's a really nice one to demo, but also a really nice one to work with source generators.
Instead of just having a plain
amazing
block of string literal, you've got something which is a bit more syntax highlighted. That's nice. I like that.
And I guess this will then, since C#11 also will add raw string literals, where you have if we have a string interpolation, then this will be beautiful. Is this already, or is this in the current preview?
If you use the latest preview, you will be able to use this one. Yes.
I'll use the latest preview today.
Perfect.
Awesome. I think also there's been some work so that Rider should automatically pick up and restart the Roslyn host so that you don't have to reload the project as well when you change the source generator. So hopefully that will...
It actually works most of the times.
Very good.
It's just sometimes I have to restart it, but usually, of course, now presentation effect. Usually, it actually works without restarting. Just hitting rebuild, and it works. Not always, but most of the times.
Cool. Okay. Last question. Then I think there was a great question there saying, is it possible to generate embedded resources, either text or binary, as a project? Does it? Because you're putting in a string there. So can you put in a string of anything, or does it have to be C#?
Not yet. So currently you can only add sources, either C# or Visual Basic. However, the input could be C# or Visual Basic code or any arbitrary additional text file. But output is source text only so far. This may change in the future though.
Okay, that sounds cool. Right, well, thank you very much for your presentation. It was absolutely brilliant, and yes, it's a fascinating topic. And it's also interesting from the examples in the chat that you can do it. You can apply it to a lot of different things. So, thank you very much. I'm going to let's take you off screen then, I think, and thank you. We'll move on to. In fact, I think it's time to change host, isn't it?
Yeah, it's time to change host. So I'm going to disappear for a couple of hours, and then Rachel is going to take my place here. Hello, Rachel.
Yep.
Hello.
Brought Rachel back. Okay, well, thank you very much, then, Martin. We'll move on and get rid of him. And hey, Rachel, how are you doing? Yeah,
doing great. How are you?
Much better now we got rid of Martin. That's always a good thing.
We're so mean.
I know. He's not listening anymore. He's already gone. So this is good. So,
you think I'm gone?
Darn it! All right. So so we will continue to be nice to Martin because we like Martin. But yes, a couple of fantastic talks so far, and we've got another couple of sessions coming up, which should be good. Next session, I think we've got Alain and Lorraine. Are we ready to bring the pair of those on?
I think so.
Let's
for some remote pairing. This looks quite exciting.
Absolutely. Here we go.
I mean, 2 years into that pandemic, and we really needed these remote tools, and there was not many people giving talks on them. So now we have them.
Yeah. Hello, everyone.
Hello, everyone.
Fantastic. So yes, I mean, I guess are you two ready to get going?
Yeah.
Which screen do I bring on first? I see I've got both screens here. Is it
That's
Perfect.
it. Thank you.
That's good. Okay, well then we will let you get started, and I'll take myself and Rachel off. Thank you.
All right. Hello, everybody. I'm Lorraine Steyn. I'm the CEO of KRS. We're a software development company based in Cape Town, South Africa. And we are a fully remote company, and I have the privilege of working with a lot of my remote teams, and we actually use all the tools we're going to talk to you about.
Yeah, and I'm Alain, also director of KRS. My responsibility falls more in the area of training and therefore using these tools on how to do remote training sessions, but also am part of a dev team, which is, as Law said, fully remote.
Yeah, I think the same thing happened to us that probably happened to a lot of companies. 2 years ago hit, and we went from an office and lots of socials and Friday drinks and lunches and football tables to suddenly just seeing everybody behind little blocks on a Zoom screen. And we made the decision to go fully remote and stay that way. So this is now our life, and we need to get the best tools and set new expectations, new ways of working. Yeah, there was a whole lot of stuff that came with it. So we're going to tell you what we learned.
Yeah, so the agenda for this talk is we're going to start off with a demo because everyone loves demos. It's a lot easier to see where things go on. Then we'll talk a little bit about why we've chosen some of the tools that we've got and perhaps some problems with it. And we'll end off with a rant because it always feels like a good thing to end on.
Righty. So we're going to swap screens in a minute, and Alan's going to be the driver. He's going to have a split personality. He's going to be both the host and the guest. I'm going to be the narrator, just because we figure if one person can do the talking and one can do the typing, it'll go a little bit easier. Whenever you see a black themed IDE, you're looking at the host window. Whenever you see a white themed IDE, you'll be looking at a guest in whichever tool we're showing you. Interestingly, all the tools work cross-platform, so our host is on Windows, our guest is on Mac. Not that it matters, just to show you that we have cross-platform as well. So I think that's basically it. I think we are ready to swap over to Alan, please.
Cool.
All right, so let's kick off here. Because it's .NET Days, we thought we'd start with Visual Studio. Precisely Visual Studio Code. And Visual Studio Code has a tool called LiveShare. So I'm sure a lot of you know it. We did say this is a beginner talk, but let's go through the basics because LiveShare's got a lot better in the last 2 years. What we're going to do, Alan, I'm not going to be able to read my notes. We'll have to make sure we can do this. Alan's going to click the LiveShare. I think he's already done it. It's really simple to create a sharing session. Basically, the one side's going to click share and the other side's going to click join. So Alan's going to kick off the share. And while he does that, I'm going to talk to you about, let me just get this up. I'm going to talk to you about some of the things on the left-hand side there. It's not just your IDE that you can share. You can also share a terminal session. You can share servers, which basically means you can share URLs and ports. So that's really nice. I mean, you can share your port 8080 or whatever it is that you've got your web front ends running on. So it's not just doing the debugging and doing the code editing. We can also run. Alan, if you have, okay, so links copy to the keyboard. If you've got guests coming in, we should see what that looks like in a moment. We're not going to flip screens. We'll just stay here and talk you through it. What I'm expecting, there we go. Law requested to join the collaboration session, accept read write. All right, so we've got a read write session going. That means I've got full control. I can do anything I want on Alan's environment. Just to tell you what we're looking at some C# code in Visual Studio Code. It's from an open source cutter called the Gilded Rose. Not that the code matters. In fact, please ignore the code. It's really baby, really simple, just to do the demo. So, Alan, how about let's go and share a terminal, because that's kind of interesting. The one we have right now is read-only, because it was there before we started the sharing. So I think we need a new one, which is fully shared, please. And then you can run the tests for me. There you go. Shared terminal. So Alan's going to kick that off. While the tests are running, I'd like to just mention that we're obviously using the voice of this platform. There is a plugin for Visual Studio Code, so you can have audio as part of your session. It's not built in, but there are, as with everything in Visual Studio Code, 3,000 plugins, and one of them is audio. Oops, lots of red. So that's what we were expecting. Failing tests. Right, I told you this was trivial. Alan needs to go and change the word fixed me to foo. All right, you can save that and run tests again. So I think now what we'll go and do is see what is the guest seeing. Are they seeing the same that we're seeing? So Alan's going to do his split personality thingy and swap over to guest. See the white theme? And it's green. So what the person running the test, the guest is seeing the same experience, the test's been corrected, and it's green. You can also see Alan's cursor in yellow over there. You can just see it at the end of foo. That's where he left his cursor. So there are visual hints about where each of the collaborators are. Alan, I think the guest could do a little bit of typing. We've got another test we can just paste in. So really simple. This is another spelling mistake type. But just to see that the guest is fully able to add things to the environment, and the guest is now running the tests. All right, so good collaboration, and it's red. What we want you to imagine is that the two parties are now going to go off and try and figure out the problem themselves. So I think what we'd like is for the guest to open some other unit. Yeah, that will do nicely, the CS. So the guest has gone off and is sitting on, where will we be? Line 11. All right, cool. The guest is on line 11, something that says this dot items equals items. Be nice to see, where is Alan? Would you like to head back to host? Okay, the host is not in the same place. So you have independent ability to go and scroll through code, even though you're in a collaboration session. Alan, have you found the problem? I think you have. Eh? Well, let's imagine that what you want to do is bring your guest, you want to bring Law back to the problem and where you found it. So could you do the focus participants? It's a really nice option. One little button. We're going to do it on that side. We can do it in either. So we'll go with focus participants. Oh, am I focused?
Yes, you are.
I didn't see the pop-up message though.
The pop-up appears on the other side.
All right. What Alan can do is he can bring everyone in the session into the place where he's working. And when I say everyone, we're talking pairing, but please have the loosest definition possible of pairing. We don't necessarily mean only one person. It can be an ensemble, it can be mobbing, whatever your term is. It can be one, or in Visual Studio, up to 30 guests in one session. All right. So we've focused everybody. Alan's changed the spelling mistake and is rerunning tests. It's as simple as that. There's not a lot more I really want to tell you on this. You can edit, you can share stuff, you can do debugging, you can do all the things you would expect. I think what I'd like us to look at now is just how you do commits. How do we save our work? Thank you, Alan. So this is really nice. Visual Studio automatically puts a co-author onto your commit. And I really like that. I find when I've done many hours or days of pairing and only one side's been doing the commits, I start to feel like my contribution is not very visible. So Visual Studio is using the co-author feature that's available to us in our Bitbucket vault. So that's nice. And we can commit there. Alan, what have I forgotten?
You haven't forgotten anything, Laura. I just want to point out one other feature. One of the other features that this has is the ability to add a comment. And if you're working as a group or doing some training, and you notice something, you can go and add a comment to a line of code. And I will just quickly scroll down and create a comment thread. And we've now got the comment thread. It means you can make a note for something to come back. Maybe you want to refactor something here. And it's just a nice way of, as you discover things, you can put notes in which people can see what's going on.
Okay. Yeah, thank you for that. It's probably also the other thing I did forget was to mention that although we're doing this in Visual Studio Code, this is pretty much all available in Visual Studio as well. It actually comes bundled with Visual Studio. With Code, you've got to add, I think, as a plugin. But
no, the plugin is for audio. It comes bundled with both. And you can do one side is using Visual Studio Code, and the other side is using full-on Visual Studio. So yes, there are some nice features with that.
I think ours has been up for a while. Alrighty, I think we're done with Visual Studio. I think you can shut down all these environments to make sure we don't use resources. And we'd really like to go on to a tool from our hosts, JetBrains. We're going to show you Code with me. And I know we sound like we're just being nice to them, but no, really, we love this tool. It's a great pairing tool. It's available for a lot of their IDEs. We're going to use WebStorm. And JetBrains, if you're listening, you could be adding it to Rider for us. We'd be really, really over the moon. But in the meantime, we'll show it to you in WebStorm and Code with me. So we're back on host, right? Black background, start a session, Alan. Sure, kick it off. All right. There are a lot of permissions in Code with me. You've got quite fine-grained control. That's really good. You can have a read-only session. You can allow editing files. You can allow access to the terminal or not, run and debug access or not, other tools or not, and everything's got custom permissions as well. So that's really all very cool. And it's got the call facility built in. So if you want to do everything in one environment, it's all there for you. Yeah, kick off a session for us. Thanks, Alain. So on the other side, Alan's going to be doing the usual thing. It's copied automatically to clipboard. There's a link. You do the join on your guest side. And here we go. Law wants to join the TypeScript session, security code, and we can accept. So there's also this additional code level of security here, which I think is pretty great. Just to tell you what we're actually doing the same cutter, but the TypeScript version of it this time in WebStorm. So I think, Alan, on this time round, we really want to run our tests, but there's such a nice integrated test runner. Do you want to do it that way rather than creating a terminal? Yes. So we can just kick off the tests with the integrated test runner, which is a very pretty little tool, and it shows you a test so nice and graphically. While it's running, I'll just mention that we could have created a terminal just like we did in VS Code. We would have had the same thing where we had to make a new shared one because the current one would have been pre the sharing and everything else would have been exactly the same. And yeah, look how neatly it's put it all out for us. Expected, fix me, and foo. All right, so you're going to do foo and run it again. Right, are you pretty much ready to swap over to guest? We'll go and see what the guest's seen. Oh, where's the guest gone? Oh, we're on Visual Studio. Too many guests. This is why we're waiting. It gets very confusing. Yeah, a couple of things here. What do we want to do next? Tests are passing. Yeah, the bottom test passed, 1 of 1 test, 13 milliseconds, all good. We're going to write some code again, right? Same as last time. Same procedure as last time, Miss Sophie, if anyone knows what that movie was. Again, we've got our aged breed should increase in quality test, and I do apologize for the cheesy nature of these tests. You can shoot me later. Okay, can we get the test to run from this side? Instantiating tests. There we go. Okay, so we're going to do the same little job of saying, oh, we better go and figure out what's wrong. So we're going to, yeah, we can see it's going to be red. We're going to go and open something. Alan, you can find that TypeScript file for us, Gilded Rose. Okay, and let's go to export class or this.items. Sure, why not? So we're on that line 17. And are we following? Are we doing anything special at the moment? We're not following, are we?
No.
All right.
We can see the host is sitting there. There's a little A at the top, just to say that they're there.
So I think we'd quite like to go and have a look at the host side now. Okay, and the host is in a completely different place. Again, same ability to work. Obviously, all the nice stuff, all the tool tips and the hints and all the great stuff that's built into these tools is all there for you. Something I'd like us to do now, Alan, is actually force Law to follow you. So the first thing is make everyone follow you, bring them in again, everyone, not just one necessarily. And now I'd like us to try and identify the two cursors. You may need to swap back and put a cursor on the other one so that we can exactly see. I'd like to see both cursors on this piece of code. Okay, so laws at the end of foo, there you go. You see the little yellow, orangey, reddy cursor. Gee, my color definition's poor today. And Alan's is the white flashing one a line above. Now we're going to show you one extra thing. So at the moment, I'm following Alan's session, but we can both still type, all right? Now I want you to go into pair coding mode, which is a fancier thing available in Code With Me. And what it's actually done is it's put both cursors together. You can see them flashing sort of that red and white. And this feels to me really more like the physical pairing when you actually swapped keyboards. So you really make sure everyone's engaged and at the same place and working together on the session. So that's pretty cool. All right, so we just showed you how we can really bring everyone together. You want to fix it quickly, Alan? You've already fixed it, thank you. And then run tests. All right, and again, you get the nice little tree of the tests and what's passed. I'm trying to think if there's anything else I really wanted to say on this one. I think the next one is just to look at the commits then. We'll end off the same way as we did for Visual Studio Code. Now it's a little bit different. The changes up top, one file, is the stuff that Alan's changed, and then it actually says changes by law. So it splits the commit by each contributor, which is also really nice. Does mean you need to do 2 commits to get all the work in, but that's pretty much okay. If Alan clicks now on changes by law, it puts an automatic comment in, changes by law. So this one isn't going to use the co-author. It's just going to use a comment. And you can have a team agreement or some way of working that you maybe want to put some more than that as well as changes by law. But you can give credit, and it's really easy to do so. It's sort of built in encouraging you to give credit for each person's work. Certainly it splits the commits, so you can always see who's done what. All right, Alan, anything else on this one?
The only thing you haven't mentioned is the fact that the client is actually a lightweight version. It's not the full app. When you join a Code With Me session, it downloads the client and runs it in there, and all the features of the host become available to the clients, which is a little bit different to how the others work, where you need the IDE set up on your side. This I could connect to someone, and if they needed some help with a WebStorm project or something like that, that's why we're encouraging JetBrains to add it to all their IDEs. It's a great feature inside there.
Yes, I think that that idea that you don't have to have an entire environment all available. Use the lightweight client, and you can join for reviews, for training. It's actually a very, very powerful feature. Thanks for that one. All right, are we ready to go on to the next one? So you can shut this down. We have one more demo for you. And this time, it's a very small, simple little tool, not built into any IDE. This is just a screen sharing tool, but it's particularly good, and it's not as laggy as some screen sharing tools. So we thought it was worthy of a place in our top 3. So what you're going to look at next is a tool called Pop. You find it at pop.com. It's as simple as that. Start a new meeting or join a meeting. Very much a similar kind of approach. When you start a new meeting, you can turn on camera and microphone and do all those kind of things. Alain's going to start the meeting now. It's the same thing of copy invite link. You send that off to the person who you want to have come in, or people, multiple people. Right, when they're connected, then Alain chooses to share his screen. And now what he's doing, he can define the area or the full screen. So we'll just pick full screen and share it. So this is particularly useful when you haven't got a sharing tool built into the tool you need to use. We use it extensively for doing collaboration sessions on SQL Server, Data Group, all the tools that don't have any kind of built-in pair coding mode. All right, so Alain could be typing. There's full control of the cursor from the guest side as well. What we really want to show you on this one is it's got one really unique feature, which we're over the moon about. Alain, could you just point out something? Yeah, there you go, with a pen. So it's got this little built-in pen. And I don't know how often in a pairing session you're busy trying to explain, no, it's 2 lines up. No, more left. You know, with this one, you just go there and you mark it. And you see how cute it is. It just fades within a few seconds. So Alain can turn it into permanent. And we could even both be doing a little diagram now. We could start sketching what we think. No, but it should go there, and then we could do that. And that would be the you know, so depending on your tolerance, of course, for using a mouse to scribble anything. But now whatever we've done is saying, and Alain will choose when to turn it into fade, and there it goes again. Okay, so that's really quite addictive. Anybody listening here, we'd really love a pen in all the tools. So we can point to things, when, just like I used to put my fat finger on a screen when we were doing physical pairing. A couple more things to mention on this one. So obviously, the fact that it's sharing the whole screen, it will be easy for you to share something you need to run to look at, you know, any of those kind of things. It's useful to mention that the tool's developed by the same guys who did the screen sharing in Slack. So it's got pretty good credentials. It is still in beta. It can be a bit glitchy. There are times when you have to restart sessions, but it's free. So we're prepared to give it a lot of credit, a lot of space for that. It's also cross-platform. It even works on mobile. Okay, so there's tons of nice things in this little tool. Just the simplest little thing ever. And what else did I want to tell you? I think I already mentioned it's at pop.com. Right, anything else, Alain?
Just want to highlight this. Some of our teams, unfortunately, are still supporting desktop apps, and all of the shared server features in any of the sharing tools we've spoken about before don't work. So this, we find those teams are relying on heavily because they can actually run the app, step through, debug together as a pairing in their pairing session, and really, really works well. Nice low latency. It feels almost like you're working on the other machine.
Right, so JetBrains, guys, could you swap us back to our slideshow then? That was the 3 tools we'd wanted to show everybody.
Cool, thank you. So yeah, we have seen a message like this before. We now want to just quickly chat about some of the challenges you face with pair programming. And the challenges from management is always a big one. It's, why do you need 2 people? And we're going to talk a little bit about why we say 2 heads are better than 1. Why do we want people to look at this? Why do we work like that? And here's another problem area we just want to highlight. Have you ever had that developer who says, I don't need to pair, I don't work well, they slow me down? That's not great. That's not the sort of attitude we like inside our teams. So we don't like our rockstar devs. We want them to work with the other people in the team. We were all there one day. We all needed to learn. And if you've got knowledge, you should be able to share it.
So talking about the other side of that particular dysfunction, because we wanted to just put some of the problems up at this stage. So problems being, bad bosses, people with egos. And there's also people who are really nervous about sharing. Imposter syndrome, I think it's something a lot of people suffer from, where you just don't know if you're good enough. And of course, you'll never really know unless you pair with people, unless you code with people. It's the quickest way to see, hey, I contributed. Gee, I wasn't as stupid as I thought. Oh, they also didn't know that. Or it's really great confidence builder. But you cannot just tell people you will now pair, because the anxiety that can induce is not reasonable, all right? So you have to do a lot of work before that. You have to create the safe spaces. You've got to already have the ability in your teams to converse and talk and support people and take baby steps, and just maybe start with more ensemble sessions where people feel they can hide a little, then start splitting them off into twos. A couple of ways to tackle that one. But we think it's a really great way actually to overcome imposter syndrome, so long as you do it with care and sympathy and empathy, I suppose, a better word.
Yeah, and for us, we found, as we state in here, pairing addresses so many problems. There'll often be conversations with the Scrum Master saying, oh, we need help in this area. The guys are really struggling on this task. And the question which gets asked is, are you pairing? Is the team pairing? Are they working together? Two heads are always better than one. You come up with better solutions. You come up with a better quality system. That's what we're looking for. That's why we push pairing so much. Another benefit of pairing is you've got that person who knows that one part of the domain because they wrote it. They were intimately involved with it and know everything about it. Now they want to go and leave for 2 weeks and the clients want to change. How do you solve that? Pairing up with that person will allow the knowledge to be shared with people and with the rest of the team, and making sure that you don't end up with silos. You have that knowledge shared. It works together. It's a really big benefit in that area. And then the other part is mentoring. We spoke about the rockstar dev, but when you're starting out, you need help. And to sit and work with someone and go through things, even if you're working with another senior and you found this new feature in the latest version of ReSharper, you go, oh, instead of typing that, what about doing it this way? Just those little hints. We're all learning all the time in this field. Let's use the benefit we have of working together and help one another along.
One of the things that I really love about pairing is how it actually helps me to stop, I've now lost the word. I sometimes battle just get started, you know, that postponing things. Motivation can be a problem, right? So if I know that someone's waiting for me and we're going to be pairing at, 10 a.m., then I need to get motivated. I need to get moving, get my ass out of bed. And it works for a lot of ways like that. It also just is a way that you're connecting with people. So compared to sitting on your own remotely where you never see anyone, and that can be very demotivating, pairing is really a good support for me personally in the way that I work. Just thinking about what else I wanted to say on that one. I think it also just ties back, if you can bear with me a moment, to thinking about how much changed for us. That we used to go into an office and we had people all the time, and suddenly we had no one. I don't know if we all realized just how big a change that actually was for everybody. What I'd like to do is actually just share some personal stories. So, as you heard, we try and pair in all of our teams all of the time. Well, every day at least on significant chunks of work. Earlier this year, we took on a new client, also remote, fully remote. And this particular time, our devs were going to work on a team with other devs, and they were managing the devs. And they didn't practice pairing. And we mentioned it. We were like, we quite like this, approach. And they were like, oh, yeah, we work together when we need to. But, there was not really the buy-in. So we started seeing more mental health problems, and I mean quite serious ones from the people on that team. And we had serious long chats. And they said, no, it's a lovely client. They're the nicest people ever. Really, everyone loves them. They're trying so hard. And the work? Yeah, the work's great. Interesting tools, interesting domain, interesting challenges. Everyone's really, really happy. But requests for 2 or 3 weeks off for mental health reasons, a number of very personal things happening to people within the team, just made us realize that ultimately the isolation is just not good for a lot of people. And there are few who are okay, but for a lot of people that caused so much more stress in their personal lives. So what we've really learned from this experience is that pairing might be something you do for technical reasons, you know, 2 heads are better than 1. You might do it for training reasons, that you want to, you know, break silos and train people. But don't underestimate that it's also for emotional support reasons. Okay. Oh, this is mine too. I have 2 very big ones here. 2 heads are better than 1, right? There's a tendency amongst devs to, the hammer we have is we want to code and people just climb into it. And when you have a pair partner, at the very least, you have to negotiate something, because else you wouldn't know what each other's about to type. So you have to talk about it. And just that business of talking about what you want to do helps you to think a little more deeply and consider alternatives. The other person can be saying, no, hang on, I would have done that. And you're like, oh yeah, but what about this? And you know, that is a really, really healthy debate that goes on. So that's our kind of funny slide to sum that all up. But there's even stats as well that just says that people who pair generally produce less lines of code, simpler solutions, and the big benefit that we're all hoping for is obviously better quality.
Cool. So we've spoken about and we've demoed an informal way of pairing. Let's just talk about some of the different types of pairing and how we found that they work. When everyone introduces pair programming for the first time, they always talk about driver navigator. This idea comes from the rallying world, where you've got one person who's driving the car and the other person has a list of directions which is busy saying, and you're going to turn here, you're going to turn there. And that's often what happens. There will be one person with a keyboard and mouse busy working and typing, and the rest of the people in the pair or group, this could be a mob, it could be whatever, are fulfilling the navigator role. They're paying attention to what's happening, but they're also thinking those 2 or 3 steps ahead, what's going to come next, where can we go? So that's the model which pairing is always introduced with. If you go and do some research into rally, especially a famous rally driver, Colin McRae, said he hardly ever listened to his navigator. So there's a challenge with this, and we've got some alternatives to talk about, which we have found are better. The next one is ping pong TDD. This is where you're doing test-driven development. What'll happen is, I'm driving, I will type up a test and make it fail. Then Law will take over, make that test passed, and then write the next test, which is failing. And it's a great way of alternating, getting your language put together, designing your system through the tests, alternating the work, making sure you're swapping regularly. If you really want to make it a challenge, you can even make it silent ping pong, where you're not talking about it and you need your code to speak for itself. Earlier on, we spoke about that problem of the rockstar developer. Now, strong mode is a system which comes in pairing where the rockstar fulfills a navigator's role, and they have this concept that they need to follow. For an idea to go from your head into the computer, it must go through someone else's hands. Let me repeat that. For an idea to go from your head to the computer, it must go through someone else's hands. So you need to be able to speak and describe the problem space and the solution that you're coming up in a way that the other person is able to code it. This is not dictating console.writeline. You would say rather, I want something to be put out to the console, and understanding the pairing partner, getting them up to speed, because you learn so much more by doing than just listening or watching. And the final type is tag teaming. This one is what happens more naturally as a pair evolves and people start working together. There's not a specific driver or navigator role. You are both hopping between that role in and out. You are talking, you are discussing, you are talking probably 3 times as much to the amount of code that you're writing, because you're talking about it, coming up with a better solution, going, this is where we want to be. we find that our teams which are doing this and the pairing, and even when Law and I pair together or we're pairing with partners, that's what's happening all the time. And this is where that code with me pair programming, pair coding mode is so great, because your cursor's in the same place. You're working together, and it's like, I'm going to type this, and then Law goes, I'm going to type this part, and we hopping. So it's Driver and Navigator, but on steroids, and actually a real world way of working. We said we're going to finish off with a rant, and this is a little bit of a war story as well. So when we went to a remote environment, people started, we had been pairing in our office beforehand, and we were pushing that we want to pair 100% of the time on production code. That's what our goal is inside our teams. So we go into this remote world, and everyone goes with what they're comfortable on. And we have some various icons on the screen there. Just to clarify, we've got Microsoft Teams, we've got Google Meet or Hangouts or whatever they call that nowadays. We've got Zoom, we've got TeamViewer, and we've got Discord. Yes, Discord was used for pairing inside our teams. Why? We geeks, we tend to be gamers as well. So everyone's using Discord, they're working around it. And we noticed these tools, all of them, started generating some anti-patterns with this. The first thing is, have you ever tried to control someone else's screen on one of these tools? Doesn't matter which one, but you get latency, cursor confusion. Try going from a Mac to a Windows machine and you get some funny characters coming out. It tends to come up with this thing of watch the master working. This, your rockstar dev loves, because they go on, they start working, and the rest are watching what's going along. They're not engaged. They're playing on their phones. They're doing other things, dozing off. It is not working. The other thing is these tend to not have the greatest screen quality when sharing, and that's why we have recommended these other tools that we've spoken about, because they all keep, it feels like a native environment which you're working on, and that's the key thing we wanted with this.
Thank you, Alan, for it's very much close to the wrap. We've just noted some credits for all of the artwork and the kata that we used, and we are pretty much ready for a Q&A. Thank you, everybody.
Fantastic. That's a brilliant presentation there. Very interesting. Thank you. I do. Well, there's been some great examples of pair programming in the comments as well. So there's a whole load of people doing, pair programming different levels. Some people doing it 100% of the time. Others sort of at least recommending that their team do proper code reviews as well. You know, sort of if they can't actually pair program, then at least sit down and do a proper pair programming. Code review session together.
So Matt,
yes.
Can we just raise that point, because Law and I feel quite strongly about that. Code review happens after the code is written, which means you need to go back and do rework on your code to fix it up to standards or a missed scenario. That's why we push for pairing so much, because you are doing that earlier in the process. You're reducing your rework.
Oh, that answers my question that I had about how the process fits in with your code reviews and whatnot.
A lot of it's got to do with the seniority of our developers. So when we have two seniors pairing, they might be the same people who would have done the code reviews. Then they can kind of go ahead and, push the thing and approve their own pull request. If it's slightly more junior people, or they don't know the domain as well, then you've got to bring somebody in, of course, to make sure still that, you've done everything right. But at least you've done the most you can to front load it and all your thinking before getting all the way to the end and then finding out you've got a lot of things to change.
Yeah, I was very interested to see that you were finding that you were getting anti-patterns with various tools there as well. The sort of things there. So, I mean, one of the questions we had was whether, how is remote pairing in the sort of the tools that you were showing to start with? How is that different from doing it with an RDP session, or sort of sharing a screen like that? And yeah, these anti-patterns sound like they're a big problem, really.
Yeah, I think it's really a lot of it's the latency. As soon as it becomes laggy, so I don't know, maybe it's slightly different in different parts of the world, but obviously in Africa we have our own challenges, one of which is electricity, although I think the UK is trying to join us in that particular problem.
We're working on it.
Yeah, isn't that strange? Yeah? A lot of us battle with our connectivity. So depending on what kind of connectivity have, we see this really, exaggerated compared to people who may be on very fast links. But as soon as it becomes laggy, it just spoils the session entirely. And then if people aren't having fun, if it's not working for them, they stop doing it, because that's human nature, right? And then everything kind of falls to pieces.
So that's interesting though. How sort of geographically spread are you when you're doing your remote pair programming? Is it kind of mostly just working from home, away from the office, because of recent events, shall we say, or are you kind of a little bit more around the world?
It's getting that way. It really is. So we have a client in the UK, so there's some devs on that one. We have one developer who has moved to far Eastern Europe. We have people spread all over South Africa because they went like, oh, so I don't need to be near the office anymore. So they left, to different parts of the country, not left the company. So we have a developer in the UK as well, but he's coming home for Christmas. One of the people who was based here. And so people are starting to spread out, and that seems quite normal and seems all right,
It's good. So you were showing a variety of tools as well at the start there. So they're doing sort of different styles of collaboration again, especially with the POP, for example. Do you use a mixture of things as you're working? Is it just do you kind of stick with your favorites? If you're using WebStorm, you can use Code with Me. If you're using C#, it's Visual Studio Code and Live Share, for example.
It depends on the project. It depends on the project. It depends what you're doing. So the team I'm currently working on, we actually developing the desktop app, which is where Live Share falls over. So we use POP for that. But the moment we go into any sort of web development, then I'll be hopping between using Live Share for the back end side and using the WebStorm for the front end side. So I like my IDEs. I like the benefits and the tools which you've got and the features which you've got, and to have all of that available, and then to be able to share that with other people makes it easy. So it's all about what can I do, how can I do better, what's going to give us the best benefit at the end of the day. I want Resharper available. That's why we're encouraging for it to be added to Rider, because you've got all of those facilities. So I use Visual Studio with Resharper. And that you can at least share with Live Share, but you want to get it to be that smooth native environment.
Yeah,
we
absolutely.
Also, we don't prescribe for our teams, except we won't allow Discord. It's a memory hungry hog. But we try and tell the teams, well, this is the best guidance we can give. This is what we want you to do, and we try and guide them towards what are good tools. But we try and also treat people like adults. So if you've got a slightly different situation and this is going to work for you, then that's all right.
Absolutely, we kind of agree. Really, it's like we want to provide the best tools, obviously, but if you want to use something else, then that's absolutely fine. We're not going to complain too much. And I should probably mention as well, Rider and Code with Me. The Rider, it is being worked on, basically. Ironically, Code with Me as a protocol, as a sort of actual implementation, is based heavily on how Rider itself works, with like IntelliJ as a UI and something else providing a back end. In Rider's terms, it's Resharper, but for Code with Me, it's somebody else's machine. It's somebody else's version of WebStorm, PyCharm, Golang, or whatever. So the architecture is very, very similar, but because of that, ironically, it's very hard to sort of get it into Rider, because Rider's already got this split, these two parts already. So it's coming. They're working really hard on it, and they're having to rewrite a big chunk of Rider to work with it. But yes, it's been a long time coming, and we hope to get it maybe next version. We'll see. So yes,
cool.
It's on the
Can you put in the request for the drawing as well on the next version?
I did make a note of that, actually. I was like, that's nice. Yeah. So I have made a note of that one. I'll pass that one on to the team. Yeah, absolutely.
So somebody mentioned that you mentioned empathy in the talk, and it's something we don't hear about a lot, but I noticed we're hearing a little bit more about this as an engineering skill. And I think that this is quite a nice area to talk about that. So do you have more comments on empathy in engineering?
I think, one of the things I've said many times is that we think we're in the, we're in the software business, but we're really just in the people business. Because people do everything. So you have nothing until you look after your people. So I don't think it's any different for engineers than anyone else. And I think that everybody's taken a lot of strain the last 2 years. I think it's helped us focus a little bit. In the agile world, there's a lot of talk about, safe spaces, that kind of stuff. It needs to be brought into our workplaces. We've been reducing working hours. We're nowhere near the 4-day week yet, but we're getting slowly less and less hours that we have to put in. We're trying to get that work-life balance and just kind of recognize that you can't do industrial era stuff when you're doing intellectual work. You just burn out and you don't do your best work. So there's so many things to talk about. I think it's probably a bit overloaded for a pairing talk. But yes, I want people to be supported. I want us to support each other. And as tools go, this is a really good way to start getting some of those bonds created.
It's a very, very interesting point now as well about talking about getting overloaded. I mean, I remember when I was working in an office and we were doing pair programming, it could be exhausting. You'd be doing a couple of hours of work of pair programming. You'd be absolutely, way more tired than if you're just spending 2 hours yourself sitting there coding. So do you find that happens with remote pairing as well? Is it a similar sort of fairly intense experience? And I guess how do you deal with that, and how do you sort of fit that in with a normal working day if you want to be doing as much pairing as possible?
It's definitely a very intense process. A lot of it depends on the people, right? So if you're using a mentoring session and at some point in the day you might be doing some mentoring, it's not as intense for the mentor because it's leading someone along. It gets intense when it's equals, what about this? What about this? And I find that's where magic happens. But we do sort of, through the course of the day, maybe swap pairs, jump into different things, and quite often do a bit of ensemble work, as a group.
Okay, so like sort of mob programming, kind of get everybody in to solve a problem.
Especially planning startup. Yeah. Sorry, Alain.
Yeah, no, that's exactly what I was going to say, Laura, is the design phase, the planning phase. Even if you've got a debate when you're working along, we encourage people, just tell us where to jump in and join in with the session to discuss something, rather than leaving it to a pull request, rather than leaving it till later in this process. Let's rather deal with it now, get it done, and get it better. And just to add on the empathy side, for some people, we introverted. We tend to be introverted in this industry. And this is a way which encourages people to interact with people. Otherwise, they would be at the stand-up. Maybe if we do check-ins in the afternoon as well, so they see their team a couple of times a day. This is now getting several hours of engagement with others in the team working, which is very good for that part. But you also have to balance it. We often find with pairing, we don't have cameras on because it just helps with the Zoom fatigue, which is another thing we've discovered in the last couple of years. So these all are things which need to be balanced. But the practical thing is, the more you do this, the more your body gets used to it, and the less strain pairing is.
That's very interesting. I heard a great description of introvert and extrovert. And an introvert needs some time by themselves to recharge, while an extrovert needs company to recharge. And I very much agree with that one. It's great to be working together, and you can do a whole lot of things, and encouraging people to work together and interact is great. But then sometimes you just need a bit of time by yourself then to recharge.
So do you happen to hire people on, or when you first started doing a lot of this pairing, did you have a few resistors? Did they come around? How do you find the attitudes when people don't pair and then they kind of come on board and you say, we do pairing here, and that, or maybe during the interview process, like, how does this work?
It's a lot easier when you're hiring because you can tell them.
Right. But at some point you started doing pairing as a thing. So how was it then when you kind of merged into this? Because I imagine others might have this scenario too.
it's the staff with habits, right? People who, they've got their comfort zones. So they've always worked like this. Why are you messing up my life? You know, I've always worked on my own. And you have to start a little more gently. And we find, you know, planning, because you can say, well, everyone's got to be in planning. Then you can start to talk to, no, but we got to break that silo. And what we found that even the most resistant people, when you say that's fine, if you work alone, you will be on support and standby for that feature alone, suddenly think, oh, I'm willing to show someone. I'm willing to work with somebody. So, you know, I mean, we're doing fairly standard commercial software for clients. So, you know, nobody wants to be on support. Nobody wants to be on standby for calls at odd hours. So we work with our specific problems. And yeah, there's still a few people who clearly do prefer to work alone. But we then just say there's certain things they must do together. And you know, because we can't have silos. We're running a business.
If we're talking about having the sort of more mob programming kind of style there, or at least when you get together, I mean, what kind of scenarios are you working there? You mentioned design, but do you ever kind of like program at the same during this? And what kind of tools and techniques do you use for that kind of role?
I know we do a lot of stuff with, you know, the online whiteboards. Again, that's another whole story about tools, because I still miss a pen. I don't know, there was something about that physical whiteboard that still, I do miss that in the online environment. But we did try and get people to sketch out something, to have put some kind of what we intend to do before you pick up your coding hammer and just start hammering out, you know, code.
Absolutely.
So planning is a big one. But also we just find when we're bringing someone new into a team, they might not be expected to carry that much of a load initially. So we might say join a pair and they become a little mob. There's that. We've got some clients who are amazing for working with us. They'll come into a session and we'll be showing them and they'll tell us, hang on, and we can fix it. And, you know, so that's why Alain spoke a little bit about that tag teaming. We're very happy to let things bounce fairly naturally around, depending on the environment and what's needed. What's important about thinking about the more formal things like ping pong TDD or strong mode and these things is that if tag teaming is not working because you have a dominant person in the group, so they're just taking over and sitting on the keyboard and doing everything, then you have to bring something in and say, okay, we're going to use a timer if I have to. We will swap every 5 minutes, whatever you decide, and agree as a team. So you do what you need to do, because, yeah, comfort zones, habits, it take a while to grow out of them. But
if you're using a time, sorry.
It's fine, go.
No, I was just going to say, if you're using a timer to sort of swap between people there, do you also use the tools? I mean, one thing that's interesting with the tools is that you can both be typing at the same time, whereas, you know, traditionally when you're sat side by side at a desk, there's only one keyboard. So do you find that you kind of can both wander off and go and do separate tasks, or is it still quite a bit of my turn, your turn, my turn, your turn?
I think you've got to be careful of wandering off and doing separate tasks, because otherwise you're in a pairing session, but you're actually working individually. So it is that it's a negotiation, it's a discussion. Who you're pairing with affects how it's going to work. You need to have clarified that up front and say, okay, we're going to work. Maybe it's like a cool, if Law and I are pairing on something, which we do from time to time, especially if we want to get something out or come up with something, then we know we're going to tag team. That's how it's going to work, because we've worked together for a lot longer. On the team I'm on at the moment, we've got a new guy who's just joined and getting up to speed with it, and he hasn't used some of the tools before. So in that, it's more of a mentoring mode. But there's 3 people in the pair often. We get him to type a fair bit more than we would otherwise, just so because of that thing of actually doing it helps. So I would bring big caution against wandering off and doing your own thing. But when you're debugging, this is just going back to what you said earlier on about breaks. If you're debugging or it's a complex problem space or you need to investigate something, that's a great time to go off solo.
Why? How so?
Well, if you've got a complex problem, you can explore more parts, especially when it's something which needs to be solved under quite timeous pressure. You can go, and then when you find something, you say, guys, I found this. Should we go? And you bring people back together, because it's many sets of eyes now exploring the problem rather than just focused on what the one is. And I personally struggle. Sorry, Rachel?
Oh, sorry, but in divide and conquer.
It is divide and conquer. I find it quite difficult to debug necessarily, because the person who's driving will see the pop-ups a little bit faster for what the variables are and things like that. So I struggle with debugging in a pairing mode. That's my personal experience, and that's why you've got to work out. So I will often say, let's debug independently, and then when you find something, you bring it back together and look at it.
My one is that there's times for talking and bouncing ideas, and you get better ideas, and there's times for thinking on your own. We're very complex beings. So sometimes I have to go for a walk with my dog to solve a problem because I need thinking time.
Yeah,
and sometimes I can't sleep on the station.
You can only shower so many times in a day to think about stuff or drive around the block.
We need to acknowledge whatever we need in that session. The only criteria that I try and talk to people about is, as long as you're engaged. If you find yourself just like disengaging, then it's time to split. It's time to say, hang on, I'm disengaging. Let me either take a break, or I need to go think about this, or so follow that as a rule.
Brilliant. Well, thank you very much for an absolutely fascinating session there. I've really enjoyed that, and yes, we'll try and get Code with Me into Rider and the pen. Yeah, so that sounds good. But thank you very much, and yes, we will take you off screen now, and we'll see if Khalid's about. And yeah, thank you. And is Khalid here? Let's bring Khalid on now, because we're going to have another handover of hosts.
Here we go.
So
host volley.
Yeah, so it's spooky season, and the spooky internet just cut out on my house. So praying I don't fall off the internet here, but if I do, I apologize. But yeah, go ahead, Matt.
I was just gonna say, yeah, try and stay online, please, because
I'm holding on. I'm trying.
Hold on tightly.
I also blame Gremlins when the internet goes out, because why not?
But Matt, you've explained why Rider doesn't have Code with Me so much. You could probably say your reasons in your sleep at this point, I imagine.
a little bit. It is. I do like the fact that it is. Well, I just like the irony behind it. That it's the people came from the Rider team. They had this split between the front end and the back end, and they just kind of what if the front end and the back end were on different machines and you got remote development? What if the front end and back end, what if we had lots of front ends, and that's Code with Me? Mm-hmm. And it's worked, it's working really great for the rest of the IntelliJ platform, for IDEA, WebStorm, Goland, and what have you. But because of Rider's own complex architecture, it's a bit tricky.
Yeah.
So
Rider in a way is always ahead of the curve, but sometimes the last to get certain features.
I know. Alanis Morissette would be proud. Well, one for the teenagers there. It's,
yeah. But yeah, you guys have been doing a great job. Martin, Matt have hosted this morning. Rachel, you just came on, doing a great job. And Matt, you're probably getting really tired at this point. So I will relieve you of your duties, sir.
Thank you. I'm going to stand down then, and I'll leave you to it then.
Yeah. Thanks so much.
See you later, folks. Enjoy the rest of the day.
Yeah.
See you later.
Hey, Rachel.
Hey.
How's it going?
It's great.
Great. Awesome. We do have our next guest waiting in the green room. So maybe I should add Layla, live coder, Microsoft MVP, GitHub star. So let me add her now, and we could say hi to her.
Hello. I get left with the two troublesome folks I see to host me.
Oh my!
Double trouble.
Oh my! I've been besmirched. How dare you? No,
$5 words there.
I see.
Yep.
Yes.
Someone in chat just said it's Layla time, which I imagine means you're a pro wrestler now. So
Yeah, that's I give you a shout out in this talk, Steve. So that's Steve Talks Code, Steve Collins. He's awesome. He's like my pair programming buddy. He probably doesn't want to be my pair programming buddy, but I'll be like, Steve, I'm stuck. I do that to Martin as well. I'm like, Martin, I'm stuck. So yeah.
yeah,
it's,
Martin's great, and I give him a hard time sometimes. But
do you?
all the
Do
time.
you?
do I? I don't know.
Daily.
I don't think so. I don't see a barrage of
Like a
stuff on
thing.
Twitter from you, Cully.
See-
No memes, no superimposed faces. Never.
Some are
Never.
just internal memes because
Mhm.
Martin is one of my .NET heroes, and I'm privileged to work with him. So just to say that and put that out there. But we could chat with you all day, but we want to respect your time and the time of our viewers. So if you're ready, we can kind of get to your talk, and we'll chat with you
Sure.
afterwards.
Alrighty.
I'll share your screen, and then Rachel and I will leave you to it.
On your
So,
bikes. Get lost. Yeah.
bye.
Bye. Hello, everybody, and it's nice to see some familiar folks in the chat there. Howdy doody. We're not going onto the .NET drama llama meter just yet, and I don't have a problem with llamas. Okay, so Khalid has already told you a bit about who I am. I can't make this any bigger, so I'm sorry, but this is me. This way, I'm looking at myself in the picture. I'm a developer advocate at VMware. I've done all those things, but the more interesting bit is down here, GitHub Layla-P, because all the code I'm going to show you today is on GitHub. So you don't need to follow along and jot down notes, but you can. Look, I have a pen. I always have a pen or a pencil or a plethora of them. Here's the pencil on this side. So as long as you've written that down, you'll be able to find all of this code. And you can find me on Twitter and Twitch under Layla CodeZip. And on the interweb at layla.dev or laylacodes.it, whichever you prefer. So today, in this one, ASP.NET Basics for Experts. Now, I did this talk from the perspective of someone maybe coming from another coding language, so say Java, over to .NET. Or someone who maybe has been doing the same thing over and over again in framework and wants to move over to .NET 6. Maybe they're wanting to upskill and they want to know how they do the things that they did in framework, because there's still so many people running on framework, to come over to .NET 6. So we'll go through top-level statements and the minimal hosting model, and those are all sort of new things that came in with .NET 6. Global using directives, dependency injection, and inversion of control. That's what IOC stands for. Minimal APIs, we'll touch on those, just a few little tidbits for those. HTTP clients and client factories. Resiliency and circuit breakers with Poly. And so maybe some other stuff, we'll see. I always say maybe other stuff, but I never have time because I do too much of the chit chat. But that's all well and good. Let's start and have a look at where we've come from. Now, we've come from .NET where I can't speak today. Everything's coming out a bit mumbo jumbo. So, .NET 5 Web API. I want to have a look at that to see what we had previously and why .NET 6 is so different. And when .NET 6 came out last year, I threw every toy out of the pram in a strop because I didn't like it. And now I'm like, oh no, all the toys can come back in. I'm much happier with it all. So let's go and take a look. We have a program file, and let's zoomity zoom in. And in here, we've got not a lot going on, really. We've got main, the program main. I want you just to note all of this indentation and stuff like that. And then we have our host builder, and then we're telling it to go over to startup. So let's go and check out startup. And this was my happy place. This is where I did all of my code and everything. So if we come in here, let's expand. Oh my goodness, so much space taken up with that. Well, at least Rider minimizes it all for for us. So that's a good thing. But you can see we get our configuration injected for us, and we go and assign that, and then we can go and start adding things to our IOC container. So that's our inversion of control, which is our container of things we want to use, and that's called iService collection in our application in .NET. And that just comes straight out the box. It's awesome. Dependency injection is just straight in .NET. I love it. No needing to bring in any of those old things like Ninject. I had to work with Ninject a long time. Was Castle Windsor dependency injection? I can never remember what Castle Windsor was. Anyway, I had to work with that. I can't remember. I blocked it out of my brain. I sucked it out and threw it away because it was all far too stressful. So this is where we can add our services. That's going to annoy me, that big old space. And in here, this is just straight out of a template. And this is where we would add our services. So if you had any custom things that you wanted to inject into your controllers, you add them to your services. And then down here, this is the app. And this is your web application. And what we do is add middleware and other things in here and map the endpoints, which if you are in Framework, you remember you used to do that. I can't even remember. It's so long ago. You used to have to put all your mapped endpoints for your controllers in that thing down the bottom, and priority list. I can't even remember. So long ago. That's been sucked out of the brain and thrown away as well. So we've got this, and this was all really good. And then .NET 6 came out and said, no, none of this. So I think to truly understand this, let's go and make a .NET 6 application. And I'm going to do a minimal APIs one. Let's make a new directory in here called temp. Oh, why? Oh, because I've already got one. Really? Thought I deleted that. No, I didn't. Right, okay, cd into temp. And is there something in there? But it looks like it's empty. Okay, so let's go and make a new .NET application. So we're going to go .NET new web API, and this time I'm going to just go minimal, and this is going to make us a minimal API. Let's go. Oh, it's a single. Too many of those. Let's go. There we go. Alrighty. So if I go and open this, we'll just have a look in code. And what we can see is now we have this one program, no startup. Now, if you were working in a console application in .NET 5, you probably didn't have a startup file as well. I always added one because I was so there living in that startup.cs. But oh my goodness, does this not look very different? Let me just go back, look at this program compared to this program. And let me expand those. Well, it's very different. First of all, we've got these things like namespaces and program and then main, and then we do stuff. But here, we don't. It's all gone. I now have this web application up here. And what this means is in an effort to get rid of a lot of ceremony from our applications and make it more appealing to developers from other ecosystems, a lot of the ceremony is gone. And that's because this is now a static method. We don't need to put program and main in there. You can, you totally still can, but you don't have to. And so this is a top level statement, which you may have heard about. So now we've got this web application create builder, and we have a builder, and here in that builder, we've got an iService collection, and we add all of our services just as we did in the startup file. And then once you've added all your services and you've done all of that, everything's added, you can then build it. And this is a web application. So if I just go web application, that will make it clearer. And so you can see now we've got this web application, and just like before, you can add all of your middleware. This is a minimal API that was with that tag -minimal. So we've got one of those in here, but I totally could add controllers in here if I so wished. So that's sort of it. It was quite the change, and there's lots of things going on here that I'm going to dig into, but let's go and dig into this in my big application, which I've already created. Is over another window. what I just want to do is bring you all over onto another screen. There we go. And is that right? Did I do that the right way? There we go. All right. So I'm testing out desktops on Windows. So I'm a little bit like new to it. So I want to bring you in all your questions over. Okay. And Rachel says, yes, Castle Windsor is an IOC container. Yes, yes. Yeah, I remember those. Okay, so I have this application. It is a top-level statement, and it has minimal APIs, and it has controllers, because yes, you can totally mix and match them completely. No issue whatsoever. All right, so let's have a look here. Now, that was something that we didn't look at on here, was why do I have so few using statements here? Because we don't have anything. And that is because of this implicit usings enabled. What that means is that every application comes with a core set of references to common NuGet packages that you would use for that application, such as system. Yay. So now we don't have to have all of the system stuff just here. So we don't need any of this. It's just implied because we have implicit usings. So that's a pretty awesome thing in my mind. But you can see I still have stuff. I do need things like system.text.json. So let's have a look at first how we can get rid of some of the stuff up here, because you can totally make your own global usings package. And let's go and do that now. So I'm going to add a new class, that'll do, and we'll call this, you can call this anything. It could be called Bob, it could be called troublesome, whatever, mean-tastic. I recommend global using or usings, and let's go and have a look. We can get rid of all of this. Let me zoom. And then anything I want, I can take out of here. We should see some squiggles. We've got red squiggles there under program, and I'm going to drop that in here. And it's still red squiggles because I need the keyword global. And now you can see the red squiggles have gone, and I've put this here because I think system.text.json in a web application is going to be used across multiple files. So I'm quite happy for that to be in my global usings. Now, things that I'm probably not so happy is like DTOs. I don't want those everywhere, or entities or something like that. So don't go crazy with plucking out all of your usings and bunging them into a global usings file. Only take the ones that you want everywhere. Scoping is still a safe way to go. Okay, don't scope everything. Don't start creating aliases because you've globally scoped everything. Do it with some common sense. All right. So we've got that, and now system.text.json is available everywhere. Okie dokie. So let's go down and have a look. We've got this var builder, which is pretty cool. That's what we have. And what we had, if we go back in here, if you remember in our startup, no, go away. We had our configuration, but we didn't have that straight out the box in that template. So what we need to do is within our builder, we have a configuration, and we can start to add things to it. And we can add a JSON file, which is our app settings. You can say it's optional, all of those things that you've probably seen plenty of times. Please increase font editor size. You mean this bit on the left? We can try that, but it's probably not, we're not going to be looking so much into that. Settings, let's go. There we go. Hopefully that has improved it for you. So let me know, Khaled Norden. Okay, so what we have here is configuration, and we can add our JSON files, add environment variables, add user secrets because they're still all there, and then we can even add command line arguments. And you can configure this however you want, and then we can build it. We still have our controllers added, and we have endpoints API. That's to do with OpenAPI, Swagger, and SwaggerGen. So that's going to be our Explorer, which is kind of useful when you're developing. So then we come down. There's loads of notes in here. So as I add stuff in, if you come to look at this on GitHub, you'll see the notes in there. We build it, and then we map stuff. And then I've got this minimal API down here. And it's pretty horrible. So what have we got going on in here? I have this HTTP client with a using. So I'm basically newing up a client because my ingredient surface needs this client. My waffle creation service needs the ingredient service because we're talking about waffles. I forgot to say, I always talk about food. I love talking about food. So today is waffles. Sometimes it's tacos, but today it's waffles. So I need to new up all of these things to go in here. This makes it really horrible. Goodness knows how many clients I'm creating. Who's managing those? I mean, we hope that it's going to be managed for us, but you know, who knows? It's all just pretty gnarly, but I should think it works. So what I'm going to do is just go back over here, and we can close this file. How do I escape you? Oh my God, I can't escape. Oh, Visual Studio Code has dominated the world. That was crazy. All right. So I am going to cd up out of here, and I have an API in here, and that is under Ingredients API. So we're going to cd into that Ingredients API, and let's go and have a quick look at that. And this is an Azure function. And this is going to serve up our ingredients. And I've got this because later on, we're going to show some resilience with this. So let's have a quick look. We don't want it doing that. We want it to always return. Good. Okay. So we're just going to get it to always return positive for now. And now we can go func start, and then I think it's C# like so. You need to do this because it's a, you know, nested projects. Go, go, go. All right, we are booting our Azure function. We should get an API. Fantastic. There we go. There's our endpoint. So now we have that running. Let's go back over here. So in my ingredient service, it's already doing that. I am going to see if I can get a new window up. Let's have that. No, let's just get a guest one. No, that's not what I want. I know. I can have one up here. There we go. All right, so now we've got that. Let's go and press play. Just don't mind all those warnings. It's all good. All righty. So what we have here is Swagger has given us a lovely Explorer. And you can see these two are from the controller that we have. And this one, which is in the root namespace, is the one we have here. And we can see that get waffle toppings. And yeah, of course it's going to work. She says, please work. Yay, it worked. This was that. Like, oh my God, it's not going to work. We've got a whole load of toppings. That's come from the API that we've created, and then some bases. So alrighty, we've got that. But we can do so much better because I totally don't want to be newing these up, not when I have a dependency injection. So the first thing I'm going to do is whip these out. And I'm going to bring those up here where I like to do all of my dependencies. So I'm going to drop them just there for now so we know what we need. First thing we're going to do is builder.services add HTTP client. So we've got that. That's our first one. And now I can get rid of this line. And that's going to use the HTTP client factory out the box. And that's going to manage all of our clients. It will stop us getting socket exhaustion. It's going to cycle all the pools, and all the kids will have fun splashing around, and it will all be managed for us. And we don't need to worry about it. So now the next thing, and that's just a generic HTTP client like we created. But I will show you in a little bit how we can be more clever with that. So now we're going to do builder.services.add. Let's add a singleton. There are 3 lifecycle states. We have singleton, we have scoped, and we have transient. We probably won't have time to go into those. Now, waffle ingredient service, if I head over to that, you can see it has that dependency of HTTP client. It's not implementing an interface, and then it just goes and gets some stuff. So when we come to do that, we need to, there's no interface, so we're just going to ask for an instance of that. Boom, that line can go. Now, the last one we need is the waffle creation service, and this does have an implementation of the iWaffle creation service. So we've got 2 implementations of this. So there's several ways that we could inject this, and I probably won't have control. I totally have control. I'm totally in control. Time to go in here and look at the different ways that we can inject those, which I have listed in there. But if you are looking at the project, there are all the different ways that you can consume one of these. So what I'm actually going to do is we're going to work with the interface. And this is, I like doing this because if you change the implementation, you only change it in one place in your program, and you don't need to go and change it in all the places that consume it. Because with my waffle ingredient service, if I go and if I want to change the implementation of that without an interface, I have to go and find all the places that's used and swap it. However, if I go with add singleton here for iWaffle creation service, and I can say I want this implementation please when an application requests it. And equally, if I wanted a different one, which is called another waffle creation service, I could just go like that, and that would be used across my application. So that's pretty cool. I'm going to stick with this implementation, but then we need to go back down to our API, because you're like, you left that all with broken code. I so did. And just like you can with a controller, you can just inject a service straight into this anonymous function. So I've just injected iWaffle creation service here, and let's go and run and see if that works. And we'll try it out. Let's execute. And we've got a whole load of toppings, and it totally worked. Fantastic. So you can see we've just quickly refactored into a nice way. But dun, 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 one of my biggest issues with this way of doing code in a long, big sort of script style, because this looks like a script. This doesn't look like C# that I'm familiar with from years and years of working with it. This is like very alien when I first saw it. It's going to get messy. Can you imagine if I add every service? You've got a big application, you're adding every service, but hey, we can tidy this up. And it's a really simple way of doing it. So I'm gonna get these out, and I've written some extensions. And I love writing extensions. So let's just minimize this, make it super big for Khaled. And what we're going to do is extend our iService collection. So I've stubbed out a thing here already, but the first thing I want to draw your attention to is the name of our class. Firstly, it has to be static because we're going to be extending iService collection, so it has to be static. But then you can call it whatever you like. Now here it's called dependency service collection extensions, but I have actually been enjoying calling it iService collection extensions. And you'll see it's squiggly because that's already been used elsewhere. And that's because I have been experimenting with having them as partial classes. You may be going, get away with me, partial, blah. But each your own. You can call it whatever you like. So I like to call them all partial class, and then independently, the name of the file is what they're doing. That's just my preference. So now we're going to write the actual extension, which is public static, and it needs to return, let me just minimize that. So we've got maximum screen size, and we're going to have iService collection. This is going to be called add dependencies, and there we go. Okay, so because this is a method chain and we're extending it, we need to use the keyword this, and we are going to ask for iService collection, and let's just call that services. Awesome. And the last thing we need to do is return something resembling that, which is return services. And now we've written our extension, and we can shove whatever we like in here. So let's do exactly that. I'm going to just rename those. And I've brought all of those over. And to consume this, I now go back over into program. Why are you upset? What's your problem? It's fine. It's just being a bit slow. So now I can go builder.services. And because this extends iService collection, it's there. And those dependencies are added. Now let's just do a quick test. And we'll get it, try it out, execute, and we've got all of our toppings. Awesome. What I want to do just quickly in here is just cover a topic that I never came across, but one of my teammates asked me about. So I'm going to cover it, and this is about private dependencies. And I'd love to know people's thoughts on this and see what you think. So the idea is if you have a service that depends on something that you don't wish to be globally available. Okay, so let's go down and have a look. And this is Steve. Steve Talks Code. So good old Steve Collins really helped me with all of this, understanding things, and has written a wonderful series of blogs on managing life cycles and things like that, and iDisposable. So I strongly recommend checking out the blogs. All right, so what you will see often is someone will new this up, and that's okay. We've newed up this marketing private dependency. If it does do iDisposable, make sure you're calling iDispose, dispose on it, and make sure you're dealing with that because we've newed that up. There's nothing managing its life cycle. So what I have seen is really what on earth was that? So we're going to have builder.services. It's because I'm using builder services dot add singleton, and then I see no type, and we're just going to add MD. Okay. And that's happy. But because we created this outside, say this had implemented iDisposable, our IOC container is not going to manage that life cycle, okay, because it has no awareness of when it's created or anything like that. So this is a bit of a code smell. If this doesn't need to be disposed of, and then don't worry too much about it, but let's just assume it did. So then what we need to do is add it like so. We're going to add it to the context, which is our service provider, and then we can add it like this. And now it's newing it up within the context. So our IOC container will manage this. And then this one here is still private and it's not being globally shared, but this one, which has a dependency on that, is getting added to our IOC container and is globally available. So that's just one thing I wanted to cover. Now, this is a way that you can order your dependencies as well. You can have loads of private methods in here, and then you can extend them here. So for example, we could have services.add marketing dependencies. So you can further subdivide up your applications however you need to. I'm just going to comment that out because I don't want that interfering with anything. So perfect. We now have time for a drink. Okay. So we've got this really nice thing here, and we can also do this for our databases. All right, so we'll just add it here. And I'm going to cheat because no one needs to see me fumble through this. You're all going to be, why are you all having a little? There you go. You're all coming happy now. They were just all a little bit unhappy. All right. So just as before, let me just minimize this. This is a really long one, so I'm going to try and zoom in and pan. I've extended iService collection for databases, and this one is slightly different because we have our services.add.db context and then our type of DB context, which is waffle DB context. And then we have all of these options, and this one happens to be SQL Server. But what do we need for our database instance? We need to know the connection string. And this is coming from our app settings. You can see in here, connection strings, default SQL. Yay, go me, not doxing myself. It's set in user secrets. So because we added all of this here, that will be pulled in and available. But how do we get our connection string from this into here? And that's because I'm going to pass our configuration. So I can go and say config.get connection string default SQL. So that's all convention based, and inject that. And then when I come to use our add database in here, we can go builder.services, and we're going to do add databases. And in here, you can see it's unhappy because it needs not this first part, because remember that's just saying this is the extension. It needs the configuration. So we can just go and grab it, which is builder.configuration. Done. Perfect. So nice and clean again. We don't have all of that big, long, wide code messing up in here. So you can see I've got loads of notes in here, and well, that looks pretty good. But there is more that we can do to make this tidy. Good to have another drink now, something different. Right. So I want to go back to our add dependencies. Now, remember when I spoke about our HTTP client, and I said this was just a generic one, and we have this waffle ingredient service that requires an HTTP client. Well, we can go and make this even better. Yes, it's a word. Do not question me. My mum told me it was a word. Betterer. Okay, let me just get rid of some of these here. And I'm loving all the comments about waffles and your favorite waffles. My favorite waffle is a proper big fluffy waffle with sliced fresh strawberries, vanilla ice cream, whipped cream, and chocolate drizzled all over the top. Oh my God, it's like heaven, heaven. Icy cold, like strawberries. I deserve one of those now after this talk, but I won't get one. Anyway, moving swiftly on, I have another extension called Clients and Policies. This is a really fun area. So I'm going to just minimize this and let's go zooming in. So just like before, you can see I've got public static partial class iService collection extensions, and I've called this one Add Clients and Policies. And that's because, let me just drop what we had. We had HTTP client. That's great. That's generic. But if I remind you this here, do something magical with this. So I'm actually just going to get rid of that. Now, this, as I mentioned earlier, is HTTP client factory behind it. So we're going to do a named one. And this is, where's my cursor? There we go. Services dot add HTTP client. And this time, rather than just that, I'm going to give it a name. you see, it comes up. Name, let's go JetBrains. And then here we can start to customize this particular one. And let's go down onto a new line. And then you can treat it just as you would if you were creating your client or adding things to your client in after you've newed it up or injected it. So here we can go client.base address is equal to new URI. And in here we can go HTTP s something, I don't know, something.com, whatever it is. Okay. And here you can go and add whatever you need. You can do your headers, you can do your cause, despicable things. It's always cause, isn't it, Rachel? Always cause. So you can go and customize it all here, and then you would go and I'm totally gonna mess this up, but let's go and have a go anyway. I haven't practiced this for a while, so let's just say we were asking for that. We can go, I'm so gonna mess this up, live coding at its finest. I can go give me an HTTP client factory, there it is, and let's just call it fac. And then we can go fac.create client, and then I think we can give it a name. We totally can. And then we can just say, can you give me JetBrains? And now we can just say, oh, let's go client equals, oh my God, there you go. And now that would be a var. Well, actually, it'd be a read only. It would be done properly because this isn't any use to anyone. But that's how you can go and fetch that HTTP client and now use it. So you inject the entire factory at this stage. Okay, so that's pretty cool. But let's go and see even cooler stuff. That's a word too. So coming down here, I'm going to add a strongly typed one. Just ignore this line here for a moment. So we can go services dot add HTTP client. You can see, right, it's giving me my angle brackets. And this one is going to be waffle ingredients. Waffle, some random mashing of keys, waffle ingredient service. Boom, amazing. Now, this has handled it all for me. It's made it its own HTTP client, and I didn't need the two-step thing. I didn't need to add a client, and I didn't need to do it as a singleton. It's all done for me. It's magical. And now I have a strongly typed HTTP client that I can inject in places. So that's all handled, managed for me, and it's awesome, and I love it, and that's great. But what else can we do with HTTP clients? Well, let's go and have a quick look at our ingredients API. Now, at the moment, this is going to always return, nearly always if I'm connected to the internet, a good result. You see, it's like all is good, everything's peachy, but that is not the case of the internet, is it? Because no, that is definitely not the case. So this is now going to work 50% of the time. Let's just go and restart that function. Let's go Control-C, restart. And you can see that. We'll come back over. And now let me go and run this. But first, let me just bring the clients and policies and add that. Don't forget to add these. I've already got it here. All right, so that's all peachy. And let's go and stop and run. So hopefully this should all go. But now we might not always get a positive. So let's go and see. If I execute, I didn't get any toppings. It failed. And if we go over here, you can see error. It's really angry. Now, I'm miserable because I don't have any toppings on my waffle. And this is not great for our end user. They're like, oh, do they not have any toppings? Do I just get a plain waffle? Boringness. So let's see if we can make that better by adding in some resiliency to our application. Okay, so I'm going to just close some of these. And that's what I've got here. And I'm going to use poly. And if we look in here, I've got poly circuit breaker. And I've got poly. So that's just a NuGet package brought in. And that is Windows.poly, something like that. Is it Windows? Did I really say that? Let's just have a quick look at what it is. It is Microsoft. Yes, not Windows. Oh dear, oh dear. It's definitely not Windows. So it's Microsoft extensions and then http.poly. So we're going to bring it in like that, and that brings in poly just to use. So we've got that. I'm going to do a circuit breaker. And I should really explain what a circuit breaker is. So let's do that now. I have a lovely picture of a circuit breaker. Now, if you are familiar with electrical trickery stuff that's in your house, you know you have circuits and you have a circuit breaker. And that's like if you trip the circuit or your power goes off and you have to go and flip the little switches, okay? That's basically the pattern we are using in our software. Closed is good. That means we've got a continuous loop. It's closed. The responses are traveling. And what we can do is set a failure threshold. So we'll say, if it fails X number of times, let's flick open the circuit breaker and stop, because something is obviously wrong. And then this could be because the service that we're making requests to is having a wobbly. It's down for the count. It's waiting for its pod to come back up. It's just not there. It's overloaded. It's just having a timeout. So what we're going to do is set in a delay and hope that that other application gets itself sorted. And to test that, we're going to send one response. And that's what half open is. And we'll send one response. Oh no, it's still all gone. Kablam, let's open that circuit again, and then we wait again for a longer period of time. However, if we send a request in, a test one, and it's like, yep, dealing with that, say, oh, okay, let's close the circuit and start sending off our traffic again. So that's basically what happens. So let's go and see that in practice. And I have a fair few different things going on here. There's a great series of blogs on the Twilio.com site. I can't for the life of me remember the author of them at the moment, but you can go and search Twilio and Poly, and you'll get some great blogs on policy. And I use that for a lot of these ones here, which was where I found out about wrap async. This was epic. I'm so pleased by this. So I have 3 different policies here. A fallback, which is like, oh, what do we do? What do we fall back on if everything goes wrong? How many things do we retry and when should we retry? And then what is our circuit breaker? So if I scroll down, the first one I've got here is my circuit breaker. So you can see my failure threshold is 3. So that's the number of failures we'll do before we activate our circuit breaker. And then we've got the time span of a minute. And then we've got some things where we can do some logging on break, on reset, on half open. So you can see down here, we've got on half open, on reset, on break. So you can do some logging or whatever you need to do in that. Next one is retry. So this is going to say if the status code is not found, we're going to try again, and then we'll try 3 times. And then the fallback policy, well, this would be where you could redirect it somewhere else. You could pass a message. You can do whatever you need to do. And now we are going to add all of those to here. So we're going to go .add policy handler, and I'm just going to pass in the wrap in there. Okay, so I've wrapped them all nicely and I can add here. And you can have a different policy for each HTTP client. And I will say that the order these are in is very important as well. So there's a path that your response goes through, and that's why these need to be in an order. So I'm just saying, if you look into it, you need to have a make sure you get these in the right order, and check out those blogs and the policy, the poly docs as well. So what I'm now going to do is let's make our API fail every time. So if I do that and that, And that. Okay, so this is always going to say internal server error and error. And I just need to restart this. And that's all peachy, so we'll come back over. All right, now I have a policy added to our HTTP client. I'm hoping that we're going to see something better happen. So let's run it. Okay, so I see that Dave Arnoldi, no, wait, how do you inject a specific strongly typed HTTP client? Okay, so a specific strongly typed one is this waffle ingredient service. And if I show you where that's required, and that is in our waffle creation service, here it is. I've injected my strongly typed HTTP client, just like that. So then it's ready to use and it's all dealt with and handled, and that's it. That's it. You just use it like that. Okay, so let's go here. Now remember, this is going to fail. I'll just zoom out a fraction, because what we'll expect is, I tell you what I want to do is bring this over onto the screen. Okay, because I'd like you to see all the error messages coming up. No, not you. Did I just close it? I did. Oh my God. Oh no, that's the wrong screen. That's why. Let's go here. And we want that one on there. Okay. This is the right one. I'm so confused then. I need to color code different instances of rider. I bet you that's something I could do. So I'm expecting to see error here. Let's try it out. Okay, so we've got an error. It's still going. You see it hasn't done it? We've got another error. Still going. Remember our threshold was 3. Error. You can see the time between each one. And now we're into our circuit breaker. Boom. Our circuit is open because we had 3. The 4th failed. We've got our 500, and you can see the circuit is now open and is not allowing calls. So you can see how it tried 3 times, and then it was like, nah, this isn't working. And now we've dealt with that. We can add in things there that would add logging, that would tell the client, like, hey, we've got a problem, try again later, or here's an alternative. We've made our application so much more resilient, rather than just say, oh, it's an empty list. I mean, how was that helping anybody? That wasn't. This will do, because you as the developer can do more things with it. So we've instantly increased our resiliency to our application. Fantastic. Right. Now, what else did I need to tell? Minimal APIs. That's what I wanted to talk to you about. So there's our resiliency. That's great. We've got 13 minutes. I know you've got questions. I'll be quick. Let's go down here and have a look at this. Okay. This here is our API. And just like before, if we have loads of these in our program, it's going to get pretty horrific. So I have an extension. I'm going to take this one out, and we should stop. And let's go and have a look at this. So this one's awaitable. Yeah, you can totally do that. And then we can come over to not our services. We want our extensions. You can see I've got add APIs async. And you can order this however you wish. So let's drop this in. We've got it in, and you could say have all your posts in one private, just like we did in add dependencies. You could have, I don't know, however you want to order them. You could have all of these different ones and then add them all like you've done this in one. So however you wish to do them and organize them. So here we have our injection, but what about a post? because we can do all sorts of things. That any of the verbs are available. And what I'm going to do is just copy that. So let's start by going map post, and it can have the same name because it's a okay, and then we're going to go and make our anonymous function. Okay. So because it's we're using the REST pattern, we can have them both with the same name. And let's say we still want our waffle creation service. Let's have that in. Let's still have it async. And then let's go on to a new line. Actually, well, I won't bother with that. What are we likely to do? We'll probably want to have something in a body, won't we? So if I have order, because that's what I'm going to say. I want to pass in my order to get my food, please. I want that. And what would we do in a controller? Well, we would put from body, and you can still do that in your API here. And then I can just go var o equals order, and we'll put a breakpoint on that, and we should hopefully see not vat, a vat of waffles and chocolate sauce. So let's put a breakpoint on that, because I want to show you that you can still do your injection and your sort of like API stuff all in one go in this anonymous function. So let's hit debug. And you can see now we've got our get and our post. Swagger's done its little job of finding stuff. So let's go and have a look in here. So it's telling us this is what the order should look like. It knows what that looks like. And now I'm just going to go like 7. And let's say the base is a heart, just so we can see that it's done that. And I put my breakpoint on, didn't I? It did. Then when we execute, what I hope is that we will see a lovely model binding. We have 7. If I extend this, we've got heart. So we've got it from the payload, from the body. We've mapped it to our object, just like you would in your controller. So that was the only quick thing I wanted to show you with that, and how to just lay out your minimal APIs in a nice way. You can see they totally work with controllers as well. So if you do a mixture because that's what you need, then that's great. So yeah, that's how I like to do it. I'm very open to ideas and suggestions. One thing about minimal APIs, I had a link to it there, is that if you were doing CRUD, create, read, update, delete stuff, and you had in all your entities, you could use something like Jeff Fritz's instant APIs. And what that does is it goes and looks at your DB context, I believe, and it goes to see what you have set. And then based on what you have set in your DB, it will go and create all of the CRUD methods, API methods for you, so you can do that. So that's pretty cool if you need something explorable. I haven't used that yet. It's still under active development, so I don't know how testable that instant APIs is yet. I also have a strong aversion to having entities surfaced, so that's a judgment call. I'm like, entities to DTOs, please. I don't like entities to come to the surface, apart from in a demo when I call order, because this is totally not the DTO. This should be DTO. This thing. Bring that in. Did I have that? Somewhere. We'll just ignore that now. But I don't normally like to have entities surface like that. So you need to make a judgment call with that. Just seeing his serializer here, you can add custom serializers to your DI. And so how you then would manage how something, your JSON is deserialized to your models. So you can do the capitalization and everything. You can do that as an object. I don't have time to go into that, but you can totally do that. So I hope this has given you some inspiration and confidence to go ahead and work with the minimal hosting, the top level statements. This is the minimal hosting pattern as well, because it's minimal. Everything's built off it. It's both top level statements and minimal hosting. I really like it. As I say, I hated it when I first started, but I've grown to love it, and it's very flexible. And if you develop it correctly, using some common sense and forethought on how you architect your system and structure your code, I think it's really powerful and very quick and easy for people to get a hold of and understand what's going on in your code. So yeah, that's it. Yeah, let's see. Have we got any questions that I haven't addressed?
Okay, we're back. So yeah, you know, it's funny. I've been accused of nodding too much when listening to speakers, so I'm kind of glad I'm not on the video while you're talking, because I was nodding the whole time.
I love a nodder. I focus on the nodder. I'm like, yes, there's my person in the audience.
Yeah, especially when you said don't surface your entities. Yeah, I was nodding a lot, because to your point, maybe your DTOs slightly, mutate and change because that's what your user wants and it doesn't match your database. Yeah. So really good point.
In the examples here, this doesn't look anything like my ingredients object. It's completely different. And especially I think because I started with MVC, and you always wanted your view model to be exactly what the view was. So you were never passing your entity to the view, because you would have your entity thing as part of the view. And you might have a select list, for your drop downs in there, you'd have everything in there. So I always was very much like entities are to do with data and that way in the back end. And then you have something that serves the front end, and they're very separate.
Yeah, excellent point. I think you also mentioned a lot of like the multi-paradigm hosting model that ASP.NET Core has kind of evolved into. Yeah. And I really love that about ASP.NET Core. The fact that you can jump from Razor pages to controllers to minimal APIs to Blazor and now Blazor components. Which one of them are your favorite? Like if you had to build an app tomorrow, like which ones would you pick out of that basket?
I mean, I've played a lot with Blazor, and I've given talks on Blazor, and I do enjoy it. But I don't like being in the front end anymore. I mean, when I was an engineer, I was full stack, but I'm so I like being in the back where it's all objective and there's no subjectivity on the margins and the borders, and I'm so done with that. So I love being in the back. I love doing stuff with APIs. So I think I'd like to explore more with minimal APIs and see how clever I can get with those. So that's kind of where my thoughts are going with doing that. And as you say, I love being able to mix and match and bring everything that I need into the application. I think one of my notes here is we have everything that we need and nothing that we don't, because you can just bring in what you need, and there's no limitation.
Yeah, excellent point. Rachel, what did you think when you were watching Layla give that expert level talk?
Yes, well, I've had the fortunate opportunity to actually see this last week also, so because we were at a conference together. But yeah, I like the promotion of the separation of concerns and components, which is once you go to this minimal model, it's not separate anymore. It's kind of at this point up to you to do some of this, and that's what's happening in this nice way. And the same thing with the DTOs, right? Not just surfacing that model. It has to go through this separation point, and you have that nicely loosely coupled layer for it. So those sort of things.
Yeah, I mean, a question for both of you, because Kevin Griffin asked this question early on in the talk. Is the minimum API approach fulfilling the prophecy of bringing more people into the .NET ecosystem? I know that's kind of like a philosophical question. There's no real hard data for us to talk about, but what are your thoughts? Does it make it easier for folks to get into .NET?
Actually, I think there is hard data. It's just that we don't have it.
Yeah. I think there are still, when you look at this, what we get with the basic out of the box template, there's still a lot of complexity for new folks there. Some people don't have dependency injection in their language. So coming over here and being presented straight away with builder.services, and they're like, wait, what are these things? So I do think there is a little bit of a sharp hill to get started. And I think that's inevitable when you look at like JavaScript or Python. There's none of that. You can just get straight in. Whereas you're presented with these, I think, good coding practices straight off the bat. But if you're new to it, coming from another language, I think there's still that little bit of a learning curve that you have to go. You can't just go, yep, this makes total sense. There's parity between this and Express.js or whatever.
Yeah. And it's interesting too, because on Twitter, you kind of see the different languages and paradigms and kind of their strengths and their weaknesses. And you kind of mentioned it, like with Express, you have this like dynamic language where you can do things and like enrich objects as they go through the pipeline. But C# statically typed, there is a lot more, I guess JavaScript people would say like ceremony to getting into C#, right?
For sure.
And that could be a little difficult. So let me look through, you kind of mentioned it, and I was thinking about it when you were going through this talk. You've kind of figured out a way to manage complexity in a minimal hosting style app. But have you seen a different approach to managing complexity that you find like interesting?
No, I haven't seen many people addressing the complexity. I did have a chat with Jeff Fritz about it, and he, with his instant APIs, he had some stuff, and we sort of spoke about different ways to manage it. And it just doesn't seem to be covered when I've looked at it. I'd love people to point me to some stuff where it's managed differently, because this sort of managing of it is the way that it works in my brain, and that may not work for everybody's brain. So if people have different ways of managing this complexity and really dealing with it, I mean, maybe people are just extending Builder and taking services out into something else. I don't know. Maybe they're doing that sort of thing and they're taking it up an even higher level. I don't know. What I do try to do is not mix my own dependencies with framework dependencies. So I try to leave things like these ones, which I consider framework ones, there, or I have toyed with taking those out into like framework dependencies, but I don't like to mix them in with my own ones, because I think that that leads to jumbledness and doesn't improve the quality of the code.
Oh, okay. Yeah. I mean, those are really good points, and like good advice too. I think I never really thought about the difference between my services and the framework stuff, but that's a really, really good point. So
yeah, you could, if you wanted to, take them all out and just dump all of the framework services in there and third party. But I like to have my own stuff, and then maybe third party, and then, framework. You can organize it however you see fit. That's kind of the beauty of it. I have just seen a question. So let me just do this. And I need to manage my screen so I can still see you.
Your wallpaper is going to eat us.
It's from Bing, and today it is orca sculpture.
It's terrifying. That's what that is. I have nightmares.
It looks like it's also hungry for waffles.
Oh yes, I'm really almost hangry now. So the question was, hello, come on. Oh my God, we've lost everything. Let's go back and open it. Where is this code publicly available? And it's here. on Layla-P.
Yep. We'll be sure to get that link from you and put it in the show notes when we publish these videos on YouTube. So folks can kind of get that from there.
Yeah, you can go and check it out. Yeah, I do love this background. It's pretty. If you were stumbling through the forest, like I often do, I'm a real nemophilist and tree bather. I think I might like fall on my butt and like squeal like a little piglet if I saw this.
Yeah, I would think I would be in a horror movie if I saw that, and not good things are coming up next for me. So I guess one last question, an easy question. What rider theme are you using right now? Because that's an interesting color.
This one is Ocean Dark or something. I got yelled at last week presenting on like a big LED screen in a light mode. Okay. It's like, why you're burning my eyes. It came up in my questions at the end. So this is Deep Ocean theme. And I always switch to Abrima. That's the font I like. And I use Dank Mono as my mono spaced font. So yeah, and I both talks people ask me how I got my Nyan cat progress bar as well. So there was some good plugging of stuff over there. My light theme, which burns your eyes, is Melon Light. There you go, lovely.
It's funny. It's like a holy war. You can't really please anybody. You know, the dark mode people are going to want dark mode. The light mode people are going to want light mode. I think we just flash themes at a high pace, and then everyone can have theme.
Yeah, just I'm quite happy with both. It depends on my mood and my ambient lighting. I'm really not bothered as long as I can read the font. And I zoom in onto everything, and as long as I think it's more the fonts that I like rather than the themes. Yeah. As long as it's not hot dog on code.
Oh yeah, that ketchup theme is
that's weird.
Oh geez,
it's wrong, so very wrong.
I don't know, the older I get, the more of a light theme I need, like the worse my eyes get. When I was younger, I could do more of a darker theme. So clearly there's some kind of weird eye issue for me, I think for some others.
Rachel, are we entering boomer territory? Are we in trouble now? I'm saying I need it too, is what I'm saying. We're gonna join a boomer club, Rachel.
We're not that old yet.
Oh, I hope not. Although I've seen some folks tell me I'm old, so maybe I am old. It's
old
fine.
in the brain, Khalid. There's a bit difference between physically and mentally.
I mean, you did yell at them kids to get off your lawn.
I did actually the other day because they were freaking my dogs out, and I was like, "These kids better get off my lawn." And then I was like, "Oh, geez, I'm a Clint Eastwood meme come to life." But
my lawn, you dark theme using kids.
So yeah, I mean, I guess one last question for you, Layla, and then we'll kind of let you go and bring on our next speaker. But have you looked at any of the .NET 7 improvements towards minimal APIs, and which ones, if you have, which ones are you kind of excited about?
No. I have I am sick and tired of living on the bleeding edge. I'm sorry. I have absolutely refused to look at anything for a .NET 7 RP.
I don't blame you. I'm the same way. Like I used to chase that like the minute the bits would come out, and it's just too tiring when you actually have other stuff to do. It's just too much changes too quickly.
I did it with Blazor on the bleeding edge, and it was so very painful. And I've seen people go through it with Maui, and I'm like, nope, not me. And I am waiting for .NET 7 to come out and be released, but I'm not updating anything to .NET 7 because, it's not an LTS. So, I am waiting for .NET 8 next, and .NET 7 can push off.
Oh, that's a spicy take. That's a hot take.
Spicy. I like this.
Oh, jeez. Man, we're gonna. All right. Layla speaks for herself.
We're gonna misquote you on this every time.
I know. I'm so totally gonna be in .NET 7, but at the moment I'm like, nope. I'm waiting till .NET 8. I won't, but you know.
I feel your pain though, because I wrote a blog post about a .NET 7 preview feature, and then someone DM'd me and said, hey, this thing doesn't exist. And I was like, what do you mean it doesn't exist? So I went and pulled out my code, and yeah, all the APIs and interfaces were renamed. So
like Bang Bang and all of these things that oh no, community doesn't like it. Let's toss it out. See, this is it. I'm waiting for the official V1. That's it. These fingers are burnt to crisp, and I'm not getting in there.
Yep. So on that note, it was a pleasure having you here. This talk was great. Rachel enjoyed it so much she watched it twice. So that's praise, right?
She's a glutton for punishment, that one.
So thank you. And all your links we'll put in the notes once we publish this video.
Fantastic.
And we'd love to have you again. It was a great pleasure. So
I would love to come back and cause mayhem. So it's fine.
That's our brand, chaos.
Oh yes.
Yeah. So anyways,
thank you so much for having me.
Yeah, thanks so much. We'll see you later.
Bye.
Bye. Yeah. That was really fun, Rachel. I enjoyed it. There was a lot of really good expert points in there. So I learned a lot about poly, which I really enjoyed. And it's funny because Layla said she's done. She's done with the front end. Never looking at it again. I think that's what she said, right?
Right.
I've
said this before too.
Oh man. Well, I feel bad for our next guest because he's doing front end, but he's gonna kill it. I know he will. It's gonna be awesome. Look, he's dancing already. So, give it up for our next guest. Emanuele. He's really going to talk about Blazor components specifically, and I'm going to add him now. Say hello. Hey, Emanuele, how you doing?
Hi, everyone. Yes, I was dancing because for two reasons. One, it's not easy to talk after Layla because Layla is one of the best speakers that I know, and the second one because I love Blazor and in .NET 7, because I love to live on the edge, and .NET 7, there are a lot of new features about Blazor. But of course, we don't talk about it today because it's too early, also for me, because let's say all the things can change in maybe 2 months or who knows. So it's not safe to talk about, let's say, .NET 7 today, I think. I think we have to wait more or less 15 days, more or less. Or,
So it's getting released around November. I will say there's release candidate on it, so I expect it to not change. I think it's ready to go if people want to bleed on the bleeding edge. Like that's an option for them.
Especially about minimal API, because me and two friends of mine, we wrote a book about minimal API for Pact, based on .NET 6, and they asked to us, hey, do you want to update the book to .NET 7? No, because we have to rewrite everything from scratch for .NET 7. So first release this version, and then let's see for .NET 8, but not for .NET 7. Let's see, because we have 1 year to rewrite everything for .NET 8. So let's see.
Yeah, I mean, writing books is hard, so I have all the respect for you. But if you're ready, I want to ask you about the stuff in the background, but I'm going to let you do your talk, and then we'll ask it at the end, because there's one thing back there. If I could get into your house and take, I would. But
Alien, I mean,
yeah, that's the one. But let's get to your talk, and I'm excited about this. I'm going to share your screen, and then Rachel and I will drop off. So good luck.
Thank you very much. So, hi to everyone. Today we are talking about Blazor and components in Blazor. I really like, let's say, to deliver this talk because in the past, and maybe also right now, I don't know, I am also a front-end developer. But I used to work with React or, let's say, framework like React, but mostly React because I'm developing a lot of Microsoft 365 application, and Microsoft decided to use React as the main let's say, technology for front end. But when Blazor was released, maybe now I think 3 years ago, more or less, or 4 years ago, I don't remember exactly. No, 4 years ago, if I remember exactly. I was really happy because I found a lot of, let's say, points in common with React and other frontend, especially the components. But what is the Blazor component? The Blazor component is a kind of, let's say, self-contained portion of UI that you can develop and reuse everywhere in the project. And you also can have a kind of its own logic, because you can write code specifically for that component. And also can be nested, because you can have a component with inside another component or the same component. Okay, so this is very, let's say, important to say. And you can also say reuse the component. So if you have a 4-page in your application, you can use your component 4 times, for instance. And it can also be shared. I mean, for shared, I mean, you can share the component through a lot of projects and not only one project. So this is another good, let's say, lesson that I learned during my last maybe 2 years and a half of developing with Blazor, because I created a lot of components that I share through a lot of projects. So my productivity, of course, is better than before for this reason. This is one of the reasons why Blazor for productivity is perfect. There are a lot of, let's say, not a lot of, but let's say 2 or 3 advice when you start to develop the new component. One is the naming, and the other one is the routing. The naming is really easy, because it's a kind of, say, best practice, but the component name must start with an uppercase letter. I mean, if you are, let's say, used to, let's say, to work with React and stuff like that, all the components start, or at least it's a kind of another best practice, but not everyone follows this kind of best practice. All the components, all the stuff start with a lower, say, character. But with Blazor, it's better if you start, let's say, the naming of the component with an uppercase. And the path indicate the folder and the location and the file. I mean, if you develop a new component called project details, or at least pages/project details, the folder location is pages. Okay, this is also important to find really quick your components in the project. Spaces, of course, are not allowed in the name of the components, because you can, let's say, you can have also a file called with spaces, but for routing point of view, it's not possible to have spaces. And you can, let's say, replace the space with the minus. Okay. But I am a developer. I don't want to talk anymore on this kind of stuff, and I would like to share my Visual Studio or JetBrains environment. JetBrains, right there. Let's see. I'm open. Sorry for waiting, but I forgot to open Rider before the session. I don't know why. So we start with a new solution from scratch. So I click on New Solution, and in the new screen, I can select Blazor Server or Blazor WASM is the same for this kind of example. We choose Blazor Server because it's one of the just selected. Okay, and then when the project is open, let's say, come on, PC, okay. And then from the solution, we can start to create, what it is, we can start to see an existing component, because everything in Blazor is a component. I mean, in this case, this page, this file, not this page, is a page, and is not. Sorry, my mouse is dead in this moment. So leave on the edge also. Sorry for that. I have to change my mouse. I hope everything is worse. Sorry for this kind of. Okay, so I have a kind of recording studio here. So I have everything in double version: 2 mouse, 2 keyboards, 2 everything. So sorry. So everything in Blazor is a component as well. So in this case, let's say this page is also a component. So it means I can use this this counter as a page. Now I will start the project in a new browser. Let's see. Sorry, come on. Browser. Alexa, open the browser. Okay. So I can use this component as a page, like this page. Okay, counter, and the routing is counter, as you can see here at the top of the page. But I can take this, let's say, this page, and I can webinar. You're right, Khalid. And I can call my counter also here, and I can have also another counter in the home page. Okay, this is, let's say, all the magic behind the Blazor component. Okay, and let's see when the browser starts. Okay, and I have a counter in my main page and also in another page with a dedicated counter. Okay, and of course I can duplicate my counter, let's say 2 or 3 times, and I can also use another, let's say, syntax for this this component. Now I should have 4 counter in the home page. Okay, and every counter has his own logic. Okay, so this is the very basic of let's say how Blazor works with components, but it's more or less everything that you have to know to start developing a component. Okay, but I can also add some parameter to this component. In this case, I want to add a parameter here, and I can use the syntax and the attribute parameter, and then I can use the public int step. Okay. In this case, Copilot helped me to write good code. Okay. Oh, I saw a questions in the chat, but I don't want to answer on that question. And then, sorry. And I forgot to add this parameter to the counter in the home page. Then I can go back here. I can remove all this kind of stuff here. And then if I press space, Rider suggests me that I have a parameter here, okay? And the name is step. This is important because it's very easy to have, let's say, this kind of intelligence, okay? And then I can add here a step by 2 and another one by 4, for instance. And then I can go to the counter, and instead of ++ here, I can use plus equal step. Okay, thank you, Copilot, for helping me, because I'm not a good developer, but with Copilot, everyone can be a good developer. So I'll start my application again. And here I have the first counter with step 2, and it works good. Thank you so much, Copilot. And the second one by 4, and it works. Okay, this is the very, very introduction to Blazor components. But based on that, we can create more complicated, and not complicated, but more, components with a lot of logic behind, or a lot of logic, or at least his own logic behind. So we can leave, let's say, the project as is in this case, and we can start to develop a new component. In this case, I would like to create a new component with a kind of cards. As cards, the address book that you have in your intranet or stuff like that, something like that. And then for let's say, and you can put your new components whatever you want in the project. Let's say I use everything, or more or less, not everything. I use every time this kind of folder structure, and I use a folder called resources here, component here in the root, and then I put every component inside of this this directory. But you can also have these components in the page folder as a subfolder of pages. It's up to you. Okay. In this case, I use this, let's say, just for this example, and I create a new Blazor component. Blazor component is the same component. Name employee card. In this case, component. Okay, and then as you can see, I have my component. I don't have the root on. You have with Copilot you can create a component in 3 minutes, as you can see, because it provides you a kind of suggestions. But we want to start from scratch, and then I would like to create a new component without a title. I don't like to have H3 as title, but we can use Bootstrap for our let's say proposal of this this demo, and I copied all this this code from my snippet code to be, let's say, more faster, and then from here I can also and it's just, let's say, a card component from let's say card component from Bootstrap, let's say, nothing special. Okay, and then I have to add all parameters, let's say, that I have in my component. This is a kind of suggestions. If you want to create component to share in a lot of projects, let's say it's better if you create as much as possible, say, parameters in the component, because it's more flexible. Okay. At the beginning, it's a little bit annoying, but after a while, it's really, really useful. Okay, public string. We have a job title, for instance. If I remember, a job title, get and set. It's just, let's say, properties like in a normal. And I have department. Okay, and parameter. Image, I have the image. Okay, I really like to have these suggestions, because I don't waste time to write every name. I have the name. Good. I don't know if in this case is JetBrains writer or a Copilot, but it doesn't matter. I'd like to have this kind of such an email. I think that's all. Okay, and now we have our component, but we don't have any let's say, any data behind it. Okay, so we can create a new folder here, new add folder directory, call it services, and we can create a services. I think Layla showed to you something similar, but we can create a new item, a new class in this case, call it employee service. Okay, then we have our class here, and then from here we can use a new component from NuGet called Bogus. I don't know if you know Bogus, but Bogus is a NuGet library for creating mock data and sample data for your project. Okay, and then, but before, sorry, I forgot to create a model behind our component, and we can create models folder, the class, call it employee model, or I don't know, and then we can create. Sorry, I don't want to create everything from scratch again, and I pass my code from my snippet as well, and then we are more or less ready to create our services. And in our services, we can do more or less the same because we can create our public async thing task. So employee model, it's an array or a list, I don't know, whatever. I'm not good with this kind of C# syntax. And then we can create this kind of code. I don't know. I don't want to use a suggestion. And then we can use Bogus. For using Bogus, you have to add the dependencies from NuGet. Call it Bogus. Bogus NuGet. Plus install Bogus. Yes, install on our application. And then we have Bogus, or at least we hope to have Bogus in our project. And then I start to, of course, again, to create a new code from my snippet. And then I return my employees. In this case, with Bogus, we create, give me a moment, I put a little bit down. In this case, we create, with Bogus, we create a lot of, sorry, let's see if I can zoom a little bit better. Okay, we create 99 employee model, and we use this fake data, but this data seems like real data. Okay, this is why I love Bogus during my development and my mocking services in my, say, experience. And then we have to start to use our services here in the program file, not the weather services, but the weather forecast services, but builder services, and then we can add a singleton. In this case, I don't like to use singleton, but in this case it's okay, as employee services. And then we are almost ready to see the results. Okay, so we have our component. I think we have more or less everything to start developing our employee card. And then from the index, for instance, we can go to the index page. Then we can remove everything, or at least, yeah, everything. And then we can start to create a new, let's say, we can inject, first of all, our services, employee services. Okay, so we have our services here injected. Can solve employees, what is? Well, employee service, employees, no, sorry, employee, oh, come on. Okay, copy and paste next time, it should be better. Employee. Okay, good. Give me a moment, because I don't know how to write employee anymore. Some troubles here. Okay, import everything. Thank you very much, Ryder, for suggesting me. And then we can start to write the code to display our, let's say, our employee's card. Okay, and then in this case, of course, if employee is null, show the loading, and then for each component, you have to let's say, display our employee card, and I pass all the parameters in with this form. And then in my code, here below, in the code behind, I also need this kind of import employee model. And then from here, employee service is not called wait, employee service. Get employee async, get employee, right? Get employees, I don't remember. Okay, get employees. And then in the on initialize async, I tell to the page, hey, load my employees in this kind of models in the page. Then let's see if it works or not. I'm not sure. I hope. Let's see. Boom, boom, boom. Come on, come on. Maybe it works. I don't know. Let's see. Why does it work? Do. I forgot something. Maybe. No, I don't know. Index. Wait, employees. Index. No, it's good. Let's start again. I have another project ready to. Maybe we have an error here in the console. No, good. For him, everything works, but it's not true. Yeah, I don't know why it doesn't work, but I can open my old project. I make some error because it's not easy to explain when you employee service here, employee service here as well, get employees. I think it should be correct, but no, it doesn't matter because I can open my other project. Oh, come on. Yeah, live is always like this, you know. Employee directory. Okay, we can use for this moment Visual Studio for a while, and let's see if it works with this kind of project. I don't know why it didn't start. Try the debugger. Oh, yes, you're right. But the blank page is really, really strange. Okay, now this project works. I don't know why, but maybe I forgot something. So we have our card in our project, and we are really, really happy about it because we have let's say, an employee card in maybe 2 minutes, and we can use this component in other project. Okay, but let's add a little bit another, let's say, I want to call it complication in our project, because now this component live in our project. Okay, but we want to share this project to the rest of the world. I mean, okay, and then we can do that because we can use a special library in the project, and then in the solution we can add another project called add new project, a Razor class library, and from here we can add a lot of components in this class library. For instance, we can take our component, okay, from here, for instance, from component employee card, we can cut the component and we can put the component here. And we have also our employee card in another project. So this component live in another project, but you can use this component in the whole project. How? You can add a reference to another project, to the other project, call it, in this case, Blazor class library 1. Of course, you can change the name of the other one. And then if you go in the index, of course, you don't have any error because we have our components in our class library. Okay, this is very useful, and this is the first step to share your component in several projects. Okay, the most important thing, or at least say one of the most important thing, you don't have to share also the model or stuff like that, because in this parameter we didn't specify, say, the model, but just say basic parameter like string, date and time, or stuff like that. This is very important because if you, let's say, port also the, say, the models into the, let's say, the component, you have always a problem for, let's say, this kind of, let's say, dependencies for models. Okay, so it's better if you are agnostic about the model and just use some string, date and time, or int value, guide value, stuff like that. Okay, and then we can also add another stuff here in our, let's say, project, because we can also add, for instance, a new CSS. You have two ways to add the CSS to your component. One is to add a new file, add new file, call it like our employee card.razor.css. And then here inside our, let's say, our component, you see our CSS. And then from here you can add, I don't remember the name of the card body, for instance. You can add your own CSS, like call background color green, I don't know, something like that. And then this CSS is just related to your component. So in this case, we have created a component with his own CSS. Okay, this is very important also for porting to a project to another. And when you deploy, sorry, when you create a package starting from a Razor class library and you want to import this class library to several projects, everything that is in our this folder root, and also everything related to the component is inside the package. Okay, this is another very important stuff to know. Okay, and yeah, this is more or less what we have. And here we have also to import this new using how to call it, Razor class library. Okay, and you are done. Now you're ready to use our component in our project. Let's see if I can switch to this demo to show you. And all the code that you saw today, it's on my GitHub, just on my GitHub. And I created the steps to create also this kind of journey to Blazor component. But at the end of the session, I will share with you my GitHub account. And then from here, as you can see, I changed the background with an image. And the image is not, of course, in the, let's say, in the main project, but is in the component project. Here in this folder, we have the background. And here in my CSS, I define the background URL is background PNG. Okay, this is another stuff to know. It's very important to know, and it's very easy to understand. Okay, now we have a project, a separate project for our components. And I forgot to tell you, but you can also create more than one components here in our library. You can also import the counter here in another project and use the counter in another project. Or I have a project in my, let's say, at work with at least, I think, more or less 25 or 26 components. One is a grid with a lot of sub-components. Another one is very similar to employee card, and I have several components in my project. But in this case, you have to, let's say, copy and paste our project, the component project to, let's say, folder to folder in several folders in the project, and it's not really, let's say, good. And you have to two way to, let's say, solve this problem. One is let's say, publish this project on NuGet, and the other one is very similar. You can use GitHub. You can use GitHub registry. Let's see if I can share with you just page Google GitHub registry NuGet. Okay, and the GitHub registry is a NuGet server up and running, depending on your project. Okay, and then from here you can add your NuGet sources in your project. It's not, let's say, too difficult to add this kind of let's say NuGet server, okay, because you have to do 2 or 3 steps, okay, to add your class library to your NuGet. One of these steps is to go to your employee XM class library in the properties, and here from the package. No, sorry, before you have to publish to where is the, I don't like this zoom because I don't see anything here. Advanced package. Okay, you have to check this checkbox because by default is unchecked, and it means you can create a package when you build this project. Okay, this is the first step to do. And the other one is under the package here, you can define the authors if you want to define an authors, also the project name. But the most important thing is define, say, the project URL. In this case, it's a .NET Days and something like that. Where is? Oh, come on. Okay. And remember to also add this .git at the end. This is very important to remember because it's one of the errors that I do every day. Okay, remember to add, say, the Git name. Okay, and then after this step, you have to go to let's say to GitHub and create a token with a special permission, a personal access token, let's say token classic, generate a new token classic. Okay, in this case it's not important. Okay, you can create a new token. Oh, come on. Sorry, I have to log it in on my authenticator. Okay, and then you have to add this read package, write and read package permission, and then you can save your token on Notepad or NordPass, whatever you want. And then you can launch a command from the terminal. I open my terminal here. With your access token, you have to go to your project folder. And then from here, this token is not valid. So it's just an example. So I can remove this token, but it's not valid. And you can add your source with the username, the password, and you have to define your NuGet server, with your username. Okay, this is more or less how it works. Of course, we have to build the application before, and then after this command, you can push your NuGet package. Give me a moment. Let's say to the NuGet folder, to the NuGet server. Okay, with this other command, and then in your project from your GitHub, when you push everything to GitHub, you see your project here. .NET. Is okay. When you push everything, you have this package here deployed on your NuGet. Okay, uploaded on your NuGet, and it's more or less, let's say, what you need to do to have your private NuGet package in your project. Okay, this is more or less how I develop, let's say, components with Blazor. And here you can find all the reference and all the links that I use today. I suggest to you to use the second one. It's a wizard about create components. And I love also to share one of my achievements in the last month. Me, Andrea, and Marco wrote a book about Minimal API. Layla talked about a lot about Minimal API, and then from my side it's everything, and you can find also here my link. So I'm waiting for you for a Q&A session with Khalid, I think. I don't know, or I'm alone. No,
Yep, I'm back. So yeah, congratulations. Layla's saying congratulations on the book. Yeah, it's pretty awesome to write a book. So thank you for that. That was a really cool talk on Blazor components. You know, it's interesting to me. The first question I always have, because who added Rachel? Rachel's camera.
Yeah, I forgot to add my cam here.
Oh, device is not connected. Oh man, Rachel's having. Oh, there she is.
I forgot how to internet for a minute. Okay. We're back.
Sorry, I saw your camera was off, so I didn't want to add you if you were like off somewhere doing something. So
I stupidly sat there going, "Why is nobody adding me?"
I'm sorry. But Emanuele, like one of the first questions I always have when I'm thinking about components in Blazor, and you probably have professional experience doing this, how big or how small should you make your components for reusability?
Yeah, it's not, let's say, an easy question to answer, honestly, because there is no, let's say, a written rules about it. For instance, this employee card, I think it's more or less the smallest component that I wrote in my work life, honestly. But you can also, for instance, let's say, create a component just for a text box, for a special validation, okay, or just for a text box. It's really, let's say, I think it's a good example. You can create a text box with a specific validation. I don't know, with a special code from a customer, or you can create also an entire grid. I mean, a really big grid as a component with sub-component maybe, but you can also create a big component for a grid, for instance. So there is not written rule, but yeah.
So would you say then maybe when you can, stick to your single responsibility principle, but sometimes things like a grid may have one or two little extra features.
Yeah, of course, it depends how many deep do you want to go with your components, of course. Yeah, because it's also more easy if you create small components, of course, it's more easy to port all the components in several projects, of course. But for instance, I have a special, special project template for my product at work, and I use more or less the same grid in all my project. And this is why I created this big component with grid. But for instance, I have another component for let's say the heading of the page, for instance, H1, H2, H3 with the special classes, and I created also a component for that. But yeah, it depends of what kind of project do you have during the day, or for the customers.
Mm-hmm. Yeah, I mean, I guess a good follow-up question too around components is, do you feel more comfortable when using Blazor using your own kind of custom-built components, or do you prefer components that other people build? Because you mentioned NuGet. There's community component libraries. There's also paid ones from like Syncfusion and Telerik. Like what are
Blazor? Blazor is from community. It's a mix from community and from a company. There are a lot of free components, of course, on NuGet and also on GitHub, of course. And honestly, at work, I use the let's say the component from Telerik. They are good, or at least for my project, they are really good and not so much expensive. But honestly, I prefer to have a company behind my components and not for my, let's say, work. Because if I have an issue or if I have a bug, I can contact directly Telerik instead of waiting someone in the evening that solve my issues on GitHub. But it's more about my fear and not it's not a fixed rule as well. But yes, I use Telerik, but yeah, you mentioned also Syncfusion as a lot of good components. But I don't just Syncfusion and Telerik, but I choose Telerik because as a Microsoft MVP, I have a free license at the beginning. They start to release, say, component after I think 3 weeks of Blazor Blazor life, and I start to use Telerik. But yeah,
it's very cool. I really recommend people try different components, see kind of what style they like. You know, a interesting follow-up question for components. You know, when you're building them, it's very attribute based. Is there something you wish was in Blazor components that you feel is still kind of missing? Like, what are some things that you'd like to see?
Yeah, good question. I don't know how to answer.
Yeah, I guess to me, I'm thinking about, you know, when I think about Razor and I think about ASP.NET Core, I think about like tag helpers, right? The ability to write these things that can enrich HTML components. And I'm curious if that kind of tag helpers approach will also come to Blazor components, right? Like that would be kind of neat to see that happen.
Yeah, of course. But of course, Blazor is a young framework to use. And if you see Blazor maybe 2 years ago, if you try to imagine Blazor 2 years ago, it's totally different. At the beginning, for instance, 3 years ago, more or less, they didn't have also the authentication part on Blazor. And now you can use authentication from I don't know, Azure AD or Keycloak or user identity. And especially in .NET 7, there are a lot of improvement also in Blazor because Microsoft, let's say, they push a lot of resources to Blazor and minimal APIs, especially in .NET 7, also .NET 6, but especially .NET 7. And I think in .NET 8, they will add more, let's say, more features to Blazor.
Mhm.
I think so. Let's see what's happening in the future. But honestly, I started to use Blazor from the beginning, and when it was in beta, and I think a customer of mine have also a production, an application in production environment with Blazor beta, if I remember, with the old framework. But yeah, I don't know. So I really like to use Blazor, honestly, during my day. What could advantages? Ooh.
Yeah. Maybe, you said at the beginning, you mentioned Alexa. I think we should, every speaker should mention Alexa and ask people to buy JetBrains licenses. That's how we make our money now. We'll just mention Alexa, buy JetBrains licenses.
I like that. So there are a few more questions. Now, this one was coming. What about JavaScript really? How much can you really avoid JavaScript when you're in a really complex component? And then also, Ivan's asking, is there a potential in the near future to replace and get rid of it as far as in the Blazor world and, give the old stick you to the JavaScript frameworks for the front end?
Yeah, of course. This is a common question. I mean, let's say Blazor is a replacement of JavaScript. The answer is no. The short answer is no, because if you want to work with Canvas or with the maps, stuff that you have to write some interop with JavaScript and some code in JavaScript as well. So the short answer is no. You have to know also say JavaScript. But what I like to to use in Blazor is, for instance, this kind of modeling that I used before in my my demo. So I created the employee model, and I can use the employee model in my backend if I have a backend with API, and the same model in the front end. Okay, this is what I don't like to have in my project when I use React, also with TypeScript or I don't know, because you have a model in the backend, but you have to write a new model in the front end with TypeScript, with vanilla JavaScript. I don't know, but you have to duplicate this kind of model, and I don't like this approach. Especially also the business logic is the same. You can create an external library when you have all the logic, and you can share the logic from the front end and from the back end. This is the great advantages of Blazor, and not because you don't have to know JavaScript, because JavaScript is in our life, and I think for the next 20 years will be in our life as well. So
no.
Yes.
I'm just joking. I love JavaScript. It's fun stuff. I guess a follow-up question to that, though, since we're talking about things that you're going to have to get used to, and you said you're with Blazor from the beginning. If there's something you could go back and tell young, naive Emanuele, like, hey, you need to know this, and this is going to save you a lot of pain and suffering. Like, what is that great tip you can give yourself?
Yeah. Let's say the struggling part of Blazor is always the debugging part. Because of two reasons. Why the auto load sometimes works and sometimes not. Mm-hmm. Not because of it's a problem about .NET, not the ID. And so this is the first pain, and maybe I would like to wait until maybe 1 year ago or 6 months ago instead of starting with Blazor at the beginning, because I waste a lot of time on the debugging part. Especially in the past, maybe someone remember this kind of approach. You have to launch Chrome with a special command to have the debugger in the browser and not in Visual Studio or JetBrains or Visual Studio Code. And it's not easy every time to switch from debugger from Java for Chrome and Visual Studio. And, and the other stuff is creating, honestly, components from the beginning of the project. Because if you start with components at the beginning of the project, it's more easy to scale the project and also to reuse the components, and also, of course, boost your productivity during the project. At the beginning, I create only components in my just in my project and not in a shared project. And every time I have to say copy and paste or rewrite all the components from scratch, and I waste a lot of time.
Yeah, that's really good tip. Rachel, any more questions?
Oh, let's see. Well, we got a bunch of course, the like, yay, no more JavaScript, but also, some folks are like, boo, now I like JavaScript. So what about in relation to some of the JavaScript front-end frameworks? How would you say it compares to, say, React, Vue, any of the popular ones, and what some of those pros and cons might be?
I think Blazor is let's say, the most JavaScript framework similar to Blazor is React. I think it's not Angular. I think, especially if you use the WASM version, WASM version is very similar to React and not Angular or stuff like that, because it's just let's say you can use Blazor as your front-end technology. Okay, and React is very similar, especially when you create components. It's very similar. The approach is very similar to React. Yes, also from Angular, but Angular is too complicated for in this moment, I think. Especially if you don't know JavaScript or TypeScript, I think React is more easy. And again, Blazor is more similar to React instead of Vue.js or Angular.
Yeah, we're gonna put you on the spot and make you answer this spicy question because somebody asked it or they kind of alluded to it. So you can answer with a no comment and pretend you didn't hear me ask the question. But let's see how brave you are.
Okay.
Their comment basically says, I don't trust that Blazor will be around 5 years from now. Do you trust that Blazor will be around 5 years from now? And do you have faith that, you've made the right decision by investing into Blazor?
And this session, is it recorded, Khalid?
we'll cut this part out if you're like, no comments.
And honestly, I'm really, really brave. And I think in 5 years, we will have Blazor. Okay.
Yeah.
Because, of course, Microsoft invested a lot of time in Blazor. Okay.
Mm-hmm.
And you can say, okay, but Microsoft invested a lot of time also in Silverlight. Okay. But or other stuff, I don't know. But honestly, Microsoft invested a lot of time on Blazor and minimal APIs in the last maybe 2 years.
Mm-hmm.
And especially at the beginning, for the first 2 years, Blazor was an experimental project from Microsoft. But after 2 years or 1 year and a half, I don't remember. So since 2 years, it's a real project for Microsoft. And they also deliver a lot of ebook or post. Also, Jeff Fritz deliver a lot of session about how to migrate web form to Blazor or stuff like that. And there are a lot of web form outside in the world project. And then Blazor is the, let's say, the easiest way to to migrate this kind of project. And I think Microsoft, let's say, want to invest more time and more resources on Blazor. This is why I think we'll survive for at least 5 years. But yet, if you can cut this last maybe 1 minute, Khalid.
Well, I agree with you because Blazor, everyone kind of compares it to Silverlight, and I think that's kind of an unfair comparison.
It really is.
Yeah, because Blazor made a lot of smart decisions, right? Adopting JavaScript interop, which is like a really good decision. So you always have like an escape hatch to a different ecosystem with Blazor, whereas like Silverlight kind of tried to boil the ocean. It said, look, you're gonna be in this garden. It's a beautiful garden, but you can't get out of it. Whereas Blazor made a lot of smart decisions.
Well, also because Microsoft did one thing in the past does not mean that this product will be exactly the same. Companies don't do exactly the same thing every time. Many of the people who were released Silverlight are not on this team anymore. They've moved on. So you have fresh people in there. Sure, some mistakes get repeated, but generally, no. And it is ASP.NET. That is their largest developer product, right? It's ASP.NET. So it is on that stack. So it's not going to go away that easily. Silverlight was not. It was on it. It wasn't its own thing, right? So you were kind of siloed off there. So.
Yeah, and I will say Layla kind of alluded to it, like the multiple hosting models. You don't have to go all in with Blazor. You can kind of pick and choose when you want to use it. And I personally, this is my opinion, I think WebAssembly definitely is the future. I just saw yesterday Docker has WebAssembly support now for containerizing .NET. So even if Blazor kind of starts to fade a little bit, WebAssembly and .NET are going to be going really strong in 5 years. But I don't really see Blazor going away anytime soon. So,
Blazor used to be Razor Pages, which used to be MVC, basically. Right? They're all. It's not new stuff. It's all built on this core that has been invested in what, almost 2 decades, and a lot of people and a lot of time and a lot of maturity there. So that is not good. So you might see something else past Blazor, but it's going to be something else on the same stack. It's not going to be a whole new rewrite. That would be financially irresponsible.
I totally agree, Rachel. And in addition, you can use also your skills for Razor that you have from the past, from MVC or Razor Pages. And honestly, I'm not a big fan about Razor Pages, but they exist, I think, since more or less 5 years, maybe. 5 years. And let's say no one talk about it, but they exist. And Microsoft, let's say, didn't, abandon this kind of project, but it exists. And I think at least Blazor will do the same. I mean,
I'm personally a big fan of Razor Pages because of, like, if you just need to build form driven pages, but
in 3 hours you have an application up and running with Razor Pages. Instead of your productivity is more, let's say, compared with the ASP.NET MVC, of course, productivity is higher. But yes, maybe because I come from ASP.NET MVC, I don't like Razor Pages, but it's my own opinion. It's not.
We do have some doubters in the chat, so let's come back here in 5 years, and then we'll try to figure out what actually did happen.
Of course.
No one can see the future. But one last question: where do you get a xenomorph head from? Because I'm really, really curious. Did you go into space and get it? Is what I'm asking.
Is that 25th anniversary?
Oh my!
Special edition, and there are a lot of DVDs here inside of the head with all first 4 movies.
Oh man! Okay, don't let me in your house ever. Is what I'm trying to say.
Totally don't.
It'll disappear. But on that note, I don't think there's any more questions. Thank you so much for this talk. It was a lot of fun. The chat was fun, and a lot of these opinions are really good to have, and these discussions are really good to have. So thank you so much.
Thank you for having me back. See you around.
Have a good one. Thank you again.
Thanks.
Bye-bye.
Bye. That was really fun, Rachel. And
yes,
Blazor is always one of those topics that's kind of like,
it's a hot take every time.
Yeah. But it's interesting if you think about it. Blazor, I guess, is coming up on 3 years really that it's been around. So where's the time go? It's almost like, who knows?
I know, it just whips by so fast.
I know.
So I think actually we're changing hosts again.
We are?
I think.
Oh my God. Okay. So, we are. Oh, I see Martin nodding. Who is the person? Martin's coming in.
I think it's Martin again. So, but before we go, I have to tell everybody that Alexa should like and subscribe to JetBrains TV. Sneak that one in there.
The growth
But
hack.
also, in case y'all don't know, we do have a .NET newsletter that we send out every month. I'm the one who sends it out, and people contribute links. And some of our presenters here are even guest contributors to the featured content. So go to our .NET blog at jetbrains.com/.net and take a look. We have a whole section with the latest news, what's going on at JetBrains, more webinars, and stuff you don't want to miss.
Yeah. Yeah, I love it. I read it myself all the time. So I really recommend people subscribe. And it's always cool to see what our community is doing. And you do a great job with it. So thank you for putting that together. And also thank you to our guest contributors that typically put those things together. So yeah, thank you. And let's add Martin, because I know he's getting a little itchy. So hey, Martin.
It's fine. I'm just gonna sit here in silent protest.
That's awesome. There we go. That's good. So Rachel, thank you so much. We'll talk to you later.
Bye, folks.
Bye.
See you, Rachel.
All right, Martin. We've had our next guest speaker kind of hanging out in the guest room quietly.
He's waiting. He's ready, and I think he's fed up with Blazor and just wants to go and build console applications.
Dude, console, it always comes back to the CLI on console. So it's like, don't disrespect the console. So I'm going to add João now. Hello.
Hello.
Maybe I should have warned him a little. I just kind of dropped it.
Ready and waiting.
How are you doing today?
All good.
Oh, awesome. So yeah, I see there's like a drum behind you. Is that going to be part of your talk or no?
No. It's just there.
Oh, that's sad.
I have other surprises for the talk.
Ooh, now we're curious.
All right. Yeah, I am very curious. So are you ready to start your talk?
Yeah, let's go.
All right, let's go. I'm going to share your screen, and Martin and I are going to drop off. If you need us, let us know, but the stage is yours.
Thank you. So thanks, everyone, for joining this session. So it's going back to basics. So we've seen ASP.NET, we've seen Blazor. So back to where it all started in console applications, and talk about how to build them with Spectre.Console. So very briefly, and to get this out of the way, about me in 15 seconds. My name is João Antunes. I'm from Portugal. I'm an engineer at Devoteam Portugal. I'm a Microsoft MVP in the developer technologies category, and you can find me on Twitter at this handle. But this is really not relevant for the presentation, so let's go to what's interesting. So why console apps? I have to say that building console apps and command line tools is not really my day-to-day, as I imagine that for most folks isn't. Some folks might do it more regularly, but it isn't my day-to-day. But I still do it quite often because it's very useful to just explore and test some features, like when new APIs come out in .NET and stuff like that. Many folks probably have like console app 77 or something like that, because we're always creating new console apps to try something out. Running benchmarks also with console apps and making use of benchmark.net. And also many times to just automate some tasks, because at least for me, I tend to fall back to console apps versus scripts like PowerShell. I just feel more comfortable using C# for these kinds of things. Of course, sometimes scripts and stuff like that. But if it's a bit more complex, I just prefer to fall back to where I feel at home, which is using C# and console apps. So having said that, and again, it's not my day-to-day, so it's not surprising, I guess, that one of my typical console applications will look like this. So just printing out a bunch of stuff so I know what's going on and have some notion of progress and stuff like that. And so when I do this, I tend to use some shortcuts, like I just hardcode settings when I'm doing these kinds of things, because normally parsing arguments from the command line is just annoying to do. So I just hardcode things, and it's mostly console apps that I use, like I have the IDE open, I do something, I run it and stuff like that. It's not something I give to someone else. So this hard code settings approach works. It's not great, but works. So as you saw in that previous screenshot, I display progress through infinite console write lines. So just if I'm migrating 9,000 items, then I will see 9,000 at least entries in the write line in the console to say that something happened. And because of this noise in the console, I also abuse white spaces or random characters to distinguish output sections. Like if there's an error and I want to be alerted that it happened, I just put, I don't know, a bunch of hashes around it, just because it's a quick and dirty way to do it. And yeah, why do I take these shortcuts in results? Because making a usable console or any other UI for that matter is not trivial. And again, we're just usually just trying to hack something quickly together. It's not like I'm going to complete that application and publish it on the interwebs. I'm just like, quick and dirty, let's go, it works, ship it. But fortunately, even for these use cases where I'm not trying to do something very pretty, there are some options to improve it. So we can make some things a bit better, even without using too much effort to achieve it. And that's where Spectre.Console comes in. So Spectre.Console is a .NET standard 2.0 library that makes it easier to create beautiful console apps. So what does this mean in practical terms? So it supports easy parsing of arguments into strongly typed settings and commands. It's easy to output text with different colors and styles, which for that situation I just showed you, where I want to alert for an error occurred, it's pretty useful. It has some options to easily prompt the user for input. It enables us to render complex widgets, display task progress in ways better than just printing a bunch of stuff to the console, and more. So let's take a look at the code, which will be the most fun part of the presentation, and most of the presentation will be focused on this. So I prepared a scenario. It's very basic, but it's inspired in something I had to do in the past, and that's why I found it more relevant. So imagine that we have a situation where we want to create a migration. Like we have some data sitting in some repository, and we want to migrate, maybe transform in the meantime, and move it to another repository. So inspired by that, this is the scenario we'll use. So I have a bit of code already here, where we have an enum for the environment, like development, staging, production, whatever, just the typical environments. I have something called migration information, which is just to present information. Like before starting the migration, we will ask the user, do you want to proceed? This is what will be migrated. In this case, it will only be the number of things to migrate, just for example's sake. I have a little type here, a migration result, which can either be a success or a failure. In case of a failure, it can also have a reason. So it's just to say that for each thing that will migrate, if it went well or not. And then we have this here, a sample migrator, which, so the focus of the presentation will be implementing the console UI part with Spectre.Console. And this sample migrator is like the business logic that actually does the migration. So it's a dummy implementation, of course, with a bunch of task delays. So we have four methods here. We have a connect method that receives the username, a password, and the environment to which we'll connect to do that migration. We have that gather migration information that we will use after we connect to present the user with some information so it can be decided to proceed or not. we have migrate async, which will actually do the migration. And as you can see, all of these are asynchronous methods. Most return task. This one returns async enumerable. So the other ones you'll see when we implement the actual logic, like one-shot things that we connect and it's done, or we gather information and it's done. For the migration itself, as we want to report progress as we go along, I'm using async enumerable because it's a pretty cool way to just do one item migration at a time. We can interrupt in the middle, we can report progress and stuff like that. And as you can see, the implementation is just a random to return success or failure, and with a delay just to pretend that the migration takes some time. Finally, we have a dispose async method so that we can disconnect, clean up, and stuff like that. So this is the scenario, a command line tool to migrate things. One of the fundamental building blocks of Spectre.Console when implementing a command line tool like we want to implement here are the commands. So commands, you can imagine like when you use the .NET CLI, the .NET add, .NET new, and .NET, I don't know, .NET SLN, I think it's another command. So those are the commands that we can pass to our application. And in Spectre.Console, we can create those types of commands like this. So we create a class that inherits from either command or async command. In this case, I'm using async command because it will be an async task to be executed. The commands can get settings. So the settings are the arguments that will pass in the command line for the command to use. So these settings inherit from command settings. And because I used async command, we have an execute async method that gets a command context and the settings. Back here, we also have, that one was the migrate command, and here we have a rollback command, which doesn't have settings because I will just do a simple implementation of this one just for the demo. But so this one only has execute async and no settings here. So these are the commands that our application will implement. Right now, this doesn't work. If I try to run this, it will just have a compilation error because there is no main method. We just have those command classes. So we implement it, and here we create a command app, which then we call configure, and it's where we configure each command. And we configure migrate and rollback and give it a name. So this is what will be used when invoking the commands in the command line. We'll need to call the application, pass the command that we want to run, and then just return app, run async, and we give the control to Spectre.Console, which will then make use, depending on what we pass to the application, will forward to the right command. So now we can run it. So I will go in .NET Run. And you can see immediately that we have some information. This is equivalent to doing -h or -help. So it shows us how to use the tool. It auto-generated the docs for the tool. Right now, the only options it has for no command is help and version, but it also informs us that we have migrate and rollback command. So we can run this migrate, but we'll get not implemented exception because I haven't implemented the method yet. So let's start implementing things. So what's the most important thing to implement when we start building a command line tool? Of course, it's to give the tool some flair. So business logic later. So let's start with adding some flair and introducing some concepts of Spectre.Console. So the way to interact with the console, with Spectre.Console, I will say console a lot of times during this presentation, I'm sorry. So is by calling nc-console and then using its methods to interact. In this case, we want to write to the console, so we call write. And write receives renderables. And renderables are the widgets that we can create. And in this case, the widget will use its a figlet that will write the text that I'm putting here in basically ASCII art into the command line. And then you can see we have a Fluent API to configure our figlet here. So I'm saying that the figlet should be left aligned and the color should be teal. So now if I go here and run migrate, now we have some pretty thing showing when you run the application, and you probably already used a bunch of command line tools that print stuff like that. So we can just do it simple as you saw. Now let's actually start implementing the logic. First thing is we want settings. So as we saw when I presented the scenario, to connect to the environment, we need the username, the password, and the environment. So I'm going to create here some settings. And so we have the username, the password, and the environment. I made them all nullable just because I want to use in the context of the demo. I want to, if it's not passed as an argument, I want to ask the user for input. So when we define these properties, we can put the command option, which is how we configure if it's how to pass the argument. So -u or -- username are the options to fill in username. And then we can pass a description. So username to access the environment for migration. And you can see the same for the other properties. Now let's run this and call help. As you can see, we now have generated the docs explaining how to call migrate using the various options, username, password, environment, and the documentation for it. The description appears. So, starting to look a bit better. But now, let's actually use this. As I mentioned, I want to double check if the user passed username, then we'll use it. Otherwise, we'll ask for it. So I have it here. So ask username, and then I will use local functions throughout this presentation. It will all be in the same file, but of course you can and probably should split things into multiple files, organize the code in the best practices and all of that. But for demo purposes, I will just shove everything here just for simplicity's sake, but don't think that we need to do it like that. So I'm asking for username if missing, so passing the username, and it's something pretty simple. I'm just checking if it's null or white space. If it's not, return current. Otherwise, we will interact with the user, again, NC console, in this case, prompt, and we pass a text prompt. So it's a prompt where we are expecting to receive, so the user can type the information we are requesting. So we're asking for the username, and we can pass a validator. So if the user passes in information that's not valid according to what we are expecting, we can add the rules here. I'm just validating that it's not empty. If it is, success, otherwise error. Now we can run migrate again, and I will not pass a username. So it's asking for the username, and I'll just write something, and it's good. If I pass a username here, then it won't ask anything. It's not really a Spectre.Console thing. It's just because I put an if in there, but yeah. So you can see how it is. The validator isn't actually doing much, because if we try to put it, if we try to run it like this, it will not allow me to input something empty. But let's take a look at a better example with the password. So let's do the same thing for the password. So let me add, but the difference is that the password, just for, again, demo, besides not being empty, we want to enforce some weird validation rules. So I created this try get valid password, which is basically checking that it's not empty and length is larger than 2. And then this code is mostly the same as before. The difference is that instead of using is null or white space, I'm doing try get valid password. If it's valid, just return it. Otherwise, again, use a text prompt. But this time, we also add the secret. So it won't show when we type the password, it won't show it to us. But other than that, it's the same. One thing also relevant to point out is when validating, when it's an error, we can pass some text to show the user. And you can notice here that the text has these square brackets yellow here. So when we are passing text in overloads that support like markup, this is Spectre.Console markup, we can configure styles for the text. And in this case, I'm just saying that if it fails, it's yellow. Maybe it's an error, it should be red, but whatever, ignore that. So let's see this in action. I'll just pass the username always, just so we don't need to write it again. And it will ask for the password. As you can see, if I write it, it will hide it. Let me just put 2 characters that are not allowed. So it's invalid. It doesn't allow it to go through. And as you saw, I didn't need to do custom code for that. I just needed to implement the validator, because I could also do it like always asking until it's good. But if I put the correct password, it will work. It will also, if I do password like this, it won't ask again. But if I pass just 2 characters, it's invalid and it fails. So, okay. So password out of the way. You can see, like, similar to the other one, just change a bit the validation logic, add the secret thing here. But yeah, a nice way to gather information and validate it using the text prompt. So what's missing is the environment. And for the environment, we can do something slightly similar, but slightly different. So again, let's go for ask environment if missing. And let's add a function here. So the initial logic is the same. If the environment is there, use it. Otherwise, again, we use a prompt. But this time, it's not a text prompt. It's a selection prompt. So instead of the user having to type that environment, it can be typed when we're passing the arguments. But if not passing the arguments, if there's an interaction, the user will be able to select it instead of typing. And we can pass in the choices, in this case, environment, development, staging, production. So if you run it, now we have this little select. Instead of typing, we can just choose what we want. And I can choose development. Or we can just pass this. And it's bypassed. It's nice that when it's like the user is discovering the tool, can have this. I don't know if many of you use like the Angular CLI or Vue CLI or whatever, and when following the templates, it asks these questions, and you can select if you want to configure ESLint and stuff like that. So it's something similar, pretty cool. Okay, so we finally gathered all the information we need. We need these three pieces of data. So now, just before proceeding, it's probably a good idea to ask the user, is this all good? Is this according to what you thought you were introducing? So we can show the user this. And we can do it using a table, which is another widget. As always, NC-Console, write, passing the renderable, Fluent API, adding a couple of columns. So a column with setting, with header setting and centered, a column with header value centered. And then we can add the rows. In this case, I want a row for showing the username, a row for showing the password, which is not really shown because we shouldn't show the password, and another row to show the environment, which, as you can see, I'm using a markup to pass as the value. And it's the same as we saw before, but I'm parameterizing based on the environment, showing that green for dev, staging yellow, red production. So if we run it, now create a table showing the things. So this goes a long way in that what I was saying at the beginning, that when we are just printing to the console, it's very hard to rapidly see what we want, like to have the attention pointed in the right direction. And by using these widgets, it's much easier to see, okay, it's stable with a summary of the things that we input. So, but here, nothing particularly, this is nothing from Spectre.Console. I'm just mapping the environment to some string color, which is then used over here to create the markup. Now we wrote the table, and now we will ask the user, proceed with these settings or not. So we'll again use the selection prompt, and let me just remove this and I'll show you in a bit. So we have another selection prompt, which is asking the user, proceed with settings or not, and the choice is true or false. And if proceed, then we'll proceed, otherwise we'll just get out of the program. But if I use this, you'll notice something, that proceed with the aforementioned settings, true or false. Yes, we understand it because we're programmers, we spend our time thinking in booleans and stuff, but it's not really great English, I guess. So one thing I want to do, and I didn't do it for the environment because the enum was pretty self-explanatory and simple. It was a single word. But in more complex cases, or when we just want to have a little bit better text, we can do it, use a converter, which converts the value to the text that we actually want to see in the console. So in this case, if we are asking proceed with the settings, we want to show yes or no instead of true or false. So if we go like this, now proceed with the settings, yes or no. It's, I guess, better. For us, probably it's a bit irrelevant, but it's better like this. So it was another usage of the selection prompt, in this case for a bool instead of a string, or in the other case, an enum. But we could use a converter, and Spectre does its thing to map things back and forth to what we want. Okay, so we have all the information. We ask the user if it's all good, and if the user says yes, then let's go. So it's time to implement like the actual logic to interact with that sample migrator class that I showed in the beginning, that is actually doing the logic of migrating things. We have everything that we needed in our hands. So I'm just going to create the class here directly and put a try finally here. In the try we'll do stuff, and in the finally we'll clean up. So the first thing we want to do is to connect to that environment using that first method that I showed you at the beginning. So let's connect. So over here, I'm using Spectre.Console again, NC console, status, which is a way to provide visual feedback to the user about things happening. So status, start async, and I'm calling the migrator connect async. So while this operation executes, we'll have basically a spinner. This is just the same as when we have a web application. We don't actually know the progress, but we know that something is happening. So we're not just looking at the command line after we press enter and nothing is happening. We at least have some visual feedback. So I'll go over here, run it again, see it, and as you can see, a little spinner. Let me show you again because it's fast. So it's a little spinner just giving us some feedback that something is happening. Not that if it crashed, it will serve much, but at least I think it's better than just staring at a blank command line. Okay. So the steps are connect, and then gather some information to, again, confirm with the user if we should proceed considering the information we gathered. So let's add a bit more code here. So again, using a status. In this case, as you can see, it's actually returning something because the connect async method didn't return anything, but gather migration information connects something. So when you are using the status and passing a method that has a return, it will be passed back so that we can have that information. Other than that, it's basically the same thing, but again, using the Fluent API, I'm configuring a different spinner. Instead of that default one, we can use different ones. I imagine we can also implement our own. I didn't do that. I'm just using a known one, which is a clock. So instead of that little spinning yellow thing, we'll see a clock. And after that, again, we have a selection prompt to the user if we should proceed or not. So let's go here, start things again. See, yes, connecting, gathering information. You can see the little clocky thing. And yeah, let's proceed. Just in case it was too fast, let me show again. Connecting, gathering information, and asking. On 150 things migrate, proceed, yes or no? Yes, but not done yet. Okay. So assuming the user says yes, we have some more logic, but before, let's just wrap up the finally part, which will be basically the same as we saw. It's another status with calling dispose async. So let's quickly see it, but it's exactly the same code as before. So we're just basically everything that returns a task, or in this case, valid tasks, I put it inside a status so we know when it's done. So connecting, gathering information, found, yes, disconnecting, it's done. Yeah, so these are basically our spinners we put on the web, but apply to the command line. So now let's do the actual migration. We have all the information, the user is connected, it confirmed that it's all good, let's go. So let's use something that's kind of similar to status, but is instead of just something spinning, it's actually something that presents the progress in a more detailed way. And it's called progress, which is pretty cool, pretty obvious name. And we get a progress context with which we will interact. So it's the way we report the progress, and Spectre.Console will render it. So it has a concept of tasks. We have multiple tasks within a progress.
which will basically mean, well, imagine that we have multiple things, like when we are installing some software that it downloads things, installs things, and uninstalls other things, and it's all in parallel, so it can have multiple progress bars. So we can do that here. I'm just going to use a single task, so nothing like that will happen. But yeah, we add the task to the context, we provide a description, and they provide a max value, which will be the number of things to migrate. So Spectre.Console will handle transforming those values into percentage and stuff like that for us. We don't need to do it. And with this task in hand, we can actually implement the logic, which will be to call migrate async and iterate, because it's a async enumerable. All I'm doing with the results is counting the successes and failures. We could do something more interesting, but for this use case, successes and failures, having their count is good enough. And then await for each on the migrate async method, incrementing depending on if it's success or failure. And then the migration task that we created, we increment to signal it progressed. So in this case, we can pass other values. For example, if we were creating a download and it downloads 2 megabytes instead of 1 in a go, we can immediately report 2. But in this case, because we are really granular, going one item at a time, we can just use the increment 1 like that. And finally, I'm returning the successes and failures so that we can use it later. Now, let's see this in action. Run it again. Let's proceed, connecting, gathering information, and let's go. And as you can see, now we have a progress bar with percentage. So I put 100 milliseconds, so that's what it's happening. It's waiting 100 milliseconds between each item of the 150. And eventually it will wrap up and call disconnect. Yeah, so we have pretty nice progress. And as you can see, it's a much better progress information than printing a lot of console write lines with everything that is happening. It's much easier on the eyes. So let me just adjust this so we don't wait a long time each time I'm showing this working. So I'm going to just replace this. Okay, so all good. We have progress report. We return these results. Now let's use them. So it's just an excuse to show you another widget, which is I think it's this one. Yeah, a bar chart. So we can also present a bar chart. The results. We have more widgets, other ways to show. Maybe I could use a table to show more detailed information. In this case, just a simple bar chart with give it a label with succeeded and failed, give it the count of succeeded and failed, and give it the color. And then it will create for us a bar chart with this. And just to reiterate, all these NC console write, renderable, always pretty straightforward. Let's run it again. Proceed, let's go. Other information, let's go. And done. Okay, so we have the migration results. Just presenting, as you saw at the beginning, it's just random. So if I run it again, it probably would be slightly different, but not a lot. But yeah, so this would be a way to implement a migrate tool using Spectre.Console. Just some ideas, showing a bunch of widgets, and it would be something like this. So this is the main part. I wanted to show a bunch of different widgets, ways to interact, gathering things from the command line. Now, just for fun, let's just do a quick experiment with the rollback.
So I'll just replace this with the whole code, show you what's working, and then we'll come back to analyze a bit that code. So SP, okay. So this is the rollback command. So let me go here, erase all of this, and have rollback. And what we have here, we have rickroll. So I bet you weren't expecting this one. Rickroll on the command line. So yeah, probably this isn't the most useful thing, unless for presentations like this one, it's useful, I think. But I wanted to use this as an example of a couple of features. First one is integration between Spectre.Console and ImageSharp, which is what's making this work. And additionally, as you can see, it's moving. So it's using live display feature, which is similar to what's happening with progress and status and stuff like that. But we can use it to implement, if you can imagine something more useful than this. For example, maybe you want a stock sticker in the command line. I don't know. You could use it like that. You can just create a widget and put things in there and refresh, and it will happen like this. So let's just see how this feature was implemented. So first things first, props to Khalid, because he was the inspiration for this part of the demo, as he was playing with Spectre.Console and pushed something on Twitter, and I got inspired. But other than that, what's happening here, I'm just using a cancellation token source to listen to Control-C to cancel the command running. We're creating a table. So old school HTML vibes, as I don't know CSS, so I use tables to put things clean. So I created a table centered with no headers or border, with a single column and 3 rows, one for the GIF, one to put some space between the GIF and then the lyrics. And then again, NC console, and now live, to use the live display feature. We pass the table, which will be the widget that will be updated with the live display. We start it. I created a class just to handle the lyrics generation that you saw happening. And then ImageSharp comes into play, where we load the GIF. We use that cancellation token source to wait for if it's canceled or not. And in the meantime, we go and we iterate over the frames of the GIF, clone the frame, save it as a bitmap to a memory stream, and then pass it to Canvas image, which is a Spectre.Console ImageSharp integration point. And then I am updating the table. So on row 00, I put the Canvas image, and on row 20, or better yet, cell 20, I'm putting the verse from the lyrics. And then I'm just getting a time span of 75 milliseconds, seek the lyrics forward, and task delay. So every 75 milliseconds, the next frame of the GIF is used. So again, I'm using a GIF because it was funny to use in the presentation, but you can use something more interesting in your application. Okay, so code time is over. So let's wrap up. There's much more. So I just showed a bunch of things, but because I can't possibly put everything in the presentation, or I can, but it would be longer. So there is dependency injection container integration. If you have a more complex application, or just have to integrate with things that are normally used with dependency injection containers. You can use command composition, like, for example, .NET add package or .NET add reference are composed commands. You can implement something like that. Command settings validation, which I didn't use. I just used validation of prompts, but you can also validate settings. You can pretty print, file paths, and exceptions. You can use other prompts and widgets like multi-select, rules, calendar tree, and so on. And there's more things, but again, there's a lot of cool stuff in Spectre.Console. Just because I couldn't show even more things that I wanted in the demo, I copied a bit of the things that they have on Spectre.Console.net website. So again, file paths, Windows, Unix, you can style it, align. Exceptions, which is pretty cool. It's much more readable like this than the usual. Multi-select, so I showed you how to use selection, but just select one. We can also select multiple. Use calendar, a breakdown chart like from the languages in GitHub. Trees, I've used trees, although not like that, just to show like this happened and these were the reasons below, something like that. And yeah, so you have a bunch of stuff. In summary, and again, making a usable console UI is not trivial, but Spectre.Console sure makes it a lot easier, in my opinion. And even if we are just trying to hack something quickly together, which is my case most of the times, this is pretty cool because it's really easy to have something much better than just with console write lines. And also great docs make it super straightforward to get started. The demo, of course, there were tweaks later, but most of this demo was developed when I was just playing around with Spectre.Console. And it was like one afternoon, I just had the docs, the site open, and I was hacking away and like, I want to do this, I want to do that. And it was really easy to do it. If you're interested in the demo code, feel free. It's on my GitHub, so you can take a look. Other than that, thanks for joining, and feel free to reach out on my site, blog, Twitter, LinkedIn, whatever. If these links are not enough, just go to the site that it has more links there. But yeah, thanks.
So we're back, and that was just amazing. I don't know whether to be proud or scared that I inspired you to create a Rickroll in a console, but I appreciate it. So thank you so much. That was awesome.
I think the worst part there was this was actually one of the questions that I had, like, can it run animated GIFs? And you answered that brilliantly. So well done.
Yeah, it's you said it really well. Like Spectre.Console has a lot of widgets that can kind of help you imagine what a console experience could be outside of just console write line all the time. So it's really cool from that perspective. Do you have a favorite widget from kind of the component library inside Spectre.Console?
I don't know. Maybe live display to Rickroll people. But in terms of work, what I've been using at work, because I was developing something similar to this to import stuff from one place to the other.
Mm-hmm.
And I used a lot the tree, because when I was importing, I was doing some validations of the quality of the data. So I was validating all the properties from each item.
Mm-hmm.
So I used the tree to like, this item failed. And then below, because of this, and that, so that I could then report to the user, go fix this because it doesn't work. So it's probably what I use more. And just the colors, it's a massive help, because we can change the colors when we are using console write line, but it's just annoying. And this is much better.
Yeah, console colors are very interesting, because even though colors can have names like black, white, green, those actual like color values are actually defined inside the terminal. So it's like colors are they're just so difficult, but Spectre.Console definitely at least makes it easier to rationalize what's happening with colors, which is super cool. You showed a lot of fluent interfaces. Somebody mentioned, with validation, can you plug in different validation models? They specifically wanted something like data annotations and attributes.
I haven't actually tried.
Mm-hmm.
I think I saw, for example, at least for the command settings. I think I saw that we can put like required. I'm not sure.
Mm-hmm.
But other than that, I've been doing it like that.
Okay.
Mostly with that fluent way of doing it.
Mm-hmm. Yeah, and it was those were such cool demos. Martin, do you have any other questions that you kind of are itching to ask?
I think there was one in the comments on YouTube as well, where someone was asking whether Spectre.Console can also be used as a logging provider or an iLogger in your applications, just to make things look nice and maybe even rickroll people when a certain exception pops up.
Well, I imagine we can implement like a sync, like implement a Serialog sync with Spectre.Console. I didn't try, but it's probably possible.
I would imagine it's possible, but I would also imagine it's very dangerous, because if you're in like a CI/CD environment and you pause the process to ask for input, the bad things will happen. So
Yeah.
I probably wouldn't recommend trying, I guess, but go for it. I'm not going to tell you not to do nothing. So,
yeah. In CI/CD, it's probably not good. Well, once someone asked if Spectre.Console would automatically like disable the like the prompts for CI/CD, like I think that's logic from our code. If we are in CI/CD, we'll not show prompts. Otherwise, it will just show. But
yeah, and doesn't Spectre.Console manage essentially like the buffer? So it kind of knows where things are positioned, but in a CI/CD output, it's more of a scrolling output. So you end up in a situation where like the essentially that canvas is just so different. It's like a different paradigm almost. So you're going to get really strange results, I think.
Yeah.
But yeah, no, that was a really great talk. I really enjoyed it, and I can't wait to put a bunch of rickrolls in some production apps.
I was going to comment in private after this session that I now want to go and build a console application. So thank you for that. I did wonder, because there's so many tweets and people talking about console applications. It's almost like there's a console app revival going on. Like, I know there's Spectre.Console, but I've also seen Miguel de Casa come up with terminal.gui or GUI-CS or whatever it's called. So do you get that impression as well? And are we steering away from Blazor, from Maui, and just all building console applications?
I don't think that, but I think with .NET, how's it called? The .NET tool, global tools. With .NET global tools and with .NET 7 native AOT, it's going to be much better to build like these kinds of tools, and they will be more efficient. So maybe you don't need to go to Rust. You can, but maybe you can just do it in C# and it's native AOT and will be super fast. So for those kinds of tools, it's pretty cool. The inspiration for when I saw Spectre.Console, the main reason I was like, I want to try it, was because I was playing with like Vue.js, and it had like the CLI that you start it and it asks a bunch of questions, like if you want to use ESLint and if you want to use whatever, or if you use TypeScript or JavaScript, and all of those settings that it will then generate boilerplate for. So I was looking at it, and it was like this with all selections and colors and stuff. And when I saw Spectre.Console, I was like, we can do it in .NET as well.
Yeah, it's fascinating. You know, it's like I always struggle with the flags in .NET and global tools. Like, is it a double dash? Is it a single dash? Do I need to put the double dash before I call the arguments so that it passes in? Like, you kind of showed how you can easily manage flags in your own CLI applications, but how do you find the ecosystem in terms of that kind of tooling, command line tooling? Is it a good thing? Are there frustrations you have with it? What are your thoughts?
No, my biggest frustration were really like parsing the arguments was super annoying. But I did already use something else. I don't remember the name, but before I found Spectre.Console, I used something else just for that parsing. For example, in one of the of these automation tasks that I did in the past with a colleague. One of the things that we wanted was like to receive passwords, and he implemented this like with the asterisks by hand. And I was like, good that you did it, because I didn't want to. But now we have Spectre.Console and it will do it for us. So at the time I didn't know about Spectre.Console. I just found out about it like 6 months later. And I'm like, yeah, this would be helpful like 6 months ago.
That's a good follow-up question. Is there a widget or component that you think is missing that you'd love to see kind of written in Spectre.Console?
I don't know if it's a component. One thing that I was thinking, because I already had the demo mostly ready, but then I was like, can I make it more complex for the event? And I was like thinking, besides having like the progress bar, having like a table or something like that, auto-updating with the things that failed, but multiple live things are not supported. It's just one at a time, which is already great to have something live updating on the console. But if we could have more things live updating on the console.
It's funny. It's funny you mentioned that, because it's kind of reminiscent of like the island stuff that's happening in front end, like where you have static web pages, but you have these islands of dynamic content. It's kind of what you're describing there, which is kind of like, it's fascinating to see the corollaries between all UI frameworks, regardless of its JavaScript, console apps, server rendered stuff. So it's pretty cool. Martin, do you have any other last thoughts?
I don't have any. I was just watching the chat for questions, but nothing is popping up. The only thing that we see is some comments and people saying that they all want to build CLI apps, and that everyone nowadays who thinks they're a professional developer are building CLIs and at least using CLIs. So I think Spectre.Console and building your own tools on top of it might actually be a good thing for the future.
Yeah, I'm excited for the CLI future. So yes, bring it. On that note, it was great having you. And again, this is before you go, I do wanna call out your writer skills in terms of like shortcuts and snippets and stuff like that. That was just it was excellent. So awesome stuff.
I did actually do this the first time using copy paste, and then I remembered, writer can do this for me.
Yeah. We're going to use that quote, writer can do that for me. That's it. That's perfect. On that note, thank you so much. Great presentation. We'd love to have you back. Thank you so much.
Thank you. See you later.
Thank you, João. Bye.
Bye.
That was
all
really,
right.
That was really cool, Martin.
That was really cool indeed. I think we have a completely opposite direction for the next speaker, where we'll not be building CLIs, but I guess we'll be building microservices with .NET and Dapr. And I'm really curious about it because I read a lot about it, but I have never seen it in action. So I think our next speaker is probably going to be the person to show it in action and enlighten me on what it is all about.
Yeah, so let's bring him on. Cecil, you ready? I'm going to give him an opportunity to give me a thumbs up before adding him to the stream. So, but I'll wait. But yeah, Dapr has really been interesting, especially as we all kind of move to kind of cloud and distributed languages and stuff like that. So Dapr is really an opportunity to have a lot of synergy across different technology stacks, but have kind of that interface. So Cecil, are you ready?
I see he's ready. He gave the thumbs up.
All right.
Hey.
All right. Hey, man.
Hey, man. How's it going?
Good. How you been?
Pretty good. It's been a pretty fun day, kind of jumping between all the .NET technologies and stuff like that.
Yeah.
But Dapr is really one of those interesting topics that I think a lot of our user base is going to get a lot of benefits from seeing. So we're excited, very excited.
Yeah, Dapr should be pretty fun. There are no console applications though, so I apologize. But we're all going to build some cool stuff, so hopefully people enjoy it.
Yeah. If you're ready, I'm going to share your screen, and then Martin and I will disappear. We'll be here. If you need anything, just let us know.
All right. Thank you, folks. Appreciate it. And so, hey everybody, my name is Cecil Phillip. I'm a developer advocate at Stripe. And this is actually my first time speaking at a JetBrains event. So, I got to make sure I do this more often. So super happy to be here. What we're going to talk about today is Dapr, right? Which is like a framework that makes it a little bit easier for you to build microservices, regardless of whatever language you're talking about or tools that you're using or anything like that. And, I'm a .NET guy, so I'm going to do it in .NET, right? Like we're going to see a bunch of .NET demos and, all this types of stuff. But I got to tell you, I do have some slides. So we're going to go through a little bit of slides, not too many slides, but then we're going to dive into some code and we'll see some examples of how you could actually, build a real application that uses Dapr. All right, so why don't we get started? So let's talk about what makes microservice development so challenging, or at least my opinion of why it's so challenging. Now, when you think about like that ecosystem, like there's just so many different options, right? And options are usually a good thing, right? There's open source options, there's options you can pay for. If you think about things that you want to do in your microservices, like you might say, hey, I want to do messaging, right? I want to be able to, have traceability, right? And use something like open telemetry. I want to do service discovery or have a state store or secret store. Again, like any of these different types of things that you can think about make up like a core tenet of, a feature that you want to do in your microservice. Now, the thing with that now is that, well, for each of those things that you want to do, there's just so many different options, right? Like I'm sure any of you here that are watching now can name 2 or 3 or more message brokers, right? Like RabbitMQ or RocketMQ or ActiveMQ, Azure Service Bus, Amazon SQS, and so on and so on and so forth, right? And now as you're building these services, like now you're trying to pick these components that you're going to use to compose your application. Like there's a lot that you kind of have to think about, right? You have to think about, oh, well, does it run on, my operating system that I'm trying to build and deploy on? Does it work with like the programming languages that I want to use? Like, are they SDKs or not? Or is it like an ACTP thing that I could call, right? Like so many different things that you have to kind of consider. And with that, like, I like to call that the microservice matrix, right? Depending on what you want to do and the more things you want to do, it just becomes a very complicated collection of things that you have to try and put together to solve your particular business problem, right? And obviously, the more time you spend doing that, it's going to be more time of your sprint. And, who has really time to spend like evaluating all those options just to find the one that works really right for you? And so for me, that's where Dapr kind of comes into play, right? It gives us an option of, creating like this runtime that we could use that abstracts some of those common practices and some of those common use cases that a lot of microservice developers kind of use. Right? You think about, being able to add something to your application that's not going to add a lot of weight, but still it gives you the flexibility to kind of not think about so much the thing that it's implementing the feature, but more so the thing that you actually want to do, right? You spend more time, creating business value and less time fiddling with configuration and SDKs and NuGet packages and et cetera, et cetera, et cetera, et cetera, et cetera, right? And so the way that Dapr does this is that it really, starts off with standards. Like what are some of the common standards we have in our industry, right? We think about things like using HTTP or AMQP for messaging protocols as we go back and forth. We think about using tools like open telemetry that I could use with these different, telemetry and logging and metrics providers, right? I think about, needing to be able to be open source. I needed to be able to run with different languages. I needed to be able to run on different operating systems and runtimes, right? Like I need a truly open tool and framework that's going to allow me to create, the application that I want to build. So when we think about Dapr now, the way that it achieves this is based on this concept called building blocks. And what building blocks are essentially different sets of tasks or things that you might want to do inside of your microservice. Right? And behind each building block is some type of implementation. So right now, these are a few of the building blocks that Dapr offers. So you think about things like, service to service communication, state store, publish, subscribe, observability secrets, like in all of these different types of things, right? But now, not only do we have like these different types of building blocks and things that we could put on top of our application, but we also have the ability to use them with any programming language that really speaks gRPC or HTTP, which most of the languages that I use today can speak HTTP. If you're using a language that doesn't, well, talk to me. We can figure it out a little bit later, right? But again, if your application speaks HTTP or gRPC, then you can work with Dapr, right? And that's really the only requirement that you really have, right? What happens is that like over very well-defined API endpoints, you can make a call to a service, make a call to Dapr, and you could say, hey, Dapr, I want you to publish this message for me. Or, hey, I want you to drop this thing in the state store. Or I want you to, give me the secrets, wherever the secrets happen to be stored. And my application really doesn't need to think about it, right? Like I don't need to know like what's the backing store, what's the thing that's behind, that's implementing that. I just need to know, okay, hey, you're going to do this job for me. I'm going to delegate to you and you'll figure it out. And then I could keep on doing what I'm doing, right? Like processing orders or, filing insurance claims or, I don't know, drop the dot for Khaled, whatever it is that we want to do, right? Like we can go ahead and like start processing like these types of workflows. Cool thing about that too. So not only does it work with different programming languages, that it works, across different hosts. So you could run Dapr anywhere. I'm going to be running it here on my machine locally, right? But if you're running in the cloud, right, you can put it on, GCP, Azure, AWS. You can run it inside of a virtual machine. Pretty much anywhere that you can run your code today, you should be able to run Dapr. Okay. Now let's kind of talk about the components, right? So we spoke about those building blocks. Behind the building blocks has to be the thing that actually implements the building block, right? So the building block is just an abstraction. It's just here's a feature that we offer, right? But behind of that, somebody or something has to actually implement that feature. So again, if we think about like state storage or even pub sub, and we're going to see some examples of those, if it's an abstraction, like where's the thing actually being stored? Like where's the message actually being published to, right? And again, like I said before earlier today, like we have that microservice matrix, right? Like we have tons of different options that are available for us to choose from. But again, because I don't want to think about it, I'm going to kind of delegate that to Dapr, and Dapr will figure it out. So if you look inside of the Dapr repo inside of GitHub, and you'll notice that there's a components contrib repository, and inside it, like there's tons of different community and also corporations and different types of folks that have contributed like different components, right? So as you can see here, we have support for things like Azure Cosmos DB and DynamoDB and Service Bus and Key Vault and Prometheus and Grafana and all kinds of stuff, right? Like more things that I even know what they are, to be honest with you. But like there's just so many different options for you to choose. But again, the important part is, again, where your app stands and when it talks to Dapr, it doesn't really need to think about those things, right? That's not something that it really needs to be that concerned about. So, okay, so we have the building blocks, and then we have the components that implement those different building block features. So how exactly does that get into Dapr, and how does my application actually get access to that? Like, how do I actually start working with it? So if you think about how Dapr works today, right? Dapr essentially is an executable, right? It's a little tiny executable. And what you'll do is as you deploy it, you'll have one instance of it for every instance of your application, right? And that's a very common pattern you might see with folks that are building microservices called the sidecar pattern, right? So if I'm building a web API, I'm going to have an instance of Dapr right next to my web API. Yeah, if I have a background service that's processing work, I'm going to have an instance of Dapr sitting next to that. If I have 10 instances of any one of those, I'm going to have 10 instances of Dapr. Because again, the whole goal is for it to ride side by side with your process, right? And then now as your application needs resources, well, it could just ask Dapr for it. So if you take a look at like this diagram that I'm showing you right now, you can see that I have service A and then there's a service B, right? If service A wants to communicate to service B, what would we usually have to do, right? I'd query DNS records, I'd have hard-coded configuration somewhere. Maybe I'd have some service discovery thing like console or something like that, or etcd, but I might have to query and be like, hey, tell me where this stuff is. And then even with that, right, like even if I figure out, okay, I have some hard-coded configuration, how do I know if it's healthy? How do I know it's up? How do I know that the address didn't change, right? Like things happen inside of our applications. We have to be able to deal with all these types of things. Well, luckily, if you're using Dapr, well, I don't really need to think about that anymore. At least not from an application perspective. Like Dapr is going to figure that out for us. So if service A makes a call to Dapr, right, or its instance of Dapr, then it's going to be able to know, well, what are all the different components that have been configured for those different building blocks? And what are the other instances of Dapr that are inside of the machine, right? So again, as you stand it up in your infrastructure, for every instance that you have, every instance of Dapr knows about, well, all the other instances of Dapr, right? And they kind of form like a little bit of a web, right? They all kind of form like this mesh. And so now, again, as I communicate with one or many instances of different services and components, I don't have to know about like the address of where they're located or anything of that sort. Like Dapr will just go ahead and it'll figure it out for me. So that works out pretty cool. So here's a quick example of what it looks like. Again, so I have my application. Now, when it comes to actually deploying your app and your Dapr sidecar usually exist within the same space. So when I say the same space, your app should be able to speak to Dapr on localhost, right? They need to be able to know where each other's ports are. So, your app has to be able to see Dapr on localhost, and Dapr has to be able to see your application on localhost as well, so they can communicate. And now what happens is that there's going to be, again, this gRPC or HTTP channel is going to be open for the communication to go back and forth between your app and Dapr, right? So you could know, okay, well, this is the app and it's here. And then your app could be like, hey, I want to send requests to you for you to do some different things. All right, so let's talk a little bit more about these building blocks, right? So we saw the sidecar model. We talked about like the architecture and how that stuff kind of works a little bit. Let's actually look at one of these building blocks or a couple of them and then see, well, what does it actually look like to use Dapr, right? So here's a service invocation one. Now, when we think about service invocation, you think about something like service discovery, right? I have a multitude of services, like each of them doing like a different task, right? How do I know where they are? How do I find them? How do I call them? What's the endpoint, et cetera, et cetera, et cetera, et cetera, et cetera, right? Well, like I said before, for every instance of your app, you have an instance of Dapr. So now whenever I make a request, again, my app is making a request to service A. What I'll do is, hey, I don't know where service A is, but I'm going to hit Dapr, right? And Dapr uses this thing called multicast DNS. If it's running, on your infrastructure or on my own laptop, right? It's going to use this thing called multicast DNS for service discovery, right? It's going to be able to discover the other Dapr instances. And it's going to say, hey, does anyone know where service A is? And, the other one's going to be like, me, like that's mine. I have it. And now I'm going to be able to forward that request, or Dapr is going to be able to forward that request for you and then send it back after like service A has processed that response, right? And again, like my app doesn't need to know anything about that. Now, one of the important parts I want you to see here is that if you take a look at the URL that's at the bottom, right? Dapr provides well-defined API endpoints for all of its different services. So for instance, if I wanted to invoke a method, right, on service A, it'll be invoke. You notice I have the name of the app. It says service A /method. And then the end of it, I have something called new order, right? And if you look on the right side, you can see like the endpoint is going to, attach to, right? It's going to hit that /new order endpoints on the other side. Now, a lot of .NET developers might be like, well, what if I have an /API /something? Well, that's fine, right? It's just a path. All you do is just append your path to the end of that, that template. So it'll be service A /method /API /drop the dot, right? Like /something. And that's what's going to happen. It's going to translate it over and it's going to hit that service, right? One thing that's cool, depending on the environment that you're running in, and this is actually a new feature. I think this one came out in like Dapr 1.7, maybe 1.8. There's this thing called pluggable name resolution. And this comes in really handy when, hey, I want to be able to talk to services that don't live in my space, right? It lives in a different cluster somewhere, or it lives outside of my environment, right? What we can do is be able to use things like HashiCorp-Console, if folks are familiar with that, to be able to say, hey, I want to request this service. Let me know where it is, right? And then, for any service that's registered in it, whether it's inside of your infrastructure or not, as long as Dapr can speak to that instance of console or, again, whatever other thing you're using for service discovery, it's able to like, again, like kind of poke its head out and like go to that other world and come back and like, deal with the responses from that particular request, right? Let's talk about another building block. I promise we're gonna get to demo soon, I promise, but slides are good sometimes. So when you think about PubSub, right, you think about, hey, I have a lot of different things that are in my system and I want to be able to publish a message to a queue or to a broker. I want to be able to have like some asynchronous communication, right? I don't want to do a request response. I want to drop a message in a queue and walk away. And then I'm going to have like a series of workers or subscribers being able to like, respond to those messages, pull them off the queue and process them whenever they have the bandwidth to do so. Right, so that's what we think about when we do PubSub, right? Well, Dapr supports, again, pluggable PubSub. And just like with the service invocation, it has a very well-defined URL that you could use, /publish, and then have /order/processed. Now /orders, like in that position inside of the URL, is going to represent like the pub sub, like what's the place that I want to send it to, like what's the pub sub service that I've registered, and then process is going to be the name of the topic or queue that I want to send the message to, right? So if you kind of read the URL, I want to publish to the orders topic. I want to publish to the orders broker inside of the process queue, right? That's kind of how it reads when you like look at the URL, right? And now on the other side, again, I can have one or more subscribers, again, all with their own instances of Dapr to be able to pull that out and start processing them. Now, let's talk about like, what would this actually look like if we want to configure this? Well, I know how much y'all love YAML. So Dapr is configured using YAML. And so this is kind of what that configuration looks like. You can see here on the right side, I have a component named orders, and I'm looking at the Dapr spec, and this one is saying, hey, I want to use PubSub using Redis, right? And then I just kind of give it some other information like, the connection string on the port, have the password. This one just happens to be pulling the password out of a secret store because there's support for secrets in Dapr as well. And now we're able to kind of go in and start processing some of that stuff. Okay. How about this? How about we pause here? And I'm going to switch over to JetBrains Writer. Why don't we take a look at some code, right? Because I know you all love code, right? So this is what the demo looks like, right? Right now I have an application running. It's just my events listing app, right? So inside of my events listing app, what I want to do is, well, I want to pick somewhere to go, right? So let's say we're going to go to, I don't know, eeny, meeny, miny, mo. Let's go to the night market, right? So inside of my night market, what I'm going to do is I'm going to go ahead, I'm going to hit tickets, right? I'm going to fill out some information. This just happens to be using Stripe checkout, right? But the important part I want you to see here, I'm going to put in some dummy information. Oh, that's not a real phone number, Cecil. Oh, that's a real phone number. And I'm going to just put in some fake information in here. There we go. There we go. There we go. Me. And there we go. Right? Now, what I'm doing here is that I have this application, and what it's doing is that I'm saying, okay, I want you to process this order. But then what happens, what Stripe does is that it's going to send you back a webhook event. And now my webhook event, when it comes in, I want to look at that event. I want to drop it into a queue. So like now I'll process that. I've sent off a message somewhere in the backend, and Dapr is going to go ahead and process that queue message for me, right? So why don't we take a look at JetBrains Writer really quick? I can show you what some of this stuff kind of looks like. All right, so this is Writer. The first thing that I want to show you is, let's show you how to actually run some of these Dapr things. I'm going to go ahead, I'm going to switch this to the file system one. I'm sorry, I'm not like, crazy with like the keystrokes and stuff like that, but I'm just want to show you what this is looking like super quick as it's running on my machine. So what I'm using here is a Docker compose file, right? You don't have to use a Docker compose file. It is not a requirement for Dapr, but it just makes it easier for me to run things locally. It's like a little bit, more flexible than me just running a bunch of console apps, but it's also a lot less complicated than me like spinning up an entire Kubernetes cluster to like run all these nodes and stuff like that. But it's also a good example that you can see here. You can run it locally on your machine, and you don't really have to set up a bunch of stuff to actually do it. Now, what I have here is I have a web app. So my web app is actually built with Blazor, and I'm using a web API in the backend. And I'm just pointing, hey, I want you to go out and build this container. Now, what you'll notice here too, I have my web app, and then right next to my web app, I have my Dapr sidecar, right? And like I said before, my Dapr sidecar is just a process. Well, let's talk about like some of these options that we're going to put inside of this Dapr sidecar. Right here, I'm calling Dapr-D, which is actually the name of the process that it's going to run Dapr, right? Dapr-D for the Dapr daemon, right? The app ID, which is the name of my application that I'm running. In this case, it's just called website. The port, my app is running on port 5276, and then some configuration for Dapr, right? Like, where do I go to find out like how to configure my stuff? But again, and you're going to hear me say this a lot, like for every app that you see in here, I'm going to have an instance of my Dapr sidecar. So here's a web app, here's a web app sidecar. Here's my order processor. Again, not super important what's happening inside of this file, other than the fact that I want you to see for every instance of this application, there's an instance of this Dapr sidecar, right? And here's my other one that's running here on this machine. Okay, great. Now, so you've seen how we set up Dapr. how do I actually use Dapr inside of my .NET application, right? Now let's head over and take a look at some code. Let's take a look first at let's see, which one we want to look at first. Let's take a look at the API server one first, right? And let's pop this open super quick. Super big font, because I was told I needed to make big fonts. Now, what you're noticing here, and I want us to focus on like this particular section of the code, right? What I'm doing is that like I'm creating a API client for Dapr, right? So I'm just using the HTTP client factory. And then I'm giving it the address of localhost. Because again, whenever we talk to Dapr from every instance of your app, I just want to talk to it on the same network, right? I want to be on the same machine, right? And vice versa, right? Dapr is going to look for my app, my instance of my app, on the same host, right? And that's pretty much about it, right? Nothing else needs to happen, right? I'm just creating like my special instance of Dapr. Now, let's go and see where we actually process that. And I believe it's inside of, yes, I know, I'm going to learn the keyboard shortcuts. Don't get mad at me. Inside here, what you're going to see, let's move this around a little bit. If I head down to is this the webhook handler? Yeah, if we head down to the webhook handler, there's stuff happening here, there's code happening here. The only thing that's happening that's important for Dapr is this section of code that's right here, right? And all I'm saying is that, hey, I want to get that instance of Dapr, which again, you saw it just had that base address of localhost 3500. Nothing else special happening inside of here. I'm going to create some JSON things. I'm going to create the content, and then I'm going to call post async, right? But then notice the URL I'm sending it to, right? I'm sending it to / v1.0 publish, the name of the pub sub that I'm getting from config, and order.fulfill is the name of the topic that I'm publishing to, right? And then if you can see here, again, I'm getting a lot of stuff from configuration, and I'm just sending it over like this JSON payload. What's inside of this JSON payload? Well, it's just, it's just an ID. I'm not sending anything over crazy inside of there. And it really doesn't matter what you send in here, but the fact of the matter is now I'm sending this stuff over to Dapr, and it's going to start processing that stuff for me, which is pretty cool. For folks that are going to ask this question, I know I always get this question. Yes, there are Dapr SDKs. You can totally use the SDKs if you want to do this instead of spinning up your own HTTP client. Again, works for tons of different languages. I like to do Dapr the hard way. I like to just call the raw endpoints and do it myself. Your mileage may vary. You might want to use the SDKs or not. Completely up to you. But if you want to use just raw HTTP client, now you can say, well, this is how you do it. All right. So this is one side. That's the publishing side, right? I've gone ahead and I've sent messages out to the to Dapr. Let's take a look at this other project, this order processor, right? And I believe the code is in this one, right? Let's take a look at, okay, so the /fulfillment, right? /fulfillment is the part that I actually start processing those messages, right? And this part is a tiny little bit more involved, and let's talk about why that's the case. So first of all, you're going to see here, I'm going to get this thing called a cloud event. Now, Dapr by default uses cloud events, which is a CNCF specification for sending events back and forth throughout different protocols, right? So it works over HTTP, it works over gRPC, works over AMQP. Again, standards-based, right? Dapr uses like cloud events for creating an envelope over your message, right? So I just sent over my ID as a JSON object, and now it's going to be sent in like the JSON data section and wrapped in like a message payload and sent over the wire. The reason Dapr does this is for a couple of reasons. One, it does it for, enable open telemetry and doing tracing. It also helps with routing as well, right? So what I'm doing here is like I'm using the Cloud Events SDK. Again, completely optional. You don't have to use it. This is not Dapr specific. Just makes it easier for me. And I'm going to say, hey, look at the request, and I want you to pull out that cloud event. And then inside of that cloud event, I'm just going to do some like basics, deserialization. And I'm going to go ahead and, get like that raw data payload, right? And that raw data payload just has in that session ID that we sent over earlier from the front end, right? And there you go. Now you know how to use Dapr, right? Now, what I want to do is show you like some of these other features that it has. And actually, let me check my terminal real quick. Okay, I got to run a command real quick. I thought I was running this. I'm sorry. It's not running. Okay, I want to show you the open, the traceability support that you have in Dapr too, because I think that's something really interesting for folks. So a couple of times you heard me mention, hey, for every instance of your app or every instance of your service, you want to have an instance of Dapr, right? Now, one of the things that becomes challenging with microservices, again, Now I have all of these different instances, and I want to be able to, maybe do like some end-to-end testing and follow, hey, well, if the request started here, like where did it end? Where did it go? Who did it call? Like what are all the different parts of my app that actually got touched, at least from like a network, transport perspective. And that's where OpenTelemetry comes from, right? Like it helps with things like, metrics and, logs and traces and stuff like that to help us find a way to like monitor like what's actually happening inside of our application. And as you probably guessed it, Dapr supports that. And I don't really have to do a lot of stuff to enable it. All I have to do is just say, hey, well, what's the thing that I want to send the metrics to? Like, what's the thing I want to send this telemetry to? And, out of the box, as you can see, it supports, anything that speaks OpenTelemetry, like Dapr could work with. So, Datadog, Zipkin, again, Prometheus, so on and so forth, right? But now this OpenTelemetry, support is not something that you really think about inside of your application code. It's something that Dapr just kind of deals with it for you. So instead of you having to like wire it up, like Dapr will deal with it. Now, yes, there is OpenTelemetry support in like .NET with like activities and stuff like that, and you could still do that, and that information will still flow through. It doesn't erase it. But if you do nothing, you're gonna get some stuff, and it's pretty cool. So I think that's interesting to see. Here's an example of what it looks like inside of, on the left, I think this is Zipkin. On the right side, this is what it would look like if you're using something like Azure Application Insights, right? You create this cool, I think they call it like an app map, right? So you can see how the information is flowing from one side of another. You can see what folks are actually, where the data is actually going. So let's do this. I want to show you what this looks like. Let's run this application again super quick, only because I want to make sure I generate some, at least a trace or two. What do I need to put here? Email, right? So Phillip at Yahoo. Right, we're gonna go to Yahoo. I want to use this Yahoo address for like fake stuff. Is that a real number? That's a real number. Okay. So what I'm going to do is I'm just going to generate another request really quick. Now I should be able to see my, now that my events are being forwarded to my local machine, I should be able to see some of that information happening on my machine. Okay. Now what I'm going to do is it done? Great, fantastic. Let's pop open the container situation inside of here. And what I want to do is look at the order processor, right? And here you can see here, and this is just, again, my container that's running. Now it's in here and it's listening to Dapr and like, just some different things are happening inside of here, right? Also, you can notice here on the left side, you can see like this is my actual Dapr container that's running. It's actually being able to like send messages to queue and like do all kinds of cool stuff. Okay. All right, and then let me check and make sure this thing is still running. Is it still running? Yes, fantastic. Great. So now if I wanted to kind of see what this looks like, I could open my browser and I have Zipkin running in that container Docker situation. And its port is 4, there we go, 494.11, right? And if I there's no traces in there. Well, usually what happens when things work the way that they're supposed to look, I'll see something like this, right? I'll see like those different instances of my app inside of here running. And now I could be able to say, okay, well, that's really cool. Like that's how Dapr does stuff. Okay, so we talked really quickly about, this is what it looks like in .NET as I run it. And you can saw how I kind of configured things, at least to run inside of Docker Compose. Again, Docker Compose is not required. But where do I actually configure those Dapr components? Like I showed you a YAML example inside of one of the slides earlier. Let's go ahead and take a look at one of the folders I have in here. And inside of my folder, I have a couple of them. So here's an example. I'm using like RabbitMQ to send messages, and it's one of the components that I'm using. And so here's an example of how you can configure a Dapr component, right? And I'll be honest with you, don't tell anybody. I don't really know these things off the top of my head. I usually just go to the GitHub repo, copy it, and then just change the values and get it to work. Right. So if you're wondering about, oh, how am I going to know like all these YAML values that I have to set? Trust me, nobody does, right? Like all we do is like, let's just go to GitHub and we'll figure it out. And then we'll just like update the values that we need to update. So again, so as you can see here, I'm specifying a kind of component. The name of the bus is RabbitBus, right? And that's, in my URL, if you saw the name of the bus that I had in configuration, like that's the name I'm using, right? And then here I'm just saying, okay, well, I want you to go to this instance of RabbitMQ that just happens to be running on my machine, right? And that's also being run inside of that Docker compose file. What would it look like if I wanted to do something different like Redis, right? Like I could do this too, right? Again, all this information is inside of the GitHub files. If you want to know how to configure these, honestly, I just go to GitHub or the documentation, copy, paste it, change the values, and then we're off to the races, right? Like everything's good to go. Now, one of the things that's different here that I want you to notice about this one is that it's using like this thing called a secret ref. Pretty much it's saying, hey, I don't want to write my Redis password inside of this, this file. Instead, I want to go pull that password from somewhere else and then have, my Dapr manifest files, right? Like just kind of populate them for me. And so again, I'm going to use that secret store building block that's a part of Dapr. And notice here, I'm using this one called local secrets, right? Local secrets is just another component, right? It's another building block that I configured. So I'm saying, hey, I want to configure this Redis pub/sub building block or pub/sub component. But in addition to that, I also want to make use of another one, right? I want to make use of the secret store because I don't want to check in my secrets into GitHub and they're all in my YAML files. And everyone's like, what are you doing? Why is all your secrets on GitHub? Like, that's not a good thing to do, right? So this is how you're doing. So now your next question might be, well, how do I configure the secret store now? Glad you asked. So if we head over to this other file that's also in the repository, here I'm using what's called a local secret store. This is only for testing. Do not do it in production. But again, what I could do is like point to a local file, and then I could have it, just use the settings in that file as my personal secrets, right? Usually what folks would do, you'd set up like your git ignore rules or whatever the case is. Make sure this doesn't get checked in. Or even you can even just make sure that it's just not in your, in your folder and make it can be somewhere else on your hard drive. But then now you could use this. And then now when it's time for you to actually start pushing to production, you could just swap it and use something else, right? And that's a totally acceptable thing to do. Okay. And then the last piece of configuration I want to show you, there's a lot of configuration files, I know. This is what like some of the basic tracing configuration looks like. And here, what I'm doing is that I'm sending some data over to Zipkin, right? So here you could see, hey, I can set my sampling rate, I can set my endpoint address, and I can be like, this is where I want you to send that information, right? Like this is where that stuff is going to go. And then you could see how exactly all that works and all that gets wired up. Okay. All right, let's head back over to the slides super quick. All right, so we saw how that works. Now, what are some other things that I could do with Dapr that I think are really cool? So something I didn't show, but something that you can definitely do. Dapr has this concept of API scoping. So right now, again, for every instance of Dapr, there's an instance of your sidecar. And then by default, all of those APIs are just available to you by default. Obviously, some of them may be configured, some of them may not be, right? Because again, Dapr is very like pay for play. If you don't configure a state store, there's no state store. If you don't configure a pub sub, there's no pub sub. But when you call that API endpoint, right, you're still able to call it. You're just not going to get a response back. You're going to get back like an HTTP, failure status code or something of the sort. So with API scoping now, what it does is go a little bit further. Now it says, hey, for these types of applications or these applications that I specified in my configuration file, I want to make you, I want to allow you or deny you to be able to access like these endpoints. So if I want to say, hey, I don't want my app to access state management, but it could do service invocation on pub sub, I could specify that, right? And again, when I say my app, I mean like my instance of my service. So you may have some services that can publish and some that can't. You may have some services that can do service discovery and some that can't. You see what I'm saying? Like you can completely configure and customize how exactly you want a lot of that stuff to work. You could lock it down as much as you want to, which I think is a pretty cool thing to do. The next thing I want you to check out is the fact that we have this thing called CADA. CADA is really cool. Also a CNCF project. I think CNCF stands for Cloud Native Cloud Computing Foundation. And it has this really cool feature that allows you to like auto scale your containers and your deployments if you're using Kubernetes, right? This is not like a Dapr thing, but it works really well with Dapr. So now I could say, hey, I have 100 items in my queue, maybe more than 100, but I have a bunch of stuff in my queue. I'm completely backed up. I need to spin up more instances of my app to be able to come in and process those, then Kata will do that automatically for you. And you could specify that using like config rules and stuff like that. Dapr also has virtual actors, which is really cool. One of the things that folks always ask, like, hey, well, we have Orleans and we have Akka.net, like, and now there's another thing. Here comes another actor framework. Like, why should I use this instead? Well, my only thing that I would say about virtual actors with Dapr is that you think about Orleans, you think about Akka.net, those things are .NET only, right? When you think about building microservices with Dapr, well, I might be working with folks that aren't using .NET. Maybe they're using Python or Java or Go or some other language, right? In that case, Orleans and Akka aren't going to work for them because they don't speak that language, right? So with this, it kind of gives you, with virtual actors in Dapr, it gives you the option to be able to have like an actor-like programming model on top of like whatever language and whatever operating system you're hosting on. So I think that's pretty cool. Okay. Here's some examples of places that you could go to get stuff and learn about Dapr. I know folks want to know where the code is. If you head over to my GitHub at github.com/CecilPhillip-Stripe, I do have a Stripe GitHub account other than my personal one because it's work. That's what we do. But definitely make sure you head over there and check out the sample. It is in the Dapr branch of the repo because I have a bad habit of putting multiple things in the same repo. And so I have these different branches with like different versions of the same application. And actually, I think I'll pop that over there and show y'all what it looks like really quick. So if you come over to the repo, and then you can make sure that you check out, like, there's different branches. There's a Dapr branch, which is the one that you're probably more interested to, and I have some other ones in there that, you don't probably need to worry about. But yeah, definitely head over there and check it out. Let me know what you think of the demo. Let me know if y'all have any questions. I'm going to pause for a minute. And, hopefully y'all had a good time and learned some cool stuff about Dapr. Don't steal from animals. What does that mean?
I'm not muted.
This was a really good demo, really good show, actually. In 1 hour, you showed us a lot of things. Speaking of which, you did show us your credit card number. We do have a follow-up question on that from the audience, but also personal interest.
Sure.
What is your mother's maiden name and the name of your first pet?
The name of my first pet is Leonardo, and my mother's name, oh my God, I should know my mother's maiden name. After the other stream, I'll tell you. All right, so let's talk about that credit card. That credit card that was there is a test card. Folks always wonder why it's 4242. There's supposed to be like some Monty Python story behind of why it's 4242. I don't remember exactly why that's the case. But for lots of folks, I think if you use, PayPal and Stripe and whoever, Braintree, you type in 4242, like that is everyone's like, everything is okay test credit card. So you could try that out and, and see. But also if you charge it and, you get to buy some cool stuff on Amazon, then, I take donations as well. So that's
I said I need a Lambo. So I'm hoping.
What's the limit on that card?
I mean, let's try it out and see, man.
So we did have a lot of questions actually. And, I guess one of the things, like you showed that list of just all the components in the ecosystem. When you're starting to build your Dapr application, like how do you choose from that menu? It's like being at a restaurant and just having like FOMO, I think, for me.
So I'll tell you, I'll answer it this way. Like when I was building stuff in Azure Service Bus, one of the things that I always wished I could do was build offline. You can't do offline Azure Service Bus today. And for a lot of cloud services, there's no like offline experience for them. And so when I think about it, I think, hey, my company has, I'm going to assume someone in your company is like already provisioned infrastructure, right? Someone, maybe it's the developers, but someone's responsible for that. And so as your company has decided to use things, you can be like, okay, hey, this is what we're going to use, but like, you know what? I really don't want to like pull in NuGet packages, and I don't want to, I don't want to have a Redis SDK and a this SDK and a that SDK. Particularly when you think about things like message buses. Some people use multiple message buses. That's a thing. Like real, companies do that. People have multiple databases. That's a real thing. People do that, right? I don't want to have like all of these SDKs to support all of those things if I don't need to, right? And then I think that also kind of goes into the conversation of, well, do I need to use Dapr or not, right?
Mhm.
Because it's also okay for you to use those SDKs. That's fine if there is an implementation specific feature that you want to use that Dapr doesn't provide. I'll give you another example. Azure Service Bus. I worked in Azure, so I'm going to say Azure a lot. I apologize.
Yeah, go for it.
Azure Service Bus supports delayed messaging, right? Like I can schedule a message to be delivered at some point in the future. Dapr doesn't support that today, right? But that might be something that you need to leverage. So if you know like this is what you're using for your infrastructure, your company is using, then maybe you should just rely on that SDK, but then you could use Dapr for the other things. Because again, the thing with Dapr is that like you don't have to use all the pieces. You could just use the piece that you want, and then the rest of it you could just kind of ignore the fact that they're there. You could turn them off, or you could use API scoping and deny them to the process or whatever the case is.
Yeah, Martin actually has a really good follow-up question. I saw him type it.
Yeah, exactly.
Go ahead, Martin.
Because you're talking about SDKs and so on, but you also mentioned that it's only a thin wrapper essentially around all of the APIs and services that Dapr provides out of the box. Is there any benefit to using the SDK or working yourself against the APIs directly?
You mean like the Dapr client SDKs? Is that what you mean?
Yeah, exactly.
I mean, so particularly for ASP.NET folks, like it does provide like some easier ways to configure Dapr. Like you don't have to work as hard. So as an example, like how do I specify what topic am I subscribing to, right? Generally what you do in Dapr is you'd have to generate like this JSON object and send it over. Whereas if you use the SDK, you could just put some attributes over your method and it'll just kind of figure it out for you, right? And so instead of you having two methods, like one method to subscribe and one method to actually process the queue, I could just have one method with an attribute. And then again, like Dapr will just kind of figure it out. So I think it really just kind of depends on how you like to do things. I personally like to show Dapr like as itself raw without SDKs, because for me, like the whole benefit is the fact that I'm using this thing. I don't have any SDKs, right? Like so, for me that's the whole point, right? I don't want a Mongo SDK. I don't want a Rabbit SDK. I don't want a what's that thing called? Google Pub Sub. I don't want anything. I just want to talk HTTP and have stuff work. And so I like to show it like without the SDKs.
Yeah, I think too for your demo, it's really good to kind of like show that it's not really magic. It's just calling a bunch of endpoints. So
yeah,
that's really cool.
I have another question related to just the calling endpoints. I was wondering, like if you use the client SDK, that's perfectly fine because that's just one SDK, right? But I was wondering how much of a lock-in is using Dapr. Like say somewhere in the next couple of years, people stop maintaining Dapr and you want to move out. Is it replacing all of the SDKs, or can you essentially just, if you write the communication between services well, it's essentially just a matter of changing URLs internally?
Yeah, so I think a couple of things I'd say. So Dapr is a CNCF project, and I know that what that means, and it's also a graduated project too. It's not like a sandbox or an incubation. And so what that means is that like if something happens, you know what I mean, like the foundation is responsible for like ensuring like the longevity of it, at least for like a certain period of time until someone takes care of it. So I think from that perspective, there's a little bit of ease in terms of like, okay, this is not going to like disappear tomorrow. This isn't someone's like side project that they're working on the weekends. I'm like, oh, hey, I went on vacation. I can't respond to your issues. My bad. You know what I mean? Like it's not that type of thing that's happening. Yeah, and I would also say like in terms of actually calling the SDKs and the lock-in, again, like it's using HTTP client, at least for .NET, right? And so from that perspective, just write an API and point to something else, right? Like wherever your thing is, it's not like, again, we're not using any non-standard protocols or message formats or anything of the sort. Like it's HTTP and JSON, or it's protobuf and gRPC. Again, like if you can change the name of your client to like not Dapr anymore and point to like a different endpoint, and that's totally fine.
Yep.
Yeah, I mean, a good follow-up question that just kind of to stay on topic. Somebody asked like, what's the interop story between when you upgrade from one version of Dapr to the next, especially since communication's happening through that sidecar model? Like, Can you just expect things to work if you're mixing and matching different sidecar versions? Are there caveats there?
Yeah, I mean, I would definitely say as that happens to definitely pay attention to the release notes as releases come out. Like, so this is Dapr's 3rd year. I think their version 1.9 just came out like 2-3 weeks ago, give or take. I've only had one instance where something stopped working. And that was only because like they changed the structure of the payload. And then I was like, okay, I'm missing, like I had it to like add in an extra property, but like everything else was fine, right? They didn't rename anything, you know, they didn't remove APIs, they didn't change the API format, but like, you know, they just added like an extra property that I was missing. So that's the only time that that's happened to me in the last 3 years. Yeah, I would say just, you know, definitely pay attention to the formats. I haven't had an issue outside of that with like rolling forward. If you look at the payload, if anyone, you know, decides to play around with Dapr and actually look at the payload, there's really not a lot changing here. A lot of the times it's just your data, right? So if you change your stuff, like it's going to change. You know, I did mention the cloud event stuff. The cloud event stuff is optional. It's on by default, but you could turn it off. So again, if you turn it off, what will happen is, again, you won't get like that envelope, and you'll just get like that raw payload, whatever you send over, XML. Do people still send XML? XML, JSON, whatever it is that you want to send over, right? Like you're just gonna get your raw data, right?
Yeah,
and it's yours. So you know, obviously, you know,
I want to clip you saying, do people still send XML? Like,
See, maybe they do. I'm not shaming anybody. If you use XML, it's fine. Everything is okay. As the fire burns behind our heads.
I mean, at the same time, we're also all using YAML. And speaking of which, there's a lot of YAML involved in Dapr, I think.
There is a lot of YAML. And so the reason that is because it follows like this microservice culture that we have now of being declarative, right, versus programmatic. And so the way that things are specified is like using YAML files that could be versions and source control and all these types of things versus, I mean, obviously you could do that with code too, but then now it's that concept of like, what do you call it? Like immutable infrastructure or whatever it is that they say, where, hey, I'm going to apply these changes. And then now the framework is going to do the diffing for me and figure it out. And then now I'm going to get like my desired state, right? Like this is what the world for me should look like. And again, you see it a lot in the Kubernetes world, and Kubernetes is probably like the most popular deployment target for Dapr. There's Azure Container Apps, which is a thing now too. People can use HashiCorp Nomad as well. I don't think there's any direct support for it, but again, like you're just running a process. It's more so about like writing the right HCL, HashiCorp configuration language specification to put it to where you want it to go. But yeah, no, I wouldn't worry so much so about like the YAML, because I feel like YAML is just, I feel like we're just stuck with it. Like it's not going to go anywhere. So,
so is there like JSON schemas or YAML validation things that could help you write all that YAML, or?
I don't think that there's any YAML validation, and that would be good to have.
Yeah.
Because I remember I was looking for it as I was building that demo, and I'm just like, why isn't this thing working? Like, oh, I missed the property.
I forget if YAML is valid JSON. I think that's the right.
I think
way.
JSON is valid YAML. That's the thing.
Oh man, maybe we should ask the chat and figure it out.
Yeah,
we're professionals, people.
Yeah, like I said, I just go to the GitHub repo and I copy paste the spec, and then I just change the values, right? Because again, like when you think about like those YAML configuration files, it's like things that you write once and you forget about it, unless you need to write like another one, right? But like they're not places inside of your code that are going to churn a lot. You know? Again, unless you're in the habit of changing your databases and your infrastructure a lot, maybe that's a thing. But like other than that, you write it once, you push it somewhere. A lot of customers usually would put it in like some central place, I don't know, a shared network drive or whatever the case is. So now all the developers just point their instance at that, right? And they pull their configuration from that. Because you might be using Dapr, but it's using your local instance of Mongo, your local instance of Redis, and that's on whatever port and IP on your internal infrastructure. So instead of everyone having copies of that, like I could just point at that shared drive and we all use it. But again, from a developer perspective, like I don't want to have to be like iterating on that too often, right? Like it should just be a thing that's there, and then now I can just focus on like doing the rest of my code.
Yeah, it kind of brings up like another thought I was having. Like, how do you recommend managing a Dapr solution? Because you're going to have multiple services, you're going to have multiple dependencies. Do you recommend a mono repo approach? Do you recommend repo per service? Like, how have you seen people building their Dapr applications?
I mean, I've seen it all, right? I think it really just depends. I'm sorry.
You've seen it all.
It just kind of depends, right? Because so like now this is a higher conversation about like how you architect microservices, right? Like this has nothing to do with Dapr per se. And this is just more so around like what makes the most sense for your company. Me personally, I'm not a fan of mono repos. I know a lot of folks that love that stuff. I don't like it because it's confusing. And high risk for conflicts and stuff like that. But you know, some folks do that, or a lot of folks, they would, you know, I know a lot of companies that have these automation scripts that would check out and, you know, move folders around and do the builds, and you know, you can kind of rely on your CI/CD to kind of do some of that stuff for you. But yeah, that's one of those things where it kind of just depends on the company, to be honest with you.
Yeah, it's tough. It's like it's hard to know what people's contexts are, so it's hard to make a recommendation without having a clear picture of like what people are trying to solve, right? So
Yeah.
I definitely understand where you're coming from there. But yeah, I think that's most of the questions. Martin, any other interesting questions? Or
I think there was one more, and given you come from Azure, maybe that's a good one to end with. Should I move from Azure Functions or cloud-specific functions to using Dapr?
That's a good question. So look at it. So this also has nothing to do with Dapr per se, and this is more so how do I want to build like my microservice application, right? Like, so when you think about serverless things and Azure Functions, you think about, hey, I'm not touching the infrastructure. I'm just writing code and sending it over the fence, and someone else is going to deal with it, right? Like that's how we generally think about serverless things. Versus if you're going to use something like Dapr, or Kubernetes or Docker or anything that's running containers in that sense, like you're controlling where the process is. Like you have to put it somewhere. You have to deploy it and spin it up and do your network configuration and updates and et cetera, et cetera, et cetera, et cetera, right? Now, if the capabilities that your application requires are not something that you can do in a serverless way, and there might be reasons for that, like you want to access the disk. I don't know why you want to do that, but maybe that's the thing, right? You want to access the disk, or you want to get like certain some certain insights about the operating system or the environment that it's running on. Maybe that's something that's important to you. Maybe you want to just run ad hoc executables and those types of things. Like serverless is not really meant for those types of applications, in my opinion. Someone else might tell you different. I'm going to tell you don't do it, right? But versus when you have something like, I don't know, I'm just running Dapr and running containers is like I'm just running an app on my machine, right? Like I control everything. I control the space that it runs in. I control the programming language and the version of the programming language. I can control where it's deployed at, the IP address, the port it runs on. Like I control everything. So now it's a case of how much control do you need or not need, and how much flexibility do you need or not need. And then based on that, you can kind of make a decision about whatever's going to be the best choice for whatever you're going to do.
Yeah, very, very good advice. I guess we ended on the perfect consulting answer, which is it depends.
We should call this entire conference "It Depends."
If you're a professional and you don't say "it depends" 100 times a day, are you really a professional?
And I don't trust you. You know.
That was a great talk. Thank you so much. We've seen people say, I'm definitely going to give Dapr a try now on social media. So you definitely convinced some people to check it out.
Yeah, if folks are interested, feel free to, again, join the Discord. I hang out in there in the .NET channel randomly, or message me on Twitter. And, again, make sure you go ahead and check out the demo. And yeah, let me know what you think.
Yeah. Thank you so much. We'd always love to have you back. And
absolutely.
Thank you. And have a great day, Cecil.
All right, folks. Take care, everybody.
Bye.
Later. Bye. That was a cool talk.
All right.
Martin. Yeah.
That was a really good talk and a good topic as well.
Yeah. there was a lot of kind of interesting questions that kind of came out of that talk. I'm still wondering, like, it kind of brings those questions up of like, how do I start building an app and like picking the right pieces? I also think there's like there's a potential for analysis paralysis. So I think Cecil did a really great job kind of breaking down.
Exactly. And I think it's also the typical thing where you would just start building to get something working and then build experience, build confidence, and then refactor going forwards to what you think makes sense after you learn what you actually want to build and how you want to build it.
Yeah, I think you used the perfect word, which is like refactor. I think looking at the YAML, it's neat to know that like you can make one decision and then change your infrastructure decisions later on, and just it still all kind of like gels and works together, which is really cool. But speaking of infrastructure and refactoring things, perfect segue. Yes, this is being recorded. I just saw chat say that. So we're going to bring in our next speaker, Daniel. Great speaker. Seen him speak before. So I'm excited about this. Let's bring him in.
Hey.
Daniel.
Hey. Good to see you all. Yeah.
Grüezi, or what is it in Swiss German?
Grüezi. Yeah, exactly.
Grüezi. Right. It's turned into a language conference now. A real natural language conference. But yeah, we've heard a lot of great things about this talk. We know you do this talk. You've done this talk at previous conferences, so I'm sure Rachel has seen it before. She likes watching.
She's seen every talk before.
Yeah. So, but
no pressure, I guess.
But if you're ready, we can kind of give you the stage, and we can get started, and then Martin and I can get out of here. But we'll be here if you need us. So the stage is yours.
Okay. Cool. Nice. Hello, everyone. A warm welcome from my side. My name is Daniel Marbach, and I'm going to talk about performance tricks that I learned from contributing to the open source .NET packages, primarily Azure Service Bus SDK. So it's kind of funny and sometimes also very annoying for me, because I consider myself a practical learner, and I've invented that term. I'm not sure if that really exists, but as a practical learner, I kind of have to go through the pain of essentially doing something multiple times and failing at it, so that I can really, really embrace the conceptual things. Because I've done it plenty of times. For example, I read a book, I don't know, for example, about performance optimization, architecture, design, whatever, and I'm like, yeah, I kind of got it figured out. And then I sit in front of the code and I'm like, okay, how does this work again? I start fiddling around and I start experimenting, and then I make tons of assumptions. And then I try to figure out, are these assumptions correct? And try to course correct. And then I really, truly learn something. And of course, talking about it also helps. So that's why I have also prepared this talk, because I think I have done a lot of Azure Service Bus SDK contributions in the past. And I'm now around more than 70 pull requests against the Azure Service Bus SDK. And why have I done that? Well, I have done these contributions exactly to essentially find a place where I can apply the things that I'm learning in my free time and actually do them and roll them out to production. And luckily, the Azure Service Bus SDK team, they're very kind people, and they accepted some of my pull requests, and some pull requests have not been accepted. I mean, that's part of the game, right? Because not every change that I made was correct, or not every change was actually worth pulling in. But while doing so, I have learned a few things about performance optimizations in .NET. And this talk is exactly about that. And I condensed the best practices that I extracted from this. I condensed it into a talk. And in this talk, I'm going to give away some of these best practices so that hopefully you can benefit and fast track the learning experience that I've went through pain and suffering and a lot of sweat. Okay, first of all, I need to get some details straight. So this talk is really about performance optimization that you can do in your .NET code. The samples will be primarily based on C#. A lot of these things you can also do in F# or other .NET-based languages. But I use C# day to day, and that's the things that I'm going to show. So, and this talk is not about things like horizontal and vertical scaling, because you can achieve a lot of like throughput and whatever by just basically going and saying, well, I'm going to horizontally or vertically scale my code, right? And there are a lot of best practices that you can apply to do that, but I'm not going to talk about it today. So this is purely focused on .NET code. It's also not going to be about tools like benchmark.net or memory and tracing profilers, because that would be a whole other talk for tonight. And then sometimes people ask me, so why do you talk about .NET when it comes to performance and C#? Why use a managed language? Shouldn't you just be using C and C++ to actually achieve high-performing code? Well, I strongly believe that over time, the .NET runtime, as well as the languages on the .NET runtime, have evolved to be a very modern and high-performance platform. And as a matter of fact, the .NET team itself, they're like constantly porting some of the unmanaged code into the managed land where it makes sense. And so, for example, recently, maybe you have heard about it, they actually brought the thread pool into managed land. So there was still unmanaged code in there. And now parts of the thread pool, I think it's all of the thread pool is now in managed land. And the good thing is the performance is better, or at least not worse, right? And then if you have more maintainable code, you have a code base that has a single a language that you can use and understand. I think that's always a good thing, and especially if you can combine it with performance. Good. And then when I do performance optimizations in my day-to-day work, I sometimes hear from my peers when I work at particular software, I say, wow, that's crazy. Is the complexity really worth it of that change? Isn't that just premature optimization? And I must say, some of the optimizations that I'm going to show tonight, they can be called out as esoteric. And what I want to hammer home in this talk as well is you should not like blindly jump to conclusions and apply them everywhere. The most important part is these optimizations, they make sense in certain type of context. And in certain types of contexts, they do not make any sense. And you would be wasting your time, your employer's time, and also your customer's time if you would be applying those types of optimizations. And I really want to get this straight. Don't just apply this everywhere. So the important part is you have to think about, is the code that I'm going to look at, is it executed at scale? And code that is executed at scale, then it really matters whether the code is more efficient in resource usage, execution time, throughput, and memory usage. And I must say, some of these are performance optimizations that I'm going to show you. And when you're going to apply them as well, they can be highly addictive, right? Because you're like, I see stuff and I want to change it and I want to make it faster. But it's really important that nobody wants to optimize code that is fast enough or only executed once a day, right? But we wouldn't want to do that. But then the question is, what does scale even mean? And how can I find out whether my optimizations that I'm trying to do actually have value and I'm not getting called by my colleagues for premature optimizations? Well, I have this quote from David Fowler. You probably have heard of him. He's a well-known figure in the .NET space. If you haven't, then you should really follow David Fowler on Twitter. He has some great content out there. And it's from a talk that he did, and the talk title is At Scale Implementation Details Matter. And scale for an application can mean the number of users that will concurrently connect to the application at any given time, the amount of input to process, or the number of times data needs to be processed. And for me, the last sentence is actually the most important one. For us as engineers, it means we have to know what to ignore and knowing what to pay close attention to. Well, okay, pay close attention to, what does that mean? I always say it to my peers, and when I review code, even open source, people that have written the code, they were smart, and we always expect, or at least I always expect the people that they have made trade-offs, right? And we have to think about what assumptions have people made when they actually wrote the code, and how have they accumulated over time? And then we need to pay close attention to what is instantiated, parsed, and processed per request, right? And then we also need to think about how those assumptions that have been made over time, how do they affect the performance characteristics, mainly the memory and the throughput of this piece of code that we're looking at when the code is executed at scale, right? And once we understand those assumptions and we know in which direction this code will go in terms of scale, so will this be executed just once a day? Will it be executed hundreds of thousands of times a second? Or maybe it's not yet executed hundreds of times a second, but we know that the system is going to scale and we want to basically start working on making that piece of code faster, right? So again, and I'm going to repeat this several times throughout the talk because it's such an important message, when the piece of code will be executed or is executed at scale, then some of these performance optimizations do matter. So as a developer and also as an engineer, I usually like to have conceptual rules that I can apply, because when I have simple and conceptual rules that I can use, then I can actually memorize them and I can apply them throughout my daily work so that I do not fall into the pitfalls of making code slower. And I have summarized some of these rules. And I know I'm the last person of the JetBrains Day online, and you probably are already tired from watching a lot of great presentations. And that's why I'm going to make it very simple for you. So the first two basic rules that you have to remember is avoid excessive allocations to reduce the GC overhead. And the second one is avoid unnecessary copying of memory. So if you stick to those two rules, then you're fine, right? Or at least most of the time, or in many, many cases, you're actually fine. And now you can fall asleep, or now maybe it's also a great time to just take a sip of your coffee or favorite beverage, because we're going to increase the speed and we're also going to go into the nitty-gritty details of some of the performance optimizations. And let me start first with the first rule under the avoid excessive allocations to reduce the GC overhead. And the first one is think at least twice before using link or unnecessary enumerations on the hot path. So link is great, and I really wouldn't want to miss it at all. Yet on the hot path or in the code that is executed at scale, it's far too easy to get into troubles with link because it has a lot of hidden allocations and it's very difficult to JIT optimize. And the JIT is the just-in-time compiler, by the way. So let's have a look at a piece of code from the Azure Service Bus SDK. And that piece of code is called the AMQP receiver. And for those who haven't heard about the term AMQP, AMQP is basically a protocol. And it is the mechanics or the driver behind event hubs or Azure Service Bus. And this AMQP receiver is basically the mechanics that make sure that when stuff comes from event hubs or stuff comes from Azure Service Bus, we can then receive messages, we can complete messages, we can push events, and that's all done over the AMQP protocol, and the AMQP receiver is such a driver. And in there is this very simplified piece of code, and what this code actually does, it takes a series of lock tokens, and lock tokens are basically glorified GUIDs. And lock tokens represent the message. So whenever you complete the message, you basically go and say, hey, by the way, I just handled this message, and here is this GUID, please complete it. And then, for example, Azure Service Bus will remove it from the service because you have successfully handled it. Let's zoom in a little bit. So the Azure Service Bus SDK has coding guidelines, and those coding guidelines say, whenever you take from the outside world something that is a sort of a collection type, you need to use the broadest possible type according to these SDK guidelines, and that's IEnumerable. So we're getting here these IEnumerable strings, and again, these are basically GUIDs. And then what the code does, it essentially does select and project those into GUIDs, then calls toArray. And then the next thing, it does some an any call. And in that any call, it basically looks whether it in a concurrent back, whether it already has seen this GUID or not. And then if it has seen this GUID, it goes on one code path. And if it hasn't seen, it goes on the other code path. So if we decompile this code, then we get this gibberish type of code. And I know it's potentially already a little bit overwhelming. So I'm going to zoom in and I'm going to highlight the most important aspects of this piece of code. So what we do here, see when we decompile this code is we have this thing here, this c dot some gibberish stuff 9__2_0 and some null checking and whatnot. And what this basically means is this is the safe zone. And when we look at this, it does check whether field is already assigned, and if it's not assigned, it then creates a function delegate, and then it assigns it, and from that point in time, everything is safe because that function delegate is statically cached, and we don't need to worry about it. So conceptually, when you see this pattern here that I just showed, then we are in the safe land for simplicity reasons. And then the next thing that we see here, we see new func of GUID of bool. So what that means is if this code is executed at scale, and this is actually executed at scale, so if you're using event hubs or Rash service bus and you're processing hundreds and thousands of messages through those services, the messages have to be completed, and then this code is executed. So that means every time this new function GUID bool is actually instantiated. So, and it's an unnecessary allocation. So how can we essentially change this code? Well, it's pretty simple. We can simply get rid of the any, and I've done this here by essentially looping through the I enumerable of string, and then we just check whether with an if statement, with a very simple if statement, we check whether it's already is contained in the concurrent back, and if it is contained, then we go on one path, and if it's not, we go on the other code path. So that's it, right? We have achieved to get rid of one link statement in this piece of code, and that was the any. So let's see how we do. Well, if we decompile this, again, with our favorite decompiling tool, and hopefully it's one of the JetBrains tools, then we can see if we zoom in that we have now this safe pattern that I've previously explained, right? We are going to check here whether the static field is already assigned, and if it's not, then we create one time the function, we associate it, and then from that point in time, it's gonna be cached. Cool. But now the question is, did we actually achieve something? And this question is important because it forces us to actually truly think, well, we can't just assume it's going to be better. We have to actually measure whether it's better. Otherwise, it's not even worth to make these type of changes. And let's have a look. And I used benchmark.net to actually measure whether things are properly working. And I've shown you here the result, and I know it's a lot of numbers. Don't worry about it. I'm going to summarize it for you. You don't have to look through this whole table. And by the way, whenever I'm showing benchmarks, you don't have to look through this whole table. I'm going to summarize it. And the first line is, as we can see, is we have 20 to 40% more throughput. That's the first line. And the second line, where we have this trash can icon, we have 20 to 40% garbage collection reduction, Gen 0 garbage reduction. So that's super cool. So just by getting rid of the link any, we actually have achieved quite tremendous achievements, right? We have been able to essentially boost the throughput of this piece of code by 20 to 40%, and we have been able to reduce the GC overhead by 20 to 40%. Okay, so can we go further? Well, those of you who have actually sipped their coffee and are still awake and energized, they actually have seen that we still have some link queue there. Can we get rid of all the link queue in this piece of code? And what rules should we follow in order to do that? Well, I have summarized, based on my experience, some of the rules that I follow whenever I do this, what I call link to collection-based operations refactoring. So the first rule is whenever you need to represent empty arrays, you should be using array.empty, because that gives you a statically cached empty array. So don't do new array, because then you're going to have allocations. And with this one, you're saving these allocations. The next one is pretty similar. When you need to represent empty enumerables, then use enumerable.empty to represent those. Then this one gets forgotten quite a lot, but collections, they come with a pre-allocated capacity. And that's internally, collections have sort of buckets, right? And it has a pre-allocated set of buckets. And when you start reaching essentially the capacity of the collection, what's going to happen, the collection needs to grow when you add more stuff. And growing is an expensive operation because it needs to allocate more memory, and then it needs to copy around stuff and make that the most efficient. But still, once you start adding and it needs to grow, essentially the add call will essentially stall for a period of time. And there is a lot of also Gen 0 garbage that needs to be created as well, that also needs to be collected at some point again. So whenever you can, and you know how many stuff you're going to add to the collections, you should make sure that you initialize the collection with the number of items that you're going to put in, so that you avoid collections from growing. Then this one is sometimes a little bit counterintuitive, especially because I've seen many teams that are saying, well, let's just use I-read-only collection and I-enumerable everywhere and whatnot. But for performance critical code that is executed at scale, it's actually much better to use the concrete collection types. Because when you use the concrete collection type, what is going to happen is when you enumerate through it, you're actually getting the enumerator that is a value type. And when you look through the lenses of the I-enumerable or I-read-only collection at the collection, then essentially that enumerator is going to get boxed. And then again, we have unnecessary allocations. And by the way, some of these scenarios, they're getting optimized more and more throughout the improvements in the .NET runtime. But still, I still consider it a good practice to use the concrete collection type where you can, to avoid these types of problems. And then when you want to figure out how many items that you need to add into collection, you're getting a collection in, then it's kind of neat to, for example, leverage pattern matching, or when you are running on .NET 6, you can use enumerable try get non-enumerated count to essentially get the count of the collection without enumerating it. Well, why is that important? If you're just using link.count, what's going to happen is it actually needs to, in many cases, it actually needs to go through the whole collection. So you're paying the price of going through it all. And when you can do pattern matching, and I'm going to show an example later, then you don't have to do that. Or again, if you're using newer .NET versions, you can just use enumerable.tryget non-enumerated count. And then this makes the code a little bit more complex, but you should wait with instantiating collections until you really need them. And well, what it means is really, in some cases, you basically first figure out, you do your conditional check until you really know, now I really need my collection. And then you create a new collection, and then you add stuff to it. Because otherwise, you will be creating collections for no added value. And these are, again, allocations that are not necessary. Cool. Now we have these rules in place in our toolbox. We can have another look at the code that we previously looked at. And again, I've said it, we haven't gotten rid of the select statement, right? We only got rid of the any statement. So let's have a quick look. Again, it does a select, it projects into new GUID, and then it does a to array. So let's take all those rules and let's try to get rid of this select statement. So here is what the code looks like. And by the way, I'm using here pattern matching because the Azure SDK is running on Net Standard 2.0 or supports Net Standard 2.0 and doesn't have a way to essentially conditionally use .NET 6 feature like enumerable try non-enumerated count. So I had to use pattern matching there. But the first thing what we do is, well, we have to understand how is this piece of code going to get used. And based on usage data, telemetry, and also interactions with the customers, the team told me, well, most of the time customers are going to pass in an already materialized list, array, whatever. So we are not in the cases of lazy enumerated values. And we can leverage that. We can say, well, let's do a quick pattern check whether this enumerable is actually of type I-read-only collection of string. And if that's the case, we just take it and forward it. And if it's not, then we're probably in the case where we're getting lazy enumerated enumerables, and then we need to eagerly materialize it. And then once we have done this, we can then pass in the I-read-only collection of string into that method. And you might be thinking, Daniel, you told me to drink a coffee, and I'm wide awake here. And you just told me I should always be using the concrete collection types. And now you're showing me an example that doesn't use the concrete collection type. I mean, what happened here? Well, actually, it's all about trade-offs. And again, the context of the code is necessary to take into account. And as I told you at the beginning, the Azure SDK guidelines, they say you should always accept the broadest possible collection type, which is IEnumerable of string, right? And that means the only thing we can do is we can leverage this information and we can try to go to the most common thing that we have in place, and that's IRead-only collection of string. So yes, we will have potentially boxing of the enumerator, but that's a trade-off that we have to make because we cannot just force customers or break the API and force customers to pass in concrete collection types. That's not an option that we had at that time. So we're making the trade-off. And then what we do is, again, because now we have the count, we can actually go and we can check whether the count is 0. And if the count is 0, we use array.empty. So we have a statically cached array, or we instantiate an array with the specific count. This here is for arrays, it's not potentially not that important, but it's even more important for lists and other collection types, because again, we want to, if we would be using here a list, we want to create a new list with the count, and then it already has the necessary buckets available so that it never has to grow its capacity. And then we just have a for loop, and what we do is we essentially add the token GUID to this read-only collection using the indexer, and that's already it. So let's have a look, because again, when we're applying these rules, we want to know whether we actually are doing great, right? And let's have a quick look. We run a benchmark, and again, I did run a benchmark against a lot of possible collection types, and I'm running the benchmark comparing the already slightly optimized version where we got rid of the any keyword versus the fully esoteric, crazy, Daniel refactored collection type, getting rid of link everything version, right? So let's have a look. So wow, we actually got 5 to 64% throughput improvement on top of the already optimized code, as a reminder. And we got another 23 to 61% garbage collection reduction. Wow, so we have less Gen 0 garbage as well. But let's have a very close look at the data. So actually, if we're honest about this, we have cases where we're actually doing worse. We're doing up to 56% worse than the original version. Sorry, sorry, I have to be clear. 50% worse than the already optimized version where we just got rid of the any. Well, why is that? Well, in the cases where we're getting a lazy enumeration, we're doing much worse because we need to array, and then the code gets slower, and it's also more, it's also potentially a little bit more allocation heavy. So we're not doing that great in this specific scenario. So is that an indication we shouldn't be doing such a refactoring? Well, it depends, right? Because again, the context is the key here, because we know that many customers, or most of the cases, we are getting actually an already materialized collection in. And then we can say, yes, it's actually worth doing that refactoring, because we will never be in the scenario, or almost never be in the scenario, where we are actually getting hurt by the slower throughput. We might be in those scenarios for unit testing stuff or so, but that's totally fine. And otherwise, if you're saying, well, we actually don't know, or we cannot make these assumptions because we just don't have telemetry or information available, then I would advise you to always favor readability. And readability should be the key driver, and also knowledge of your team, instead of gold plating everything and trying to squeeze out the last link use statement in your code, right? If you are familiar with link and you know it's not a hot path, then please use link, because it's a great feature of C#.net, right? And who wouldn't want to miss it? And of course, then also there are potentially likely other areas in your code that make things slower, that slow things down even more. And then again, go and use your favorite memory and performance profiler, for example, out of the JetBrains toolbox, and get a better understanding of the code that is executed at scale. And like with all the things, especially in software development, it's crucial to know when to stop on a given code path and find other areas that are more impactful to optimize. Again, so maybe In your scenarios, you might be saying, I'm totally fine with just removing the any, because that's a low-cost optimization we can do. Everything else, we're not doing it because it's not worth doing it. Cool. Now, the next one is be aware of closure allocations. I've already hinted a little bit at closure allocations when I looked at the link performance investigations, but closures can actually occur anywhere where we have lambdas. So for me, lambdas are action or function delegates or custom delegates in your code. And when they're invoked and they have access to state from outside of the lambda, what does that even mean? I'm going to look into this a little bit more with some specific examples that hopefully make this clear. So in the Azure SDK, there is sort of this circuit breaker, poly, retry capability built in. And that's necessary, for example, because you can lose the connection to Event Hubs or Azure Service Bus as an example. And this method that I'm showing here is called run operation. And what it does, it essentially returns a task, because the majority of the code in there is going to be executed in an IO-bound fashion. So we're going to do MQP calls, HTTP calls, whatever, right? So that's IO-bound. And then we have a function delegate that gets passed in where we get the time span and it returns a task. And that's the actual operation that we're going to execute. And then we have sort of a while loop surrounding it. And that while loop essentially executes that operation. And when it was successful, we return. And when it was not successful, for example, when we got the server busy or we got some type of back pressure, we then just do a sleep or a task delay. And then we try again until a predefined timeout. So that's that poly retry capability that is custom built into the Azure SDK, especially the Azure Service Bus stuff. And let's have a look how this is going to be used. So here I have an example where we call in this retry policy run operation, we are calling the create message batch internal. And as you can see here, we have a local called message batch. And then in here, essentially, when we're calling the actual method, so that's the operation, and then we assign it to the message batch. And that is the closure, because the message batch is outside these curly braces here that we have on line 3 and line 6. So we're going to have a closure allocation here, because we're accessing the state that is outside. And by the way, probably it's not really visible. I'm going to step back a little bit. Layla, one of the two Laylas, she's going to speak tomorrow about debugging distributed systems. She made this t-shirt for me, and it says, I see closure allocations. And this is exactly the thing that triggers me the most when I see these closure allocations. That's why I probably have this t-shirt. And we're going to talk a little bit more about this. So how can we get, or why is that a problem? So let me show you. When we decompile this code, what we can see here is we have a display class allocation on this line here. And then what we also have here is we have a function delegate allocation. So essentially, in order to invoke this code that is executed in this retry policy, we need 2 additional allocations for no added value. So can we get rid of it? And yes, we can, because we want to make sure that we don't have these closure allocations anymore. So what we can do is we need to write some sort of a library tool, infrastructure tool available, and that is the new version of it. So first of all, because some of the SDK code started returning value tasks, we want to make sure that we also use value task. For those who haven't heard about value task, that's basically a discriminated union out of a result that is synchronously available or an IO-bound operation that is going to be executed. When is it valuable? Well, some people will argue you should always be using value task. I don't know. I see it mostly valuable when, for example, you have stuff where you, let's say, 8, 9 out of 10 cases, you're going to do a cache hit where you get the value. And then in 2 out of 10 cases, you're going to fetch, for example, to your database, get the value. That's the IO-bound operation. Then value task is very helpful. But of course, your mileage may vary, and you might also have other opinions about this. Feel free to use value task everywhere. I just want to say that I use it differently. Cool. Then what we do is we have a function delegate where we pass in the state, time span, and the cancellation token, and we return valid task of T result. So why T1? Well, first of all, whenever we pass state, whenever we execute a Lambda, we want to make sure that all the state is available inside the Lambda. So that means we need to pass all the state from outside into the Lambda so that we can execute it. And we don't want to use object, because if we use object, when we pass in an integer long or another value type, it will get boxed, and then we have, again, allocations that we don't want to have. So we need to give in the state from the outside, and we need to pass it into the Lambda. So that's what we define. And then we just simply execute the operation, pass in the state that we got from the outside, pass in all the parameters so that the Lambda can be executed. And then, because we have a value task returning operation that is also value task of T result, we can build sort of functional style on top of it, methods that do not return anything by essentially returning null or default of object. And since we have this utility already in place, we can now create a new run operation method for void returning actions, where we return a value task. Again, we get T1 in, and then we execute the operation. Sorry, we declare the operation, a function of T1, time span, cancellation token, and the value task, and pass in the state. And then we can leverage C#9 has introduced the possibility of doing static lambdas. And you can mark a lambda as static, and that means the compiler is going to enforce that you cannot reach outside the lambda and get some state that will actually closure allocate. And then the next thing that we can do is, with value tuples, we can actually pass in the state and the operation as state into the run operation method. And then we can deconstruct, and that's on line 8, T1, that's the state and the operation from the tuple by using the tuple deconstruction. And then we can execute on line 9 that operation with all its state. And because we have nothing accessed, and is guaranteed by the compiler that between line 7 and line 11, between the curlies, we cannot reach state outside the lambda, we will never get the closure allocation. And then if we decompile this code, this is what it looks like. And again, I'm going to zoom in a little bit here. And as you can see, again, we have this pattern of the compiler generated static field that gets assigned. So we are in the safe zone. So we have just saved 2 allocations, the display class allocation and the function delegate allocation. And you might be thinking, okay, but Daniel, really? I mean, all this complexity, mind-boggling complexity, just to get rid of 2 allocation, why would that even matter? Come on, seriously. And I have an example here where I work for a company called Particular Software, and we have a messaging library. It's called nService Bus, and in there, what it does is essentially nService Bus abstracts queues like Azure Service Bus, Azure Storage Queues, Amazon SQS, and some RabbitMQ. And it then executes the code of the custom code, including dependency injection, deserialization, and everything. And inside the guts of nService Bus, there is this concept of a pipeline. And the pipeline execution engine is basically the engine that drives executing the code of our customers. And this needs to be really fast. And in there, I did closure allocation optimizations. Again, my t-shirt, right? And here is what I actually achieved. And I'm going to summarize it. So by getting rid of closure allocations inside the nService Bus pipeline, we had a throughput improvement of 74 to 78% on a pure pipeline invocation. And all the allocations are gone. And let me quickly go back here. If we focus on the first line, we can actually see here that we have saved 20 megabytes of data, if I can do the math properly, because we got rid of all these closure allocations. And again, because nService Bus is going to execute code that will be like hundreds or thousands of times per second, these allocations truly matter. And as we have seen, can make things amazingly fast. And if you want to know more about the guts of the N-Service Bus pipeline and the closure allocation optimizations I did, I wrote a blog post on particular.net/blog pipeline and closure allocations. That's the second recent blog post as of the day of the recording. And go there and have a read, and feel free to ask more questions if you have any questions about that, also in the comment section on the blog post. But now you might be asking, how can we actually detect those allocations? Well, one way of doing it is you can use your favorite memory profiler and you watch out for excessive allocations of display class or various action and function delegate allocations. Another more proactive way of doing it, and I think it has already been mentioned actually in the comment section of the chat, what you can do is you can use the heap allocation viewer or the heap allocation plugin in the Rider. It's an amazing plugin, really helpful. Or if you're using Visual Studio, you can use the heap allocation analyzer. There, it's a Roslyn analyzer, and it will point out while you're writing the code where you have closure allocations, and you can get rid of those. And by the way, if you're thinking like, well, but Daniel, well, that doesn't really apply for my code. Well, there are actually many built-in .NET types that have overloads that accept an action delegate or a function delegate, and they're building more and more of these overloads, generic overloads that allow you to pass in state. And I think a fairly popular example is the concurrent dictionary. So I have here an example of concurrent dictionary of string when you use get or add. And again, if this is executed at scale, it actually matters. What we can do is we can use the state-based overload where we use a static lambda. We pass in all the state within a value tuple, we deconstruct it, and then we have access to the state, and then we never have a closure. So you can also leverage this with the built-in .NET type. If you're using, for example, concurrent dictionary. And that's a very easy win and a quick refactoring. The next one is pool and reuse buffers and larger objects. So again, an example of the Azure SDK. So I've already talked about the concept of lock token, the glorified GUID that is used to represent message completion, the acknowledgement of messages. And whenever stuff comes from the network, essentially those lock tokens, they're just byte arrays somewhere that are coming from the TCP stream over the AMQP protocol. And the SDK had this code in place where it actually created an array segment. And then what it did is it created a new byte array of 16 bytes, and then it used buffer block copy to essentially copy the data that is coming from the network segment into that newly allocated array. And as you can imagine, 16 bytes is actually a lot when this code gets executed at scale, hundreds and thousands of times a second. And this will occupy the garbage collector quite a bit. And therefore, we're getting more cheesy pauses. And because we do a lot of allocations, memory copying, it's also going to hurt the throughput. So how can we optimize this piece of code? Well, maybe some of you have heard of the array pool. And this was also one of the things where I was reading about the array pool. And I was like, okay, I've heard of the array pool. And the array pool, for those who haven't heard of it, it's basically a way to rent arrays. And renting arrays is more like closely like you would go to a car rental, right? When you go to a car rental, you basically say, hey, I need a car. I want to have a 4-seater, 5-seater, 6-seater car. And then you drive the car, you get one, and then you drive around. And then once you're done, you return the car to the car rental. And like a car rental, when you go and say, hey, I would like to have a, 3-seater car, probably the car rental company tells you, well, we only have available a 4-seater, or right now only a 6-seater. And the array pool actually kind of also works very similar, right? When you're asking for a 16-byte array, large array, you might not get exactly that. You might get more, but it makes sure that you have a big enough array so that you can store the data that you want to store, that you asked for, you can store it in that array. So that's how the array pool works. And I was like, oh, I've read about this array pool. Let's use that to optimize this piece of code. And I'm not making this up. I really fell into this pitfall. So I refactored this code and was just like, okay, array pool of byte, give me a 16-byte big array, or at least 16 bytes, right? That's the first line, and I'm renting from the pool. So I'm going to the car rental and say, give me that car. And then I do buffer block copy. And when I'm done, I actually return it to the array pool, because I need to tell it, hey, I'm done. Here we have it back, because I'm done using it. I'm done using that car that I rented from the renting company. So, and I was like, oh, cool, I have now used array pool the first time, and this is a great use case to use it. And then, of course, I started like measuring it, went through my benchmarking exercises with benchmark.net, compared it, and got shivers. Well, the code that I wrote was actually 226% slower than the original code. But hey, all the allocations are gone. Isn't that awesome? And I was like, is that a problem? Well, let's face it, if you are in a memory constrained environment where you might be able to trade throughput for memory, right? Then this is a perfect solution. You could be using it, but you have to be aware that the trade-off is, it's compared to the previous version, it's 226% slower. And again, the context is the key, right? But that being said, we can actually do better. And that's the next rule. So for smaller local buffers, we should be considering using the stack. How does that look like? When with the introduction of span of t and the stack alloc keyword, we can now directly allocate memory on the method stack, and that memory is going to get cleared when the method returns. So this is what I did then. So I did a stack alloc of 60 bytes. So it's going to allocate 60 bytes on the method stack. And then I'm copying the span, so the GUID, the network segment, into that stack allocated array. And then I'm creating a new GUID from this byte array. And you might be thinking, but Daniel, hold on a second. I know that GUID actually has an overload that accepts read-only span. Why are you even copying the memory? That's not necessary. You're absolutely right. In some cases, it's not necessary to copy the memory. I'm showing here this example because in the Azure SDK, there are quite a few places where there's some complex buffer rental around in the underlying MQP library, and sometimes the network segments need to be defensively copied, and also because it's not standard, some of these constructor overloads are not available. So that's why we essentially did copy the memory. But I'm going to also talk about how you can avoid copying the memory in the later in the remainder of the talk. So just that you know. And again, if we benchmark this, we can actually see that I'm going to summarize it. When we have this version in place, we are now 45% faster, and all the allocations are gone. So cool. We now really achieved more throughput, and we also got rid of all the allocations. By the way, stack alloc, that's very dangerous. Also, because if you stack alloc too much, you're going to get nasty runtime exceptions. And there are sort of rules around stack allocations that you need to follow. So I just recently saw someone on Twitter mentioning that the person made a pull request against one Microsoft library, and they stack allocated based on unbounded input that came from the outside world. So that's very dangerous, because what can happen is you get out of memory exceptions, and you don't want to do that. And I'm going to talk about that as well a little bit. So let me summarize all the rules that I've showed you. Again, link, try to avoid it on the hot path. Then be aware of closure allocations in your code. Pull and reuse buffers where you can. And for smaller local buffers, consider using the stack. There are 3 more rules here that I haven't talked about. So be aware of parameter overloads on methods that accept params of object array, because it's going to allocate an array. And where possible and feasible, use value types, but pay attention to unnecessary boxing. And of course, if you need to do allocations, but you can move it away from the hot path, it's always a good practice to just move away the allocations from the hot path. So now we're going to the potentially most complex but last piece of the talk. So the avoid unnecessary copying of memory. So these are the two rules that I have. So look for stream and byte array usages that are copied or manipulated without using span or memory, or replace existing data manipulations with methods, with newer overloads of the methods that accept a span or a memory. So span and memory, what is that? Well, with the introduction of C#, I think it was around 7.3, we got a span in place, and we got also over time, over the runtime versions, we got more and more APIs got spanified. And span, conceptually, if you don't know what that is, it's basically just a pointer to a memory location somewhere, and then a length that determines the length of the memory that you want to look at. So, and the span represents essentially memory on a simple conceptual level on the stack, and memory of T, the cousin, represents memory on the heap. So for example, span, you're going to use that when you have synchronous methods, inside synchronous methods. If you use async, task, value task, and these types of things where the state machine of the async stuff is involved, in these cases, you cannot use span unless you manage to separate the synchronous path from the asynchronous path, and then inside those methods, you can use span, but you have to refactor your code. Otherwise, you have to use memory, the cousin of span. And why is that such a crucial feature? Well, again, with the pointer, it can point to any arbitrary memory location. It can point to managed memory, unmanaged memory. And with the length, we can essentially have sort of a curtain that we pull in and pull out, and that's called slicing, where we can look at a piece of memory. So we can take, let's say, 1 megabyte of memory, and we can point to that start of the memory, and then we can say we only want to see 16 bytes. So we draw in the curtain so that we only see that part of the memory, and span actually makes sure that we can safely use this memory without going over the boundaries of this memory. So it's a super nice addition to the .NET runtime and also the language. And inside the event hubs library, there was a partition hashing function that was recently introduced in the event hubs client. So they introduced a new publisher type, and that publisher type has internally that partition key resolver, and the partition key resolver determines from input strings essentially a partition hash code, and based on that hash code, it's going to invoke stuff on event hubs. And that code was used 30 to 40% on the hot path when customers that were using that publisher type and using partition keys would invoke that. So on 30 to 40% of your event hubs interaction code, when you use that specific publisher type, that partition hashing function would have been used. And what is a partition? A partition, for those who haven't heard this term yet. Well, conceptually, and it's a very, very simplified version of explanation because in the interest of time, you can think of a partition as sort of a box with a label, right? So for example, if you want to clean up your book library and you want to sort them by authors, you can basically make a box that has, say, all authors that start with the letter A. And then you have another box where you say all authors that start with the letter B. So that's all more or less. And then you put all books into A, that start with A, into A. And all books where the authors start with B, you put it into the B box. That is sort of partitioning in place. And the hash code function that was in place in that event publisher type looked like the following. And in there was a compute hash method, and then compute hash method that is consistent, kept across all the SDK language versions as well. So that's the same in JavaScript or TypeScript. It's the same in C# and in all Python and all other supported languages of the Azure SDK. And then this generate hash code method takes a partition key. And again, that's user input. So that's a string of any arbitrary length. and then it checks whether it's null, and it returns null when it's null. Or then what it does, it essentially calls encoding UTF-8, and then it calls this getByte method. And here you can see that sometimes allocations and memory usage is very hidden, because you need to understand what actually getByte does. And the name, fortunately, already kind of reveals it. We're getting a byte from this string. And because we're getting a byte, and we have the .NET runtime has no way to essentially say, well, I'm going to give it to the pool, because they don't know what you're going to do with that byte array. You can keep it forever. You can keep it just shortly. So they have to basically create a new byte array every time you call getByte. And that byte array is going to be as long, as big, to essentially fit whatever you add into that string. So if you just put in an A, one character A in it, well, it's just going to be using whatever bytes you need to represent a Unicode character, right? But if you're putting in my name, which is already quite long, because I have Swiss German roots, we have long names, then, well, it's going to be a longer byte array, right? And again, customers can pass in any arbitrary partition key string, right? So essentially what we can say is this method will allocate based on the input, like little or a lot of stuff, a lot of byte arrays. And then we can see it on the method signature, on the compute hash method, that we're getting this byte array in. So this is an indication we can actually do better. And now everything is going to come together. And this is definitely also another time where you should sip on a coffee or a good tea, whatever your favorite beverage is, because we're going to now knee deep into this code, into the optimization. So this is the new version that I came up with. And here, let's focus on the first piece of the puzzle. So what we're going to do is we're going to turn the string into a span. Again, we want to use span so that we are on the high performing side, and we can leverage all the new overloads of the methods that accept the span. So we turn the partition key into a span. And then the next thing that we're going to do is we're going to ask how long is this string? And we're not going to use a getByte count, because getByte count actually needs to enumerate through all the characters in the string. We're going to use getMaxByte count, and that gives us an approximation of the length of that string. And that is essentially O of 1 semantics, and that's much faster than using a getByte count. And then the next thing, we're going to apply a pattern that is called overrenting. And what we're going to do is we're going to define an arbitrary stack limit. And this is on line 7. It's 256 bytes. Why do I say arbitrary? Well, there is unfortunately not a lot of guidance around how much we should be using. We could be using 512. We need to be in the safe side so that we are not running into stack overflow exceptions. And if you look into the .NET runtime source code, you see various stack limits being defined depending on the use cases. The .NET team is working on some guidances. I have also linked in the README, should you be interested, an issue from the .NET runtime repository where you can read up about this, and there will be more guidance. I here chose 256 as a safe limit. And then what I'm going to do is I'm going to check whether the partition key byte length approximation is below the stack limit. If it's below the stack limit, I'm going to stack allocate the whole stack limit. So I'm overrenting. And I'm going to talk about that, why that's actually good, a little bit later. And in the other case, when it's bigger than the stack limit, then I'm going to use the array pool, because I know that in the byte array length where it's actually efficient to use the array pool, the renting the car that we talked about, right? And then what I'm going to do is I'm going to use the getBytes method where I can pass in the span and I pass in the buffer. So now I'm in control of the buffer. It's no longer the .NET code that is in control of allocating the array. I'm saying, hey, here is a buffer that is large enough that you can write into. And I give it to that method. And then what's going to do is it's going to write the bytes of that span into that hash buffer. And what's even better is it's going to tell us how much bytes it has written. Why is that important? Remember, I told you span is basically a pointer to a memory in the length. And now because we have essentially overrented a large byte array, but we only write parts of it, we know how much we actually have written, and then we can draw in the curtain and we can slice the span to the length of what we have written. That's what we do on line 19. And then at the end of the day, we need to check whether we actually got something from the array pool, and we need to return it when we are done, right? Because we want to be good citizens. And by the way, you might be wondering, why isn't he using a try finally? Well, at that time, we actually also made the trade-off. We talked about several things that can go wrong here, and we came to the conclusion that it's not worth adding a try finally because it would make the code size bigger. That also has an impact on the performance of this code. So we decided not to do it. So we returned the buffer, not in the try finally. And then we passed the read-only span. So that's the only change that we do to the compute hash method of byte to that method. And now comes the most important part, because we are overrenting. And again, we're overrenting because we're saying we're getting an approximation and of how long the string will be, but we don't want to use that to like stack allocate different sizes. We're saying let's always have the same stack memory. And then we're saying, but hey, do this optimization, and that's here. It's called skip locals init, where we essentially tell the compiler, do not emit the locals init instruction. And what that means is by default, what the .NET runtime does, it always clears the memory that you're asking for because it wants to be safe. There shouldn't be any garbage in there. And it does that normally, but if we tell it skip locals init, we add that attribute, it's not going to emit that clearing of the array, and then we're not paying the price to go through clearing everything, which is the majority of the cost when we stack allocate for larger arrays in this specific code here. Then it's actually more performant to only stack alloc always the same stack limit than trying to have various sizes of stack allocations and whatnot. And that's essentially the pattern of overrenting that I mentioned with the skip locals init. Cool. Now, if we measure this, again, we have to measure it because we need to know how we are doing. And if we look at it against various sizes of inputs that are below the threshold and above the threshold, what we can see is we get 38 to 47% performance improvements, and all the allocations are gone. So the overhead for the GC will be less by having this optimization in place. Cool. I'm summarizing the rules. Look for stream and byte array usages that are copied or manipulated without using span or memory. Replace existing data manipulation methods with newer span or memory-based variants. And I haven't mentioned that one. Watch out for immutable read-only data that is copied for no added value. And then get optimize those things in your code, and then things will get faster. I'm going to summarize here all the rules, and I'm just showing it. I'm not going through it because it's way too much, and I'm showing it here as a reference, but it's also available in my GitHub repository that I share later. And before I wrap up everything, I want to quickly throw out a challenge for all of you, and we might also be talking about this later in the Q&A section with Martin and Khalid. So the original compute hash method, we actually stumbled over a bug in that code, and I have quickly added it here to the slides. We found it because I made these optimizations, and then some tests started failing, and we found the bug in the compute hash code in the original one. Can you spot it? Do you know what it is? Think about it, and we'll have a conversation about it later. Cool. Let's wrap everything up. First of all, I want to tell you that, again, some of these optimizations, they're kind of a little bit esoteric, and they should only be applied on the code where it really matters. And first of all, tweak the expensive IO operations first. So when you have expensive database calls that are taking hundreds milliseconds, thousands of milliseconds, optimize this piece of code first. So a SQL statement that you can make faster, or entity framework lazy loading, or whatever OR mapper you're using that has lazy loading enabled. And if you can tweak those types of things, you're going to have tremendous wins in your code. And only if you have basically optimized these pieces of stuff, then start optimizing and thinking about these lower level performance optimizations. And then you can leverage those to make your code even faster. And most of the time, those thinking about your expensive IO paths can be combined with these optimizations to make things really, really fast. And just to put it into context, I've talked to the team, and the team said that overall, all the performance optimizations that I did and the designs that came out of it made an increase of 8% in overall publishing throughput, for example, on the Event Hub release, and 3 to 4% on the Event Hub processor code. And who wouldn't want to have an 8% or 5% faster car, right? Well, except I'm only allowed to drive a Kia Ceed. But yeah, I guess I just want to say that I think if you can squeeze out 8% performance out of your code, that's a lot, especially when the code is executed at scales. And again, I want to drive this home. The context of the code is important. Think about the assumptions that the previous people that wrote it, or that might be even yourself, have made. And how does this piece of code going to be executed? Hundreds, thousands times a second. What is the throughput and memory characteristic of this code? And then only when you have the answer that it really is code that is executed at scale, apply these rules that I have shown you. Otherwise, don't even bother and stick to the stuff that you're already familiar with, and don't even try to think about these performance optimizations yet. Okay, thank you very much. If you want to reach out to me, if you have questions about performance optimizations, async, concurrency, whatever, reach out over me. Twitter, it's @DanielMarbach, and I would love if you follow me on Twitter. And if you have questions about some other stuff that you want to privately reach out, or for example, also answer with us, reach out to me over daniel.marbach@particular.net, and I wish you happy performance optimizations.
All right. Yay, we did it.
Yay, we did it. You survived.
Yeah. So you put a challenge forth towards us, so you need to go back to the slides. So
sure. So you want to directly talk about the challenge? I see.
Yeah.
I think most people, including myself, were still trying to parse it, so it might be good to put it up.
Yep.
Okay, here we go. Cool.
Is there any way you can zoom it too?
Yes, I can. Here we go.
There we go. I think I found the problem. We're dealing.
Well, you already know the solution, right?
Yeah, we're dealing with beef instead of chicken. No, I'm just joking. It says dead beef there for some reason.
No, I was thinking there's a good bit of this method being commented out, so I think that's the reason.
There's no return value. Yeah, of course.
No, so actually the problem is in the code that I'm showing on the screen. Okay. And it boils down to we need to have, and again, context about the code. We need to think about what is an important characteristic of a hash function, as an example.
Mm-hmm.
And not the cryptographic hash function, but here, what is for a partition key hashing function? What would be an important characteristic? Martin, you know that because you have dealt with hashing a lot, right? Probably.
I have had the worst bugs thanks to hashing even.
Does that have anything to do with uniqueness, the ability to generate unique value?
As an example, but that's not the problem. It's more in the area of consistency.
Okay. Martin, do you
All right,
have
let's keep that one up for a little bit. Maybe someone in the chats can spot the issue.
Mm-hmm.
Yep.
And let's go through a couple of the other questions that we had.
Cool. Yeah.
I think the most recent one that we had in the chat, and it's probably a good one to tack onto the list of rules that you had on the slides, is there like an analyzer or a series of tools that could help you with discovering whether you are not adhering to one of the commandments, so to speak, that you had on your slides?
Well, the only ones that I'm aware of is essentially the heap allocation viewer that I showed already on the slide, and of course the best practices that the .NET team puts into some of the Roslyn analyzers. So, for example, for stack allocation usages, there are some sort of built-in best practices that you get highlights in your IDE, in your favorite IDE. When using those, I'm aware of those, but nothing else right now. Maybe some tools with like ndepend or whatever have some additional rules, but I haven't used it. So I kind of have conceptualized those rules, and I'm trying to watch out for them when I, for example, review pull requests. But again, I'm not going to pick out link queue all the time. And as a matter of fact, I always start with the link version first, because that's the easiest for me to write. So I write some tests. I write the link version first, using group by and whatever, right? And then once I have everything working, passing the tests, then I start doing more iterations on making it faster, making it less allocation heavy, and all those types of things. So I always start with the easy code.
Yeah, I also, in relation to link, I like the tip of having static lambdas there, because then at least you know that you're not accidentally capturing things that you shouldn't be capturing.
Yeah, exactly. Yeah. And I have to unlearn to say link queue. I always say link queue. I have to say I've been made aware of this, because I have to like hammer it into my brain to say link.
Hey, it sounds special and exotic, so don't change the
Thanks,
world.
Khalid.
Yeah,
thanks.
You know, you mentioned something really fascinating during this whole talk, the phrase hot path, right? And like you said, you may be triggered by looking at code to know that there's going to be a performance issue with the particular approach, but it doesn't always mean you need to optimize it, right? Like,
correct.
So when you're doing investigations, like how do you take profile, like how do you discover something is a hot path? Like what tools do you use to determine?
Okay.
That kind of thing?
Yeah. So I have used a lot .memory and .trace. I primarily use these tools because I'm very familiar with it. And then what I essentially do is I create some, for example, for the Azure Service Bus optimizations. I did a lot of body memory optimizations as well. I essentially created a very simple example that uses the SDK directly. For example, adds thousand messages into a queue and then just feeds from it. And then I have essentially console read lines where I say attach debugger now, or sorry, attach tracing tool or memory tool now. And then what I do is I run through these examples, and then I sort essentially by memory usage. I sort by the hot path. I don't remember how it's called in .trace, that flame icon thingy. I sort by that, and then I look into it and say, oh, there is some dictionary usage, or there's lock contention, and I start like optimizing stuff like that, because that's a typical, I basically simulate a typical usage scenario that is realistic, how you would see it in your production code, but in a very, very constrained environment, so that I have everything under tight control, so that I'm not basically looking because sometimes if you have too much other bloating code around, you don't even see where things are actually affecting your throughput when you just want to focus on one single piece of the whole stack, right? And again, if you're doing the larger wins, then you need to look at your IO path, and that's usually the whole stack where your HTTP calls or database calls or mapper, enumeration, materialization, whatnot, right? But of course, these are performance investigations for specific user scenarios of a specific library. Then it makes sense to really isolate that piece of the puzzle.
And yeah, I mean, I guess the follow-up question to that is like, once you've isolated, once you've kind of optimized things, like how do you know when to like stop optimizing? Like any good artist, you kind of put the last paintbrush on the painting. When do you stop optimizing?
Well, tongue in cheek, my internet switches off around midnight, and then I have to go to bed, and then it's time to stop optimizing. No, it's I can highly recommend this, by the way. If you're a person that always stays up late, it's kind of healthy, because when you don't have internet anymore and you can't Google stuff or Bing stuff anymore, you're like, I'm done with this, going to bed. No, I'm kidding. Well, I think it really, again, it's to think about, there is at some point, I guess, for a specific piece of code, things are getting so complex that you're starting to go from, we saw it in the last example, from essentially 2 lines to, what was it, 20 lines, right? It's like, it's a 10-fold increase of complexity. And that means everyone that is looking at that code has to also understand it, and you have to maintain it over time. And then the question is it worth going that far? And again, for me, it's also an iterative approach. Do a quick win, let it sit. Measure it again, come back to it again at some point, do some more optimizations if you find out it's still shining on the hot path there, and then do some more optimizations. Otherwise, let it go. And again, some of these optimizations I have done over months and years against the Azure SDK.
I mean, that's a really good point. It's like sometimes when you're doing investigations for performance, you're not going to find it immediately. It's going to take a lot of time. And I'm really glad you said that, because I know when I've run into performance issues, like it's typically in a bad situation and I'm like under the gun to fix it. But when you take a proactive approach for optimizing, it can take a while to kind of get to where you need to get. So
what I also tell my peers is I want people to at least think about it. And thinking about it doesn't mean you have to spend hours on it, but just basically look at it and say, okay, is this going to be executed hundreds of times? Could we do some more? And if the answer is yes, we could, but we don't have time, at least to have thought about it the first time, and then write it down into your architecture decision log, code decision log, whatever you think of it. Say, hey, we thought about it and we decided not to optimize it. And then someone else, or maybe it's you, later down the line can say, oh, you look at the code and say, what were the assumptions? Well, we knew it's not ideal, but we have documented that we knew it's not ideal and the trade-offs we made. And then you can build on top of that knowledge and make it better over time.
Yeah. Can I summarize that as being performance aware whenever you thread through your codes? Just like in the US, you would see these signs saying "Be bear aware," even though you're probably not gonna see a bear during your walk, but always be performance aware.
Dude, I see bears all the time, Martin. I don't know what you're talking about. No, I'm just joking. We do have a couple answers in the chat. The QWERTY says, is it that the last 11 bytes might be omitted?
No, that's also not. Maybe there are some other problems, but actually this piece of code, it has also been served. It's also used in the service. So the algorithm itself is executed billions and billions of times in production, so that I don't think that's a problem. Now I can give the solution.
Yes,
so one of the things that is kind of key is, regardless on what operating system or runtime you're executing, for the same input, it should return the same hash code, right? And that's an important characteristic. And the problem is we're using bit converter to int32, and bit converter is essentially endian aware. And what it means is, depending on the endianness of your system, it's going to return little endian or big endian. And then what that means is, so if you execute the same hash code function for the same input on a system that is little endian, you get a different result than on a system that is big endian. And for a hash code function, we want to make sure that we're getting the same result. And the solution is that we're using, for example, binary primitives dot read uint little endian or big endian. So basically make a decision what is the right endianness, and then use that, and always the same. And that was the the thing that we discovered. Luckily, it wasn't shipped yet, so we could still fix it during development time. So that was great timing, I guess. And as you can see, just doing performance optimization on this code actually discovered a very interesting bug that would have been very difficult to fix when it's already behaving that way in production, I guess.
Good point.
Yeah.
I think that's also a nice segue into probably our last question of the day. Do you think that the language, whether that's C# or VB.NET or F#, could be better in terms of helping people to keep them from making performance mistakes?
That's a very good question. I think, ultimately, I think the answer is yes, I think, but I also think that they're already doing this. So for example, I mean, some of the link optimizations, they're actually doing it in the runtime. So some of the problems that you might have heard 4 years ago, 5 years ago about link queue, they might no longer be true today with .NET 7 or even just .NET 6, right? So things are getting better and better. And also essentially the Roslyn and also the JIT compiler, they're aware of a lot of, for example, also devirtualization calls, and they can discover these types of scenarios, do loop unrolling under the covers and all these things. And things are getting better. And I hope that's just going to increase getting better. I do think for those types of low-level code optimizations, you will always have to have specific knowledge. But I think that the amount of specific knowledge that you have to have will basically get smaller and smaller, hopefully. But I mean, we know that things also evolve. So for example, recently the .NET team started talking about the concept of green threads. And that will be another concept that comes into the runtime. And then you have to make even more trade-offs about deciding, should I be using the classical TPL runtime stuff? Should I be using green threads? When is green threads important? So I think with newer features, there is always a period of time where you have also more decisions to make. And then it's good to be informed so that you can actually make those trade-offs. And of course, conferences like JetBrains, they actually help you to stay informed because you can benefit from the knowledge that people have built up for you and summarized.
Yeah. I mean, to add to that, even that question, it's like the .NET teams, like test cases are probably decent, but once a feature kind of gets into the wild and the whole community starts using them, I think that's kind of when you actually see the ramifications of any technical decisions, right? Layla famously said today, she's like, I'm tired of being on the bleeding edge. Like sometimes waiting to see how these things will come out is really good. But yeah, on that note, Daniel, this is a great talk. Yeah, I would have never got the bit converter endian thing. I'll just be honest with everyone on the stream. So
it took me also a while. And I had to go back to basically my engineering studies. Like, how does this work again? And I still can't like fully say that I'm aware of all the endianness and problems that are there, as I'm definitely not on that level.
Well, next time you do a talk with us, make sure you bring an easy sample that I can get so I can feel good about myself. But on that note, again, thank you. That was a great talk. You're always welcome here at JetBrains. We love to hear you talk. So thank you so much.
Thank you,
Have
Daniel.
a nice day.
Yep, you too.
See ya.
Bye-bye.
Martin, I guess this is the end of the day, huh? It's really dark.
This is it. Should we try like a high five? Yeah, that's the side. Yeah,
we did it.
Done. Well done. Well done.
Yeah, I want to thank Matt Ellis, Rachel, and obviously all the speakers that came today. If you're still watching, which there are a lot of people still watching, thank you for sticking it out the whole way. Get some rest. Tomorrow is day 2 of 3 days of JetBrains.net days. So we'll see you then. Right. Good night,
Right.
Martin.
See you,
Bye,
everyone.
everybody.
Have a good night and a good day.
Bye.